So can we start? Yeah, write fast, please. I'm write fast. Yeah. Now, first thing as I've said first, let's look for what? Complementary solution. Yes or no? Looking for complementary solution, I can say that CS here. Looking for CS, I can say that this one is what? M squared minus 3m equals to 0. Yes or no? And so from here, I can say that here, m, open bracket, m minus 3 equals to what? 0. Yes or no? Yes or no? And I can say that here, m is equals to what? 0, or m is equals to what? 3. Then what is my solution? So I can have y is equals to what? C1 exponential 0 plus what? C2 exponential 3x. So this one now give us what? C1 plus C2 exponential 3x. So I've gotten the what? I've gotten the complementary solution. Let's now look for what? The particular solution. So now what do I have here? I have 9. I can say that what do I have? So I can say that y is equals to what? K. So how many times am I differentiating twice? I know that y prime y prime will give me 0, and y prime will still give me what? 0. That's therefore to put it as k, because if I put it as k, I think everything will be what? 0 minus 0, which is not valid. So let's put y as what? As ax. Then y prime here should give me what? A, abi now, and y double prime is 0. So if I put everything back here, what do I have? I have 0 minus 3a equals to 9, and a is equals to what? Minus 3. Okay, let's do it like this now. Whenever, let's make it a lot down. Whenever you want to substitute your arbitrary constant and it's giving you 0, 0, 0, 0 something, what would you do? Change that thing and add x to it. So you understand what I'm trying to say like that? For example, here, I know that if I left it at 0, differentiating of 0 twice will give me what? 0 minus 0 equals to 9, which is not an equation. Now, a way to avoid that is to what? Set your y to something that has what? X. And at the end of the day, what do you have? I have a to be minus 3. What will be my final solution here? My final solution will now be what? C1 plus C2 exponential 3x minus what? 3. Alright, let's do one more example. Well, it shouldn't be 3x in here, because ax lending me by not ordinary a. So x you are there. Okay, another example. So let's look at this now personally. So here we have 2 the square y. Okay, I'm coming. 5 dy dx minus 3y equals to what? 6. Yes? Huh? Okay. Yeah, the reason was because here I had k, and here I had kx, ex. Now the reason was because if you say this one I left this one as ordinary a, by the time I will differentiate it twice, I will not have a definite solution here, because it should be 0 minus 0 equals to what? 9. So I get into a way to avoid that is by adding x to that one here. You get good. So now I want to solve this one. So we'll solve it, but we'll be fast. Okay, started at 29. So we are stopping at 32 with 29. We all right. So let's find CS. What will CS give you here? CS will give you what? 2m squared plus what? 5m minus 3 equals to what? 0. So what are the factors? This is 2m squared plus 6m minus m minus 3 equals to 0. Yes or no? Then you have 2m. What do I have here? M plus 6, right? M plus 3 minus 1. What do I have here? M plus 3 equals to what? 0. I want to get that, please. Then for me, I can have 2m minus 1 and also m plus 3 equals to what? 0. Then here your m is equals to 1 over what? 2, or m is equals to what? Minus 3. Are we together? Are we together? And so from here, minus 3. So from here, so what is my y? So my y in this case will now be what? Yes, ma'am. I factorize now. If I factorize this one, this is what we have. 6m plus minus m will give me 5m. So now, so from here, as I was saying, what is my y, Jerry? So my y will be what? C1 exponential half x plus what? C2 exponential what? Minus what? 3x. Are we together? Okay, so from here, I've got my complementary solution. So let's now look for what? Particular solution. My PS here. So for me to have my PS here, I think if I differentiate here, I cannot have undefined. I cannot say that A or y is equals to what? A. So y prime here is equals to 0, y double prime here is equals to what? 0. Have you now? So if I put this 3 inside this space, I will end up having minus 3a is equals to what? 6. And a is equals to what? Minus 2. That what will be your final answer? You now have C1 exponential half x plus what? C2 exponential minus 3x minus what? 2. Do you understand? Huh? Okay. Let's increase the heat of the game. I said I want to increase the heat of the game. I said we're not going. Why isn't this people? That's next one to look at. I don't want to look at now. All right, can we start? Are we sure? Let's start. So from here, what is my CS? CS is what? 2y double prime, no? 2m squared minus what? 11m plus what? 12 equals to what? 0. So let's factorize this. 2 times 12 is 24. So that is 2m squared minus 8m minus 3m plus 12 equals to what? 0. Yes or no? What do I have here? I still have 2m open bracket what? m minus 4 minus 3. What do I have here? m minus 4 equals to what? 0. Then you have your 2m minus 3. Then we have m minus 4 equals to what? 0. I'll get one apprentice like that. Now from here you can answer that m is equals to what? Minus 3, sorry, minus 3 over 2 or then your that will give y is equals 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 y is equals. So now I've gotten my CS. Now the next one I'm moving to is what? How to get your what? PS. Now how do you get your PS in this case now? Now PS, now the PS in this case now, you find out that this one is very, very different from the ordinary numbers that we're doing. I'm getting it. Whenever you have a linear equation like this, very linear, you can have y is equals to ax plus what? Plus b. I guess my parents like that. So from here, say if I differentiate, so y prime will give me what? A, have you now? And y double prime here should give me what? 0. Let me put the 3 of this one inside this equation. What will I have after I'm putting in that? So I have 0 minus 11a, have you now? Plus 12 open bracket what? Ax plus what? Plus b. Everything equals to what? 3x minus 2. From here, what do I have? I have minus 11a plus what? 12ax plus what? 12b. Then I can carry this one together. Don't forget, this is 3x minus 2. Then carry this one up. What do I have here? If I carry this one up, what do I have here? I would have 12. Let me roll this piece. I'll have 12ax out together plus what? 12b minus 11a equals to what? 3x minus 2. So comparing coefficients, I can now say that 12a is equals to what? Is equals to 3. Yes or no? And I can say that a is equals to what? 1 over 4. So if a is equals to 1 over 4, so I'll be left to find b. Now can I get b here? I'll have 12b minus what? 11a is equals to what? Minus 2. From here, what do I have? I have 12b minus 11 over 4, which equals to what? Minus 2. Then if I take this one to the other side, then I should have 12b equals to minus 2 plus, let's say minus 8, no, minus 2 times 4 plus 11 over what? 4. Do you understand what I did here, please? Eh? Okay, good. Then for me, I have 12b to give me what? This 8 minus 11, which is what? 3 over 4, right? Happy now? Then if I divide both sides by 12, what do I have here? I think that should give me 1 over what? 16. Right? That is, eh? How did I get? How did I get what? How did I get E? Okay, I just compared coefficients. No, that I have X here and I have X here. Compare the coefficients. Any questions? Any questions? Any questions? Any questions? Okay. Why are we using KX? Yes, that's another good question. This one I'm using AX plus B is because what I have on the other side is what? Yeah. Are we together? Yeah, now it's already here. Are we together? Now the last, I think, am I correct? Is my B1 over 16? Is my B1 over 16? Okay, good. So I've gotten A and I've gotten B. So what will be my, don't forget that Y is equals to what? AX plus B, which is what? 1 over 4x plus what? 1 over 16. So what's my final answer here? My final answer is what? Y is equals to what? C1 exponential 3 over 2x plus what? C2 exponential 4x, exponential 4x, 1 over 4x, 1 over 4x, 1 over 4x, 1 over 4x, 1 4x, 1 4x, 1 4x. I hope you understand, please. Okay, let's get another question, then we move. I'll move to another caliber. This is how far they have helped me. And it's blacker than some people's faces. Queen among Kulova. I'll take that, please. Okay, good. Don't worry, we enter Laplace very soon. But I want to take all these things one by one so that you'll be able to what, understand and be able to what, attempt them yourself whenever you see it in exam. I'll get on a trying to say. I get on trying to say, please. It looks too small. Okay. So now, are you ready? And let's look at 6y prime prime plus 4y prime minus 2y equals to 3x. About why 3x minus 2 again? 3x minus 1, Joe. I'm not advancing anything. It's still the same thing. Still the same thing. I did not advance anything. I will take that. So from here. So let's find the word CS first, right? What is CS? CS will give you what? 6m squared plus what? 4m minus 2 equals to what? 0. Divide everything by 2, straight up. What do I have here? 3m squared plus what? 2m minus 1 equals to what? 0. I think it's better like this. And from here, I can now have what? 3m squared plus what? 3m minus m minus 1 equals to 0. Are we together, please? Are we together, please? Please. I didn't expect you guys to do. So for me, I have what? 3m. Then what do I have here? M plus 1 minus 1. What do I have here? M plus 1 equals to what? 0. And for me, what do I have here? 3m minus 1. Open bracket, what? M plus 1 is equals to what? 0. Yes or no? Yes or no? Yes or no? Good. And from here, what's your m? Your m equals to 1 over 3 or minus 1. And because of this case, I can now say that my y is equals to what? C1 exponential 1 over 3x. Abi now? Plus what? C2 exponential what? Minus x. How getting that? Then so from here, okay. Now let's not get our written on this part here. Okay, so let's now get the particular solution now. PS, are we together? So to get the PS now, what do I say? Y is equals to what? Y is equals to what? AX plus what? AX plus B. So Y prime is equals to what? A, and Y double prime equals to what? 0. Plug everything inside this space. What do I have? I have what? I have 4A minus 2AX minus 2B equals to 3x minus 1. Yes or no? Yes or no? Eh? Okay, good. So from here, if you want to compare coefficients, what do I say? I can say that this one here will give me 4a minus 2b equals to minus 1, and at the same time here, minus 2a is equals to what? 3. Yes or no? Yes or no? Yes or no? Then from here, and I have a is equals to minus 3 over 2. And if you put that here, what do I have here? 4 open bracket minus 3 over 2 minus what? 2b is equals to what? Minus a. Are we together? Are we together? Let's talk. And from here, what do I have here? Minus 6. Yes or no? Minus 2b goes to minus 1. Take this one to the other side. I think I should have minus 5 over 2 equals to what? B. B. And for me, I can have my y. A general solution. y is equal to Let's continue. So we said our complementary solution is so we have CS is equals to what? M squared minus 2m plus 1 equals to what? 0. So can you just tell me the factor straight up, please? Don't 1, 2, 3 is 1, so m is equals to 1. All together? Yeah, I know it's twice. But m equals to 1. So from there, twice. So we have m here equals to the answer, and then from there, what will be my general solution in this format? Thank God I've cleaned. So that will be what? C1 plus C2x, open bracket, what? Exponential what? X. Yes or no? Now this time around, so I've done my this. Then let's now look for what? My particular what? Solution. So how does my particular solution looks like? So I have, whenever I have anything exponential here, what form does it take? It takes what? K exponential ax. So now, so I can say that here, y is equals to what? K exponential what? Now this one won't be ax, but it will be what? 4x. That's smart of you guys. I love you. Now from here, let's differentiate. Y prime here will give me what? 4k exponential 4x. Then y double prime here will give me what? 16k exponential what? 4x. Are we together? Then let's substitute everything back inside this equation. So what do I have? I have 16k exponential 4x plus 2 open bracket what? 4k exponential 4x. Are we together? Plus what is y? Y is equals to what? K exponential 4x equals to what? 3 exponential what? 4x. So I have here to be 16k exponential 4x minus what? 8k exponential 4x plus k exponential what? 4x equals to what? 3 exponential 4x. Then from here, 8 minus 16 is what? 16 minus 8 is what? 8 plus this one is going more, 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 I'm running wa. You have not seen anything. That's right. Lazy people. But you guys are sitting down and you are still complaining, no high. Please do get it like that. Eh? Now, now this time around, listen, we have been making it look. Eh? Why did I use 4x? Because that is the same power that I have with my question here. She got my pencil again. Okay. Now we have been saying all of this one since morning. Eh? Oh, that stinks. Okay, now we have been doing shortcuts. We are, I'm doing Mathathon now. I've been doing shortcut. Is this not shortcut? Wait, is this not shortcut? How is this guy? I want to do long cuts next time now. Aja. Let's continue, Joe. Okay, I'm obstructing you. So now this time around, let's look at this. So you want to solve the square y dx squared minus 4 dy dx plus 4y equals to what? 3 exponential 2x. This is what we want to solve next. How many questions have we solved so far? We think we're 20 now. And me, I'm 15 questions. Yeah, let's look at that one, Jerry. Now, first of all, can you guess what type of solution it will be without solving? Look at that equation. What kind of solution will it be without solving? Is it form 1, form 2, or form 3? So from 3, from 44, it's from 2. Because if you factorize this one, by factorizing this one, what will you have here? M squared minus 4m plus 4 equals to what? 0. This is your what? CS. Then from here, if you work with this one, you have what? M minus 2 all squared equals to 0. And 2, and then. So from here, your solution is what? Y here will now give you what? C1 plus what? C2x, open bracket what? Exponential what? 2x. So that's my solution there. I've been doing shortcut. Your body is... It's not shortcut. How is it from 2 now? If you can factorize that one. I've been not factorize again. I see you now. You gotta follow talking. Nessun everything there. What do I have there? 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 Exponential, exponential what? 2x. Are we together? Equals to, what do I have there? Equals to 3 exponential 3x. I see what I'm saying. 2x. I see what I'm saying. I see what I'm saying. What am I? What are you saying? What am I? What are you saying? What am I? What are you saying? What am I? Let's change. I only have. You can't. The thing is that in order you can't readily have 0 in your what as a particular solution. It's very rare for you to have 0 as a particular solution. Now this time around, the same thing I did to that one is what I'm going to do here. I'm going to add x to this one. So if I add x to this, I can have what? Y goes to what? Ax exponential what? 2x. Then by differentiating this, okay, I think I will have product to Rabi, u and v. What is what? From here, if I differentiate this, what will I have? So u dv. I have 2ax exponential 2x plus what? Plus a exponential 2x. Yes or no? What y prime give me? This one is what? U. This one is what? V. What do I have here? 4ax exponential 2x plus, if I differentiate this one, this will give me plus 2a exponential 2x plus what? 2a exponential what? 2x. Abi now? Eh? Abi now? Wait there, yeah. Do you understand what I did here, please, to be sincere? No. I am talking. Now what I did here was product through. We will talk. What I did here was product through. Write u, differentiate v. If I write u here, this is it. If I differentiate this one, I have what? 2 exponential 2x plus write v. If I differentiate this one, I have what? A. Then this one here, product through again. Everything is u, everything is v. You have not know now. So now put everything back inside that your equation, Jari. So what would I have in that my equation? So I will have 4ax exponential what? 2x. Are we together? Minus what? 4. No. Plus what? 2a exponential 2x plus 2a exponential 2x minus 2x minus this one here and this one here to be continued. Okay, I think the thing that they did here was they put x squared here. But to draw a conclusion to that part, I want to move on. Was after this, after we have done the last part, we now have probably 2 solutions or 2 differential equations that will combine all of them together. Which one is her? Why are you saying her now? Is it possible for you to come out every year? If you, yes, now. Okay. I'm going to buy this one called DJ Kumaloli. So now we have talked about exponential x. Are we together? Are we together now? So let's now move on to the signs. Sign of course. So now look at this differential equation. Okay, do you know what? Let's make it fast. I believe all of us know how to solve complementary solution now. So let's now omit the complementary solution. So let's be solving for the what? Particular solution. And that's what I want us to master. From here, you have what? 2 dy dx plus what? 3 dy dx minus 5y equals to what? 6 sine what? 2x. So this is what you want to differentiate, yes? No, we don't finish that one. What they did in the book was, after they put x squared in this place, and you guys are tired. So if you want to go and try it at home, and just put what? Put x squared in this place, and by the time you differentiate, you get your answer. Okay, it is squared, yes, it is squared. Yeah, the reason is when I put x, I think it was still cancelling out again. You get, so that you guys don't get bored. So let's continue. So now here, I'm not doing the complementary solution. So whenever you have anything sin x, this one is not finished. Yeah, I said to be continued. Yeah, 2x, yes. It's in the question now. That's the question we are solving. Is this not the question we are solving? Okay, I wrote 3a. Okay. I don't know what you're talking about. So please, if you want to go and complete this at home, the solution to this is that this here you have x squared here. Yes, you have x squared. Probably go and try it at home. The final answer is what you get when you go and try it at home. I don't. Whatever answer you get at home is what is correct. Fine, boy, look here, just continue work. So for me, I look up. So whenever you have a sine bx, listen, no, or a cos bx, or you have the combination of what? Sine and cos. I get what I'm trying to say. Yeah, it's 3 things. Whenever you have a sine bx or a cos bx, you have the combination of 2 of them. What will be your y? Your y will be what? A sine bx plus b cos bx. So my particular solution here cannot be y is equals to, what this one be? It should be a sine 2x plus what? B cos what? 2x. I'll get some trying to like that, please. Even if it was only a single sign that was here, this is what you will have. I get some trying to like that. So from here, y prime here, what y prime here give me? As 2a cos 2x plus what? 2b, no, not plus here, minus 2b sine 2x. Y double prime here should give me minus 4a cos 2x, right? Minus 4b sine 2x. Yes or no? I said that whenever you have a single sign or a cos or combination of sine and cos, your particular solution will take the form of what? A sine plus what? B cos. But what is the sign here? The sign was 2x. That's why I added the 2x to both of them. So you get? Now so from here, if you differentiate this one, this is what you have. Now so from here, so let's now substitute away. Substitute everything back inside where? This place. CS, go and find CS on your own. And this one here, let's go. So what do I have here? So let's make it very fast. I'll multiply everything here by 2. So that will give me what? Minus 8a sine 2x minus HB cos B cos 2x cos 2x cos 2x cos then So now let's take the 9, 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 let's take the cos 2x minus 13b sine cos 2x equals to 6 sine 2x. Are we together, please? Then so from here, if I say I want to compare coefficients, I'll be now. So if I say there's no cos here, so if I say I want to compare coefficients, what will I have? I will have minus open bracket 13a plus 6b equals to what? 6, and the other one will give me what? 6a minus 13b equals to what? 0. So if I want to open this one again, let's say I have minus 6a minus 13b equals to what? 6. What can I do here? So if I say I want to subtract both sides, yeah, if I subtract both sides, nothing can cancel out now. Have you know? If I subtract both sides, 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 equals to what? Half. Okay, minus 6, so minus half. So if we have gotten that A, then what next is it that we are looking for again? What is it that we are looking for again? We are looking for B. So where can I put my B? And put it inside this place that will give me 0. So I have here to be 6 open bracket minus half minus 13b equals to 0. So if I have minus 3 equals to 13b, are we together? And b is equals to what? Minus 3 over what? 13. So what is my y now? My particular solution will now be what? What is A? Minus 1 over 2 sine 2x minus 3 over 13 cos what? 2x. Then you can just add it to your complementary solution. And then within this complementary solution, that will not take time. Yes, that's the answer. Jesus Christ. Wait, calm down. Oh, wait. What? If I shoot, my phone. Yeah, she don't say so quick. What a journey. Oh, God. All right, so let's come again, please. This time around, it should be what? 6a minus 13b equals to what? 0. So for me, I think the only thing I can do is to what? I think, which one are we eliminating? Let's eliminate which one? A or B? Which one are we eliminating? Eh? Eh? Let's eliminate B. For me to eliminate B, this is equation 1. This is what? Equation 2. That means I have to multiply this one by 13. That will give us what? Minus, wait, if I multiply this one by 13, this one by 6, equation 1 times 13, that will give me what? Minus 169a minus 6 times 13 should be 78. 78, 13 times 6 should be what? 78. Then 2 times 6 should give me what? So that will give me what? 36a minus, what is this now? Minus 78b equals to 0. So what do I do here? I subtract both sides. So what do I have here? This is giving me 5, 0, 205a minus 205a equals to what? Equals to 78. Then a is equals to what? 78 over what? 205. Have we now? How was it? Before? Yes, have we now? Wait, but there should be a minus here. So if I've gotten the minus, so put it inside this place here. So I can say that 6 open bracket minus 78 over what? 205 minus what? 13b equals to what? 0. So if I go to the other side, so I have 16, 6 times minus 78 over 205 multiplied by 1 over 13 equals to what? B. Yes or no? Then for me, I can have this one cancel this one to give me what? 6. And my B is equals to what? Minus 36 over what? 205. So that is my, so you can say that y is equals to, what is my A now? Minus 78 over what? 205. 205 sine 2x minus 36 over 205 cos what? 2x. Thank you. But I'm not done. I just said thank you. I don't know what I'm saying. Holy Spirit. Kai. Minus 78 minus 36. Okay. So there are sometimes you can have cocktail. Yes, sir. Like getting to answers. Now that time we did is nonsense we did. Yes. Now our eyes just open now. Did nonsense then. Yeah. I think we've done everything now. The only thing that's what I have to do is what? How to combine few of them. Eh? You don't what? What is it? I don't get. I don't understand. You don't know the reason why the first one was wrong. Okay, I will explain to you. When I had 13a here, and I had 6b here, and I was forming the equation, and I done 13 to 6, and done 6 to 13. And you wrote it inside your notes, I cannot complain. Are we together, please? Have you gotten that? Okay. Let's take about 3 or 4 more examples. Which one is no? If you guys are doing examples since morning now. Okay, I'm going to feel entirely long. We not do example, you talk. We do example, you are talking. At a certain time, you will talk. You stand up, you will talk. Can we continue, please? Okay. Where? Listen here. I just collected like terms from here. I collected like terms from here, and I equated coefficients. Sine, sine, sine. 6. Cos, cos does not have cos. I put 0. Zero, yes. So let's do this. Let's do these exercises. So we have 8 y double prime minus 6y prime plus y is equals to 2x plus what? Plus 40 sine x. Now I want to try this. Now this one that we are doing here, we are not doing the complementary solution. I'm not concerned with the complementary solution because I know we can get it. What we want to look for here is what? Particular solution. Now what would the format look like? Can we have someone that can guess it? What would the format of this thing look like? Then first of all, yes, you are right, it should become ax plus b, then plus what? C sine x plus what? D cos x. Do you know why it should be like that? Because don't forget that anytime your sign is appearing, the correspondence for the law you'll be creating is what? Sin x and what? Cos x at the same time. Do you understand what I'm saying like that? So because once you can understand the what do I call it? The kind of form it will take, then you will be able to know. I think differentiating and finding those ones will not be difficult. I get my friend saying like that. Now what form will this one take? This one does take that y is equals to what? Ax plus b, then plus what? C sine x plus what? D cos what? Cos x. So that will be the form. I'll get to my friend to say. Abi, this 2x is taken care of by what? Ax plus b. And this trigonometry here is taken care of by what? C sin x plus what? D cos x. The square y, the x minus plus 10y equals to exponential 2x plus 20. So what would this form be? What would the form be? So y here will give you what? A exponential 2x plus what? Plus k. Yeah, that's what it should be. Out of everything, which one are we solving? Huh? Yes, ma'am. Yes, yeah, we are helping you. How can we help you? How can we help you? Yeah, let's find you. Oh yeah, oh yeah. Which place? And now what we are trying to say is that we have a question and we want to generate the function that can correspond to his what? Particular solution. So whenever you have this x, anything x, which will give you what? Ax plus b. Anytime you have anything to be trigonometrical at all, whether sine or cos or tan, just know that at the end of the day you'll be having what? C sine x plus what? D cos x. Do you understand? Now the same thing to this part here. I said that which one are we solving? All of you said no. They play. Because you said none, you are solving all. How will you come to school without doing anything? Eh? Okay. So because I'm nice. Yeah, let's do the complementary solution of everything together. Yeah, complementary solution. Sharp. So what is CS? CS number 1. CS of number 1. What do I have? 8m squared minus what? 6m plus 1 equals to what? 0. So what will be this one? This one should give me 8m squared, right? Minus 2m, no, plus 2m minus 8m plus 1 equals to 0. What would this one give you? 2. Give you 2m with, is this thing correct, Cha? Not correct. I need 8 and minus 2 and minus 6. That's minus 4 minus, okay. I have 8m squared minus 4m minus 2m plus 1 equals to what? 0. What do I have here? I have 8m, which will give you what? M, no, not 8m, 4m, 2m minus what? 1, minus what? 1, 2m minus 1 equals to what? 0. You have 4m minus 1, 2m minus 1 equals to 0. Then you have m is equals to 1 over 4 or 1 over 2. So your y here will give you what? C1 exponential 1 over 4x plus C2 exponential 1 over 2x. Okay. Complementary solution of 1. Complementary solution of 2. So what's the second question? So what do I have here? Oh yeah, now talkie. M squared plus m minus what? Minus equals to 0. What's the form here? Can we find it straight up? I have minus 2 and I have plus 1. I mean now. Minus 2 plus 1. That's going to give me m plus 2, m minus 1 equals to what? 0. And m here is equals to what? M minus 2 or 1. So your y here is equals to what? C1 exponential minus 2x plus what? C2 exponential what? X. Happy now? So this is the solution of this. And number 3. Number 3. So let's get that number 3, which is going to give me what? M squared minus 7m plus 10 equals to 0. This one is m minus 5, m minus 2 equals to 0. Then what do I have here? M is equals to 5 or 2. And y is equals to C1 exponential 5x plus what? C2 exponential what? 2x. Okay, we are done. But I didn't say we are true. We are done. Done does not mean I are true. Don't clap. Now, particular solution. Yes. I know, I did not say that. It's not me that said that. Not yet, my mind I said I'm not doing anything. So particular solution. So let's take a particular solution. But this time I'll not start with number 1. I'll not start with number 2. I'll start with number 3. So let's start with number 3. Particular solution. Particular solution of number 3. So PS number 3. So since I have this already, so let's differentiate the answer. So by differentiating, what will I have? I have y equals to what? A exponential 2x plus what? Plus k. Then y prime here will give you what? 2a exponential 2 exponential 2 exponential y double prime 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 y double then what will I have? And I will have 4a exponential 2x minus 7 times 2 will give us what? Minus 14a exponential 2x. Yes or no? Plus what? 10a exponential 2x. I mean now. Plus what? Plus 10k equals to exponential 2x plus what? Plus 20. Are we together? What do you think will happen again? What do you think will happen now? Authorize which one? Add everything, what will you have? Remember this negative 19? Where? Oh yeah, I'm looking at it too. What up? I know. I need an exponential 2x now. I need a value of exponential 2. Where are we adding the x? Where are we adding the x? Because the thing is that if I do that way you say I'm going to do, the only thing I'll be getting there will be k. Abi now. So and I'm not getting only k here. At all. Oh. We had what? What was that question we had? Exponential 2x plus 20. If k was x, what would have changed? If k was, there would have been a k here. Abi now. But at the same time, too, my exponential x would have been cancelled too. Let me check out the question. Let me check out the question right with it. There's an x to the a. There's an x to the a. So let's see. So let's say that here this was ax, then y prime here should give me what? So this is 2ax exponential 2x plus a exponential 2x, then y double prime here. This one should not give me what? This one should give me what? This is your u, this is your v. 4ax exponential 2x plus what? Plus 2a exponential 2x plus 2a exponential what? 2x. And let me substitute everything here. Okay, but I like it or not. If you don't get one of these things, I'm not going home today. So what is my d squared y dx squared here? We have this one to be what? 4ax exponential what? 2x. Then plus what? 4a exponential what? 2x. Then minus 7. What is my dy dx here? 14a x exponential 2x plus 7a exponential 2x plus 10 a exponential 10ax exponential 2x plus 10k equals to I'm left with what? This one here and this one here, which will give me what? 13a exponential what? 2x plus what? I mean now? No, it will not be 13, it should be 11. 10k equals to what? Exponential 2x plus 20. And what is here? I can answer that 11a is equals to what? 11a equals to 1 and 10k is equals to what? 20. Then your a here is equals to what? 1 over 11 and your k is equals to what? 2. Then putting everything back inside that place. So you can say that your y, so your general solution, or let's start from here. Y in this case here should now give me, what is my a? 1 over 11x exponential 2x plus, what is my k here? Plus 2. Okay, it's minus 7 here. Okay, then that will give us minus 3. Okay, minus 3. Okay, then this one will give us what? Minus 1 over 3. Thank you very much. I think that's that about that. So putting that, so my general solution for number 3. So that is y is equals to c1 exponential 5x plus c2 exponential 2x minus 1 over 3 x exponential what? 2x plus what? Plus 2. I'm waiting now. Write fast, please. Yeah, we'll stop at the second one. Yeah, we'll stop at the second one. Yeah, write fast. We'll stop at the second one. I'm going to gentleman. Okay, where's the up? Yeah, okay. Yeah, huh? No, I made mistake. So now it's not minus 8. So now it's not minus my explanation. See, minus 7 here. So I wrote plus here before. Okay, I still writing this one. Hey, wait. The first I want to clean board now. Let's do one more, then we'll go home. Yeah, we'll do one more and we'll go home. It's not we, because some people are looking at me that we'll go home. I'm still here now. I'm going to check here now. I'm going to write fast, I beg. They are still writing it. I don't know. It's If you did not finish that second one, I need to move shit. I don't even know share. Let's finish it. Hey, wait. You're not writing, Gongo. My friend. You're not writing. Okay, she be this side. I can clean this side. Now, let's do it together again. Yeah, everybody eyes here. Everybody eyes here. All eyes here. All eyes here. Sit down. One whole eyes here. You're just looking at the back. And the way you just call your help like this. My A is -1/3. So now, what is my number 2? My 2 is what? Number 2 is giving me y is equals to ax squared plus what? bx plus c plus d exponential 2x. Yes or no? Say, So y prime here is equals to what? 2ax plus b, plus what? 2d exponential 2x. Y double prime is equals to what? 2a plus what? 4d. Exponential 2x. Let's substitute inside that. What is it? So that one. So what is the square y? So I have what? 2a plus 4d exponential 2x plus 2ax plus d plus 2d exponential 2x minus 2a. Let's open it straight. Minus 2ax squared minus bx. Wait, what are we doing now? Minus, okay, minus 2bx minus 2c minus 2d exponential 2x equals to what? X squared plus what? Plus exponential 2x. Okay. Let's get like that. Yes. D has cancelled. Because I have 4d here, 2d. Okay, that's not cancelled. It's not cancelled. So that means these 2 here will cancel out. Then what do I have left? Do I have any other thing that's cancelling out again? No. So I have, let's combine everything together. 4d exponential 2x. Then I don't think, let's arrange everything together. Minus 2ax squared. Okay. I'm coming. Plus 2ax next. Minus 2bx plus 2a minus 2c. I think that's all. Equals to x squared plus exponential 2x. Now. Okay, plus d, yes. So I think everything here and everything here is equal to each other. So I can say that 4d is equals to what? 1. Yes or no? Yes. And I can say that d is equals to what? 1/4. Yes or no? Then if I have this, I can compare this x squared and this x here together. I can say that minus 2a is equals to what? 1. Now. I can say that a is equals to what? Minus 1/2. Okay. Now what else am I looking for? B. I don't have any x here. That means I have 2a minus 2b equals to 0. Then if I divide side by 2, so I have a is equals to b. Now. That means b also is equals to what? Minus half. Okay, what else remains? C. I brought in d, which remains c. So I can say that 2a minus 2c plus d, are we together? Equals to what? 0. What is 2a? That's minus 1 minus 2c plus 1/4 equals to 0. I have 2c is equals to what? So that is minus 1. Let's say take this one to the other side. So that will give me minus 3/4. Now. Then c will give me what? Minus 3/8. So I have a, I have b, I have c, I have d. See that we joined together and we did it quickly. Eh? Yeah. So if I now to combine everything together, so combining everything together, so if I want to combine everything together, so I can now say that y is equals to, what is my general solution there? Ax squared plus what? Bx plus c plus d exponential 2x. What is my a here? My a is minus 1 over 2x squared minus 1 over 2x minus 3 over 8 plus 1 over 4 exponential 2x. What is my general solution? Gen. So what is my, so that's going to give me c1 exponential okay, yes, exponential minus 2x plus c2 exponential x minus 1 over 2x squared minus 1 over 2x minus 3 over 8 plus 1 over 4 exponential 2x. I didn't say you should go home now. Abba, calm down. Yeah, finish writing, please. Eh? Hey, can solve the last one now. Can solve the last one now. Please solve the last one.
Yes, sir. Send it to your YouTube.
Or you by you. I've not seen it. Where? Point. I don't understand. Yeah. Yeah. This one here. This one is different. Okay, that means, sorry, I've not changed it. Change it like that. Put X. I've not changed it. I've not changed it. So today we looked at method of, let's start from the scratch. We looked at method of variation of we didn't have variation now. Undetermined coefficient. Abi now?
Yes, sir.
So we started from undetermined coefficients. We looked at complementary solutions, and we noted that how many times or how many forms of complementary solutions did we have? We have 3 forms. The first form when it is real, roots, and difference. And what will be your solutions then? The solutions will be in terms of what? C1 plus C1 exponential M1x plus C2 exponential M2x. Good. And also, when it is roots and they are what? Real and equal, what do you have? You have C1 plus C2x close bracket exponential mx. And when it is roots and it is also imaginary. First thing I have to notice there is that there's a format. What is the format? Alpha plus or minus beta I. Abi now? And if you have that form, then what answer will you have? You have exponential alpha x, open bracket, a sine beta x plus b cos beta x. Abi now? Then after that, we looked generally into, we now started solving particular solutions. I said that anytime you see a constant, what do? You put k, right? You create another form, which is what? K. If you see that k, if you differentiate it, it will give you 0. You add x to it. If you see that one will give you 0, add another x to it. You're going to say like that.
Yes, sir.
So then when forms of particular integrals, and I think we did as many combinations we could do. And we had one pending question that is here that we did not look at because you guys are very, very lazy. Lazy people. Lazy people. Say you are lazy.
We are lazy.
So you've tried. So the next time we'll be meeting, we'll be talking about variation of parameters, basically. And from that variation of parameters, so we will move on to Laplace after we are done. Thank you, and God bless you. So please, I want to clean this one. This one. MTS21. Here we. So this morning we finished integration this morning, and this same morning at the same time we went towards partial derivatives. And from that partial derivatives, we were able to look at some stuffs. We started with introduction, yes or no. Then from introduction, the next thing we did was what? From introduction, we moved on towards higher order differentials. Then from higher order differentials, this morning, from higher order differentials, we moved on to what? Total differential, right? Then from total differentials this morning, I don't know how you got the note. I don't know. You still came late, but you got the complete notes. Okay. Then from total differentials, we talked about what? Chain rule. Then from chain rule, I think we stopped at what? Rate of change. Okay, now let's continue from where. Let's pick it up from where we stop. So from rate of change, let's now move on to. Let's move on to small increment. Small increment. Small increments, yes. Before I start, or before I commence, may I request if anyone has jumped on his or her phone and is reading 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 so now look at that we have a function, 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 you have a function, this function for increment, u partial y increment in y plus partial u partial w increment in what? In w. So if you notice, you find out that this formula that I've written on the board is very, very similar to what? Total differentials. Yes, thank you. Can I pass the phone? Thank you. Yeah, the topic small increments. I want to talk about small increments. Okay, now we've talked about small increments. So now I want us to, I'm trying to see if, let's get questions here and we solve. And after small increments, we look at, okay. Don't worry, this night, don't worry, we do for each other. Don't run away, oh. Don't run away, oh. Because we'll do some scary things this night. Don't worry, I'm not scaring you, I'm just telling you to prepare your heart. 343. All right, so let's start. Are we together? Yeah. So let's start. So now let's take out this. Let's take these questions out. I don't call questions from my head, but just know that this is how it looks like. It looks like that. Now, question number 1, as we have. Now, the pressure P and volume V of a gas are connected by the equation. Let's start. Yeah, let's write. The pressure P and volume V of a gas. The pressure P and volume V of a gas. The pressure P and volume V of a gas are connected by the equation. The pressure P and the volume V of a gas are connected by the equation. Are we together? Are connected by the equation PV to the power of 1.4 equals to K. PV raised to power 1.4, that is PV, that V has the power of 1.4, then equals to K. Now the question is, determine the approximate percentage error in K. Determine the approximate percentage error in K when the pressure is increased by 4%. Determine the approximate percentage error in K when the pressure is increased by what? By 4%. Are we together? And the volume is decreased by 1.5%. And the volume is decreased by what? 1.5%. Are we here? Okay, now pressure is decreased by what? 4%, and volume is decreased by what? My PV raised by 1.4 is equals to what? K. Now this question is telling me that from here I want to determine my what? Approximate percentage error. Now sometimes these small increments can be known as percentage error, or approximate percentage error, or small changes. They are meaning the same thing, but those different how would I call it, different names or nomenclature that they can give it. Now whenever you have something like this first, don't worry, the time they're always in terms of what? Percentages. I get what I'm trying to say like that. Now the same thing to here, the same thing here, and what? The same thing here. Now let's now start. I have PV raised by 1.4 equals to what? K. Are we together? Then for me I can say that partial K partial P here is giving me what? V raised by what? 1.4. Yes or no? Then partial K partial V. Yes, partial V now. You give me what? 1.4 PV raised by what? 1 point what? Raised by what? No, not 1 point, 0 point what? 0.4. Are we together? Now the question told me that what is it now? That pressure is increased by 4%. I just differentiated this one. Partial K partial P, differentiate P. I have this. Partial K partial V, differentiate V. You have this. Are we together? Now the question now says that we should find. The question told me that pressure increased by what? 4%. That means an increment in pressure is what? Plus what? 4% P. Now the reason I'm adding this P is that I'm adding in that. Sorry, it's not plus or minus. I'm adding this because I'm showing that I don't know what my P is before. That before it what? Before it increased. But the question told me that my pressure shall increase by what? By 4%. I'll get one apparently like that. And the other one says that the volume that is changing V, it decreased by how many percent? By 1.5%, and that's what? Volume. I will get one apparently like that. So from here, let me write out. I've gotten all of everything I need. I can now write out this one to give me what? So I can say that change in K, which is what I'm looking for, is not the same thing, is approximately equal to. So I can have partial K partial P change in P plus what? Partial K partial what? V change in what? Change in V. So now approximately equal to, what is partial K partial P here? Now partial K partial P is what? V 1.4. Now this one here, what is my percentage P here? Plus 4% of what? Of P. Are you getting it? Then plus, what do I have here? I have, this one is giving me what? 1.4 P v 0.4. Then what do I have here? Minus 1.5% what? V. Are we together, please? Good. So from here, let's open the bracket. So what do you find out here? You find out that your change in K here is approximately equal to, so if I open this bracket here, you find out that what will I have here? I'll have PV 1.4 multiplied by 4%, yes or no? From here, then from this part here we have what? Minus 1.4, 1.4 PV multiplied by what? 1.4 multiplied by 1.5%, yes or no? This is what I will have, yes or no? If I multiply everything here, and now there's a V here, okay, where? This one here is supposed to be 0.4, but it can't be 0.4 because there's already a V here, and V is to the power of 1, and they are multiplying each other. So you get what I'm trying to say like that, so it can't be like that. So from here, I can now factor out increment in K. So if I factor out my formula here, what will I be left with? PV 1.4. Now I'll be left with what? 4%, 4%, minus 1.1%, is what? 4% minus 4%. Can I know what this one will give me? 1.4 multiplied by 1.5. Please, I will need calculators. Please, I will need. Available. You know my calculator. Yeah, why need me? Let me find calculator, Joe. 2 points. 2 points what? This is 2.1%. Are we together? Then everything here, K, PV 1.4. The 4% minus 2.1% will give me what? That will give me what? 1.9%. Is it positive or negative? Positive. That means therefore the change in K here is equal to what? Positive 1.9%. That's all. This one here. Open this one now. V 1.4 multiplied by P will give me this. Then 1.4 here. This is 0.4. But there's also a V here, which is raised to power 1. So anything raised to power 1 times this V will give me what? V raised to power 1 plus V raised to power 0.4 now, which will still give me what? P, this one here. Then from here I can now factor out my what? My general formula, which is this. After I've gotten here, just work out with your percentage. And from your percentage, the total answer you have from your percentage will give you what? Whatever increment you are looking for in your V. I get what I'm trying to say like that. So the total answer to this one here is what? 1.9% what? Increase. I'll get what I'm trying to say like that. Okay, now another question. Another question now. Although there's a shortcut to it. But the shortcut might look a little bit confusing. Are you ready to go for it? Okay, I want to learn the normal method first. Okay, it's good. One shortcut. It's a bit, okay. Alright, let's start. Are you ready? I'm waiting for also. Let's try it fast now. MTS 2 people be ready this night too. I'm not scaring you, but be what? Be ready. What did I say? I'm not scaring you, but be what? Be ready. I did a very long differentiation here. Was it not? Yesterday? Was it yesterday? It was yesterday. A very long differentiation. When I was dealing with review of differentiation and integration. Yes. Okay, I remember. Okay, another question. Another question. Modulus of rigidity. Please, let's write fast, please. Modulus of rigidity. Modulus of rigidity. Rigid and ity. Rigidity. Modulus of rigidity. G. The modulus of rigidity G. The modulus of what? Rigidity G is equals to, so you can write this formula. Let me write it for you on the board. G is equals to r raised to power 4 theta divided by L. The modulus of rigidity, that formula. The modulus of rigidity, that formula. Are we together? Where r is the radius? Where r is the radius? Where r is the radius, comma, theta is the angle of twist. Where r is the radius, comma, theta is the angle of what? Angle of twist. Angle of twist. Twist. And L is the length. And L is the length. And what? And L is the length. And L is the length. Full stop. Determine the approximate percentage error in G. Determine the approximate percentage error in G. Comma, theta is reduced by 5%. Are we there? R is what? Increased by what? 2%, comma, theta is reduced by what? 5%, and L is increased by 4%, and L is what? Increased by what? 4%. Do we get the question? Okay, good. Now, first thing that we have to do here is let's master. Are we together? So let's rewrite this thing in such a way that it can favor all of us. So I hope you know that this thing here is G. You see the same thing as writing it as R 4 theta L minus 1. Yes or no? Okay, good. Now let's now find. So from here, so from this, so my approximate change in G, they are approximately equal to what? Partial G, partial R, change in R, right? Then plus what? Partial G, partial theta, change in theta, then plus what? Partial G, partial L, change in what? L. Are we together? So let's start. So what's my partial G, partial R? So partial G, partial R here means you want to differentiate with respect to only R, which will give us what? 4R3 theta L minus 1. Are we together? Then what do I have next? So partial G, partial theta. So if I want to do respect to theta, I think theta will leave here completely. That will give me what? R raised to power 4, L raised to power minus 1. Are we together? And the last one here is what? Partial G, partial what? Partial L. And I want to do partial G, partial L. If I differentiate this raised to power, what will I have here? Minus R raised to power 4 theta L raised to power what? Minus 2. Are we together? Are we together? Differentiate respect to R here. Only R here will leave to give you this. Theta here, theta will leave. And here you are differentiating with respect to L. Minus 1 comes to the front. I get in it. Now let's now check. What is my increase in R? Is R increasing or reducing? R is what? Increased by what? 2%. I mean now, that's what? 2% of what? R. Increment of what? Theta. What's increment of theta? Theta is what? Reduced. Minus 5% theta. And increment of what? L. That's going to give him what? Plus 4% what? L. Yes or no? So now from here, let's combine everything together. So now here I can now have my partial G, which is not equal to now my partial G approximately equal to. So putting everything here that I have inside this place, and what will I have? So I put together. Let's start. I'll put everything I have inside this place. So okay, let me save this place so that I should not look clumsy. Let me come here, a fresh page. So I have change in G will now give me. So what's that? So I will have into bracket 4r cubed theta L minus 1 multiplied by, what is the increment in G? I mean, increment in R is what? 2% R, then plus what's the next one here? Partial G, partial theta, right? That is R raised to power 4 L raised to power minus 1 multiplied by what? Minus, I mean, is it minus or plus? Plus 4%. Then the next one here is what? Wait, the next one is theta now? Okay, it's minus 5%. Minus 5% of what? Theta. Then the next one is what? Plus. Okay, you said minus. Okay, minus R raised to power 4 theta L minus 2 multiplied by plus 4% of what? L. Are we together? And from here, what do I have? Now I have change in G approximately equal to. Now let's multiply. So I hope let's do it this way. Let's make it fast. So I want to bring my formula outside straight up. So I have R4 theta L minus 1 multiplied by 4 times 2%. Yes or no? Yes or no? Okay. Then the same thing here. What do I have here? Minus. And I have R4 theta L minus 1. What do I have here? 5%. Yes or no? Then the next thing here, I have what? Minus R4 theta L minus 1. I have what? 4%. Right? Now, this one is L, what? L to the power of 1. So 1, we'll cancel that. So from here, I can now have approximately equals to what? R4 theta L minus 1 will now give me what? 4 times 2% is what? 8% minus 5% minus what? 4%. And at the end of the day, what do I have here? I have R4 theta L minus 1 increasing at what? Minus 1%. So therefore, what they ask us to do for them? Approximate percentage error is equals to what? Minus 1%. Do you understand, please? Do you understand? Do you understand? I just saw it now. Okay. Which one? Which one? See this one. Why is it not 2 minus 2 as that? I don't get. Now there's L squared multiplied by L here. This one here, is it the same thing now? You know that from my general equation it was what? L is power minus 1 from here generally. She gets. It was only as this place and it became minus 2. Another question. Okay, I'm not ready for the shortcut now. You're not ready yet. Okay. I'm obstructing the view. You know what? We have a lot of things to do, and our journey is still far. So let's write fast, very, very fast, very, very fast. Let's choose one more examples. Are we together? Let's choose one more example. Are you ready? The power consumed. I'm writing. The power consumed. A power P consumed. I'm more specific like that. A power P consumed in a resistor. A power P consumed. A power P consumed in a resistor. A power P consumed in a resistor is given by P equals to V squared over R. A power P consumed in a what? Resistor is given by what? P equals V squared over what? Over R. Do you get that? It's given by pressure, P is equals to what? V squared over R. Full stop. Determine the approximate change in power. Determine the approximate change in power. Determine the approximate change in power when V increases by 5%. When V increases by 5%. When V increases by 5% and R, when V increases by 5% and R and R decreases by 0.5% and R decreases by 0.5% and R decreases by 0.5%. How do you? If the original values of R and V, if the original values of R and V, if the original values of R and V are, if the original values of R and V are 50 volts and 12.5 ohms respectively, 50 volts and 12.5 ohms what respectively. Did we get that? Yes. Okay, let me just 12.5 ohms respectively. So let me quickly run through it one more time. I'll be fast now. The power consumed in the resistor is given by P equals to V over R watts. I didn't put that. Determine the approximate change in power when V increases by 5% and R decreases by 0.5% if the original values of V and R are 50 volts and 12.5 ohms respectively. Alright, good. Let's work with that. So from here, I can say that, okay, sorry, I want to back the fan because the fan will be from the mic. So from here, we have that P is equals to what? V squared over what? V squared over R, right? So from here, I can confidently write it as what? P is equals to what? V squared, R is power what? -1. And are we together? Okay, good. So from here, don't forget, what are we looking for? Approximate change in what? In P. Yes or no? Now, what is approximate change in P? Approximate change in P. What is the name of this sign? I said I didn't ask for the meaning. I said what is the name? Can't find it. That's delta. So approximate change in P is equal to partial P over what? Partial V change in V plus what? Partial P over partial R change in what? Change in R. I'll get into this. And so from here, so what is partial V? So let's go and start looking for it. So I can say that partial P partial v is equals to what? If I change this in respect to v, what do I have? 2v r minus 1 partial p partial r should give me what? Minus v squared r minus 2. Are we together? Then the next one again is what? Partial. Okay, I don't need the partial now. Now, what is my change in v? My change in v is what? What is my change in v? V increases by what? V increases by what? Equals to what? Minus 0.5%. I think I have everything. So what's my change? But the minus in it has multiplied the minus outside. Should we get? Then approximately to p. I have here to be what? V squared r to give me, what is this? 10.5%. I will say that. Yes, this will have been my final answer, but the question already added another information. They gave us the original value of v and the original value of what? R. So if I substitute, it won't be multiplied now, divided by 12.5 times what? 10.5 over what? 100. My change in p. So if do you have anybody that is with calculator that can help me compute what I've just written on the board? What's the answer? The answer should be plus 21. Is that what you got? 21. Okay. So that's the answer. So the answer is what? 21 what? Watts. Do you understand, please? Do you understand? Okay, good. That'll be that about that for small increments. As I said, that'll be that about that for what? Small increments, yes. After the percentage, yes. I multiplied it. Now, I could have thought my answer here already, but the question has already given me the original value of what? Of V and R, which is what? 50 and 12.5. She gets, so that's why I have to substitute the back end. Do we get? Okay, good. Dexter, thank you. I might still use it, need it, but for now I'm not. Okay, so who is with your manual? Anyone with M1 manual? Yes. Okay, you can say we are faster. Yes, sir, I can hear you. So this person raise up your hand. Yes, sir. Shortcut. Okay. You need it. No, I think there's some feedings. So actually, that's why I'm. So the next topic we want to look at now. I want to look at extrema. Yeah, what about the shortcut? Now the shortcut is just a simple basic trick that I can help, but I don't know how to explain without confusing you. So you shall know this method. Abi, you know this method, so stick with the method. I know CBT, you'll be faster. Adrenaline will push you. Okay, let me come to this side. Sorry, do you have anyone that is with handkerchief that is not using? Do you have anyone? Handkerchief you're not using? Wait, don't worry. Alright, let's continue. Don't worry. Okay, extrema. Yeah, let's talk about extrema and maxima. Now that's what we want to look at now. Extrema. 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 So we'll write it step by step. We deal with it step by step. So now number 1 is f of x comma y equals to 8x squared plus 6y squared minus 2y cubed plus 5. Number 2. Okay, f of x comma y equals to, sorry now, where are you? Sorry, x cubed plus x squared minus xy plus y squared plus 4. Number 3, z equals to x cubed plus 6xy plus y cubed. What number? 36. So now I want to find extrema. So let's write out this question. So we'll be taking it to be treating it step by step. Now solution. Are we ready? Now number 1. So we'll be writing it. Step 1. Step 1. Find, step 1 is when you have to find partial f partial x partial f partial y. That's step 1. So let's find it. So partial f partial x, what would that give me? Differentiate this answer with respect to what? Only x. What do I have here? Sorry? I have what? 16x. Sorry? I feel this question is not complete. Okay. So partial f partial x is 16x. Now partial f partial y. What would that give me? So that give me what? 12y minus what? 6y squared. Now step 2. So let partial f partial x equal to 0 and partial f partial y equals to what? 0. So what do I have here? You have 16x is equals to 0 and you have 12y minus 6y squared equals to 0. Are we together? Then for me I can have x is equals to what? 0. For factoring out, what is common here? 6y. Then if I factor out 6y, what do I have? 2 minus y equals to 0. You see that you have x is equals to 0, or you have 6y equals to 0, or y equals to what? 2. Yes or no? So we can have x equals to 0 and y equals to what? 0, or y equals to what? 2. I'll get in this piece. So that means here I have one single point of what? Of x, but how many points of y do I have? 2. Now at this point, so at x equals to 0 or y equals to 0, so all of these points here has a name, and all of them are called turning points. I'll get one pencil like that. Turning point or stationary point. Do you get? How did I do it? I did this one here, divided both sides by 16, and I have my x equals to 0. I wanted x to stand alone. This one here, I differentiated this answer with respect to x. Okay, how did I get this one here? How did I get this one here? Okay, the thing is that here is a law. After you have gotten this, the next step you have to do is what? Equate both answers to 0. Next one. Okay, sorry, I was saying, sorry. I wish I was transparent. I can see me, but you can also see through me. I wish. It would have been a very, very good thing. Okay, fx, f, fxy. So from here, I want to find fxx. Now, this next thing I want to find. How we? But let me put our step 3 first. Step 3 to be to find fxx, fxy, fyy. So let's start. Fxx. So fxx here. What does fxx means? Fxx means you want to differentiate fx with respect to what? To x. So if I differentiate fx here with respect to x, what do I have there? I have 16. Now fxy, meaning I want to differentiate fx with respect to y. And I hope you know what will I have there? I will have 0. Yes or no? And the last one here, which is what? Fyy. So if I differentiate this one with respect to y, what will I have there? I will have 12 minus 12y. Yes or no? Alright, are we together? And the next thing we have to evaluate is this. Evaluate, that's step 4. Evaluate d equals to ab minus c squared, where a is fxx, b is fyy, c is fxy. That'll be the next part. From the next part here, this is what I want to evaluate. I want to find my discriminant. So what will be my discriminant here? What is my d here? My d is what? ab minus what? Minus c squared. What is my a here? My a is what? fxx. How about the fxx here? 16 multiplied by, what is my b here? I have what? 0 minus, all together. Are we now? Some b, okay, yeah, okay. That's open bracket, sorry. 12 minus what? 12y and minus what? 0 squared. So what do I have here? I have d is equals to what? 16 open bracket. 12 minus what? 12y. Happy now? No. But from here, don't forget that how many values of y did I have? I had 2 values of y. So I'll say that so when y equals to 0, what points will I have? I can have d is equals to 16 open bracket 12. Happy now? That's when y equals to 0. And when y is equals to 2, what will I have? I'll have d is equals to 16 open bracket minus 12. Yes or no? Yes or no now? Okay, good. So I've gotten to this part. So in the last step, step 5. So from step 5, if condition number 1, d is lesser than 0, saddle point. Second one, d is greater than 0 and fxx greater than 0 or fyy, I'm going to have local minimum. Number 3, d is greater than 0, fxx less than 0 or fyy less than 0, local maximum. So this will be all the 5 steps that guides. So this is all the 5 steps that guides it. So now let's look at it critically. From here, what can we observe? Now let's look at it. So from here, yeah, I have 2 conditions for d. And the first condition for d is that d is greater than 0 here. D is what? Lesser than 0. Yes or no? So at y equals to 2, which is lesser than 0. And don't forget that anytime I have a lesser than 0, now I have a what? A saddle point. That means this one here, this fine boy here, I have a what? Saddle point. Are we together? And who said no? Here at d equals to 0. I don't want to know whatever this multiplication is, but it is obviously lesser than 0. And if your d is lesser than 0, you have a what? Saddle point. So that's why I said that at y equals to 2 here, you have a what? Saddle point. And this other one here, that is what? D is here, is what? Greater than 0. Abi now? D is greater than 0, but also there are 2 conditions that have to be satisfied. That I don't need only d to be greater than 0. They must be satisfied. There are some conditions that must be added to it. So from here, what do you notice? If d is greater than 0, and at the same time, fxx is greater than 0, or what? Fyy is greater than 0. You have a what? Local minimum. So let's look at it. Is fxx greater than 0? Yes. 16. And fyy at it, is it greater than 0? If I put 0 here, I think, is it greater than 0 now? So that means at y equals to 2 here, you have a what? Minimum point. Please, you understand? Please, you understand? Please, you understand? So I will leave these steps on the board. I'm not even touch this board again after this question. Yes, sir. You can't have both violate like that. Are you getting it? Is it that both of them are greater or both of them are lesser? She gets? Yeah. I was expecting a question like that too. Okay, I want to clean the second part. Any other questions? Why is my fxy 0? 0. I don't get. Why is my fxy 0? Yes, that means fxy means you want to differentiate fx with respect to y. And what is your fx? Your fx is only comprised of what? Only x. There's no y in it. And if you differentiate y, if you differentiate x as a constant, what will you have there? 0. That's why. Do you understand? Okay, good. Huh? What did you say? fx1 is not always 0. It's just for only this condition that it was 0. And this reason why it was 0 was because there was no y in my fx to differentiate. That's why it was 0. Yes, sir? Okay, this part here. This part here. It's local. Local minimum, local maximum. What's it? It looks like brackets. Wow. I said that. Then let's look at number 2 now. Let's look at number 2. So we'll be taking the steps one by what? One by one. So in number 2, what's your first step here? Find fx, find what? Fy. So in number 2, so what's my fx now? Fx will give me what? 3x squared plus what? Plus 2x, all together, minus y. Is that now fx? Happy now? Fx means differentiate with respect to x here. Then what is your fy? Fy differentiate with respect to y. What do I have here? 2y minus what? Minus x. Then the next step is what? Make fx equals to 0 and what? Fy equals to 0. What do I have here? So fx is equals to 0. So if fx equals to 0, what do I have here? 3x squared plus 2x minus y equals to what? 0. And here I have what? Y equals to what? Y equals to what? 3x squared plus what? 2x. Yes or no? And here if fy equals to 0, what will you have? You have 2y minus x also equals to what? 0. Then from here, you can say that y is equals to x over 2. Yes or no? Yes or no now? So you can substitute both of them to each other. So you can have x over 2 equals to what? 3x squared plus what? 2x. Yes or no? Then if you cross multiply here, what do I have here? You have x equals to what? 3x cubed plus what? Yes, if you multiply by 2, sorry. You have what? 6x squared plus what? 4x. Then if you call it like times together, probably you now have 6x squared plus what? 3x equals to what? 0. Yes or no? Then so from here, what can I have? I can have 3x, which will give me what? 2x, plus what? Plus 1 equals to 0. So it should not give me either 3x is equals to 0, or you said it doesn't understand. Talk now if you don't understand. Continue, okay. Or 2x plus 1 equals to what? 0. Then from here it is either x equals to 0 or x equals to what? Minus 1 over what? 2. Now, so if x is equals to 0, if I put this in any of this place, what will I have? If x is equals to 0, I will have what? Y equals to what? 0. Yes or no? Because if x is equals to 0, if I put it in any of these points, what will I still have there? 0. Yes or no? Here. This one here. This one came here. X came. Then, so from here, so if x equals to minus half, if I put it inside this place, what would I have? Minus half divided by 2. What would I have? That's minus 1 over 4 now. That's minus 1 over 4. That means how many points do I have now? I have, this is 1 point. This is what? Another point. Are we together, please? Are we together, please? Now, the next step after we have gotten that is to what? What is the next step? Find fxx, find fyxy, and all. And let's now find, so here, okay, let me, from here. What did I find here? I found my x and y now. Yeah, now, not that here, first thing I have to do was what? I have to find x, y, because both of them are turning point or stationary point. So I need to find a point first. That's what I did here first. Now, so from here, so let's go. What is fxx now? fxx, differentiate this answer here with respect to x. What will I have? I have 6x plus 2. So now I can now have two values for it. So I can say that when x equals to 0, fxx will give me what? 2. Yes or no? Yeah. And when x equals to 0, minus half, fxx will give me what? All I have there. So if I put minus half here, that will give me what? Minus 3. Minus 3 plus 2 give me what? Minus 1. The next one here, fyy. So all fyy give me straight up. Fyy differentiate this one with respect to y. I have what? 2. Who gets one I'm trying to say like that? And the next one, fxy. So I think if I differentiate with respect to y, what do I have here? Minus 1. Are you getting it? Now, so from there, so what is the next thing I have to do? I have to compute. Let's now go and compute. D is equals to what? AB minus what? C squared. So now, what is my A? So before you do your A, we have to start picking. When x equals to what? 0. So what will be your D? Your D will be what? What is A? A is fxx now. So when fxx equals, so I have 2 multiplied by, what is your B? Fyy, which is what? 2 minus, what do I have here? Minus 1. Now? All squared. And I think at the end of the day, D will be what? Greater than what? 0. Yes or no? Yes or no now? Away. Yes or no? Yes, so this is greater than 0 here. And if this is greater than 0 here, so that means this point here is also what? Greater than 0. And for us to have a greater than 0 here, there are two conditions that must be satisfied. It's either f of x is greater than 0 or f of y is greater than 0. And from here, what do you understand? I think both of them here are greater than 0. So because of that, I can call this one here a what? Local minimum point. And if this one is a local minimum point, do you know that without even stressing myself, automatically this one is a what? Local maximum point. Yes or no? Why? Should we prove it? If we want to prove it, let's prove it too. I will not love to stress myself, so let me just leave it like that. Do you understand, please? Do you understand? Do you understand? Okay. So now, number 3. Number 3, here you have what? You have z equals to what? X cubed plus what? 6x y plus what? Y cubed. 6x what? Okay, 6xy. Then as usual, what do I find first? What do I find first? I find zx. So what is zx here? Zx is what? 3x squared plus what? 6y. Are we together? And the next one here I'm looking for is what? Zy. Zy here. Zy is going to give me what? 6x plus what? 3y squared. Yes or no? Yes or no now? And the next thing you're doing here is what? Zx equals to 0. Zy equals to 0. So what do I have? I have 3x squared plus what? 6y equals to 0. And here I have what? 6x plus 3y squared equals to what? 0. Then from here, if I divide both sides by 3, I have what? X squared plus 2y equals to what? 0. And this one to doing the same thing here, I have 2x plus what? Y squared equals to what? 0. So which one am I substituting for each one? Which one are we substituting for which one? So let me say that, let me make y bow here. So if y, let's say I want y, so y will be minus x squared over 2. Happy now? Happy now? Then putting this answer here, what do I have? I have 2x plus, what do I have? Minus x squared over 2, all squared equals to 0. And I can have 2x plus x squared over what? No? Because x4 over 4 equals to what? 0. Multiply everything by 4 will give you what? 8x. No, I have 8 plus what? X raised power what? 3 equals to 0. Then it is either x is equals to 0 or x is equals to what? Minus 2. Do you know why? And the reason is because if I isolate this one, 8 plus x cubed equals to 0. X cubed is equals to what? Minus 8. What number can multiply itself 3 times to give us minus 8? Is minus 2. So I've gotten 2 answers for x. So I can now be like, when x is equals to 0, what will I have here? Y also will give me what? 0. When x is equals to what? Minus 2. What will happen here? Y should give me, will it give minus 2 too? Because this is minus, so that I will have what? I have minus 2. Y equals to minus 2. So this is a point. This is what? This is another point. Now let's look at it and let's write. Please, let's digest. I'm waiting now. Are you done writing?
No.
Mama, you're not writing. I don't. Okay. Why do I get x equals to 0 on this part now? Can we continue? Can we continue? You guys still writing this up and let me see. Away. Please write fast, please write fast, please write fast. Please write fast. Where now? We should be done by now. Right? Let's continue, please. So from here, I think I've gotten everything to this extent. So the next part that I'm going to should be look for step 3, where I'm looking for fxx, fyy, and fxy. So let's look for those parts. Now, what's your fxx here? Fxx here. Fxx here would not be, where's 8? Okay, it's not be fxx now. should be zxx. So what zxx give me here? So zxx should give me what? 6x, yes or no? When zxx will give me 6x, that means I can now say that when x is equals to 0, zxx will give me what? 0. Yes or no? And when x is equals to what? Minus 2, zxx will give me what? Minus what? Minus 12. Yes or no? Now also the same thing goes to what? Zyy. So zyy, what will zyy give me? Zyy will give me what? 6y. Also the same thing. So when y equals to 0, zyy is equals to what? 0. When y equals to minus 2, zyy equals to what? Minus 6. Minus what? Minus 12. Alright. Next thing I need is what? Zxy. What is zxy? Zxy is what? Zxy is what? Zxy is equals to 6. Now let's now go and represent on that equation. So now what is that equation there? The equation is what? D is equals to what? AB minus C squared. You can start when x equals to 0, y equals to 0. So what do I have? So when what is a? That's zxx. So I have what? 0 multiplied by 0 minus what? 6 squared. And I have d here is equals to what? Minus 36. And minus 36 is what? Less than 0. So what will happen if I have less than 0? That means this point is a what? A saddle point. If this point is a saddle point, then the next one I'm looking for is what? The other part. So the other one too, when x equals to minus 2, y equals to minus 2. So what do I have there? I think I have minus 12 times minus 12, which is greater than minus 36. You have 144 minus what? 36, which is what? A positive answer. Now, despite the fact that it's a positive answer, both of them were negative. And as they were negative, they were what? Lesser than 0. So I can say that this one here is a what? Local maximum point. Do you understand? So that's that about that. Yes, sir. Huh? It's not the point you are using. It's the value of d that determines whether it's a saddle point or not. It's not the value of the y itself. You see, that's why I said that it is d. You see, if d, not the point. The point is what makes up the d. Like I'm trying to say like that. So if you are talking about the d, you are talking about the point, but not directly the point. You got what I'm trying to say like that. Look, I believe we should be done with this part now. Are we done with this part? Okay, good. I'll complain that now. Yes? Yes? Know that if zx is 6 now, then there's minus 6x, 6 is what? 36. The minus 12 times minus 12 is 144. Minus 6 there. So that will be that about that for extrema. Okay, so the next formula I want to write is Taylor series. Taylor series. Now Taylor series here is giving us f of x to give me f of a plus x minus a f. Okay, it should be x naught f prime of a plus x minus a x naught all squared f double prime of a divided by 2 factorial, then plus x cube, not x cube now, x minus x naught of cube of f triple cube of a over 3 factorial plus x minus x naught for iv of a over 4 factorial plus dot dot dot. I'm continuing like that. So this Taylor series and macaroni series of one variable. Now the question is, now why do we have Taylor series, and who in God's name asked these people to create all these things? Who asked them? Who sent them? Are we okay? So now, a simpler way of elongating. I won't use the word elongating so that I won't scare you. Wait, say you want to be scared now, be scared. Because where are they going to? Is still deeper than this. Yes. You know that I told you that. Yes, this is a common piece in CBT. Go ask anybody that is currently in 200 level. How many of this question they saw in the exam? Go ask. It's a common piece. I will teach you. I'll try my best. Wait till you have to help yourself. So whether you would like run, you would like don't run. These formulas must enter your head. So as I was saying, now Maclaurin series are just simple ways of what? Writing expressions. Now in case you want to write expressions that you want to write, okay, there are ways that you can find series. Yes, there are series ways of speaking functions. For example, if you have sine x and somehow you need sine x, but you don't need sine x in form of sine x, you need sine x in form of a series, then you either use your Maclaurin's form or your Taylor series. I get what I'm trying to say like that. Like for engineering, it's useful in engineering. Engineering uses it a lot. So there might be some cases where they don't want to use sine x in the real sense of sine x, but they feel that if they have a numerical, or if they have a series, or if they have a formula that computes sine x in values, you rather use it than using the whole sine x itself. Do you get what I'm trying to say like that? So now we'll do examples. So I think we'll do about 4 examples. We'll do two examples on Maclaurin series. We'll do 2 examples on Taylor series. Then from there, we'll now jump into 2 variables. So buckle your belt. So if you are sleeping before, wake up. So let's start. I'm not scaring you, literally. Let's do that as if I'm scaring you. So now, one thing you find out is that now Taylor series and Maclaurin series are the same thing. They are saying the same thing, but the only way that they are saying it is they are saying it in different points. Now in Taylor series, you need a particular point. You'll be given a particular point, which is, I think you'll be given as. Okay, I think I use x naught here. Let me just make everything a and a. Okay, you'll be given a particular point x equals to a here. So whenever the only thing that differentiates Taylor series and Maclaurin series is that Taylor series has a point. Maclaurin series does not have a point. You don't need a point to compute Maclaurin series. But for you to compute Taylor series, you need what? You need a point. Okay, let's start. For example, I want to compute this Taylor series. So we'll do the simple ones, because you guys are already shouting hey, ha, who, he, ha. We'll do the simple ones. I think that's okay by you now. If you like, it's not okay, but you all the best for you. So you have f of x here equals to exponential x. Now with this one, I want to compute the Maclaurin series. Now Maclaurin series here means that you have to follow this order. Now since this is f of x, so that means I have to find f of o. So what will f of 0 give me? That will give me exponential 0, and anything exponential 0 will give me what? 1. Okay, differentiate this. What's the next one you need? The f prime. So f prime of x will give you what? Exponential x, and f prime of 0 will give you what? Exponential 0 to give you 1. Please, are we getting what I'm doing, please? What I'm doing is that from here, this is your f of x. I am working according to the formula I have here. First, f prime of x, and what is f prime of x? That's what the differential of what? The f of x. Then put the 0, and continue. I'll get what I'm trying to say like that. Are we together like that? Okay, good. So from here, I can now have f double prime of x, which is what? Exponential x. F double prime of 0, which is what? Exponential 0 to give you what? 1. Now f triple prime of x, which is what? Exponential x. And this one is what? F triple prime of 0 to give you what? Exponential 0 to give you what? 1. Then here you have fiv of x, which is what? Exponential x. Then you have fiv of 0 to give you what? Exponential 0 to give you what? 1. So you can stop at any point you want to stop. So at my own leisure, how many have I completed? I've completed 5. So let's stop at 5. At least I said you can do as many as you can do. Minimum. If they are after you, they can ask you to find 5 times. So the minimum is 3 third term. That's the minimum is third term. It's a very common piece. So this thing that you're looking at is very, very common. Very common. Very, very common. Are we together now? Please do get what I've done, please. Do we get what I've done, please? So let's now start. Let me now compute them back here. So I can now say that here, my f of x here will give me, that where's my f of 0 here? 1 plus what? X open bracket. Where's f prime of 0 here? 1. Then plus what I have here? X squared. What is f double prime? Sorry, what's f double prime of 0 here? 1 over what? 2 factorial. Plus what do I have here? F triple prime of 0 here is what? X cube. And this one is what? 1 over what? 3 factorial. Then the next one is what? X 4 1 over what? 4 factorial plus dot. Then from here you can now have f of x equals to 1 plus x squared over 2 factorial plus what? X cube over what? 3 factorial plus what? X4 over what? 4 factorial plus dot. So that means with this thing I've written on the board, I have successfully computed the the Maclaurin series of what? Exponential x. Yes, we can do enough for another function, yes. As I said, we will do two types of function. Do for another function. My mind is speaking one function already, safe. I don't want to do a common function. My mind is speaking another type of function. Are we done writing this? Yes, sir. Yes, that's all. Yes. They are not solving. They are just expanding. Yes, sir. They can give you that. You compute the third term of a Taylor series of a particular type of function. Yes, Taylor series, basically Taylor series or Maclaurin series. And if you have to compute it, that means you definitely have to compute the old series itself before you can get the third term. Abi now? Don't worry, your father paid for it now. Did he not pay? He paid now. Do you understand? Can we start? Huh? Laplace. That was in 205. That was in 205. Laplace is grinding. Now you see Laplace, you run away. Are we done writing, please? Okay, good. Now we have done this one type of function. Now the next type of function we want to do looks a little bit scary. Is it scary? I don't want to do that type of function, John. Let me think of another one. No, I don't do exponential x. Do I do tan x? Yeah, let me do tan x. So now here, no, I'm not doing tan x. Differentiation will stress me. Let's do sin x. So here I have f of x. This is number 2. F of x is equals to what? Sin x. Are we together? Then if f of x equals to sin x, that means f of 0, which equals to what? Sin 0, which is equals to what? 0. Now f prime of x is equals to what? Cos x. And f prime of 0 equals to what? Cos 0, which is equals to what? 1. F double prime of x minus sin x. And I have f double prime of 0 equals to minus sin 0, which equals to what? 0. Then f triple prime of x equals to what? Minus cos x. Then what do I have here? F triple prime of 0, which equals to minus cos 0, which is what? Minus 1. Now f fourth derivation, that is what? Sin x. And f iv of 0 equals to what? Cos 0, which is equals to what? Is it cos 0? Sin 0. Sin 0, which equals to what? 0. And last, I'm stopping today, fv of x, which is equals to what? Cos x. Then from here, fv of 0, which equals to what? Cos 0, which equals to what? 1. So from here, let me now compute Taylor series. I can answer that f of x now. What is f of 0, please? F of 0 for sine is what? 0 plus f of, so I have x. What's the f? First f 1 plus what do I have here? X squared. The next one is what? 0. Then what do I have there? Over 2 factorial. Then plus x cubed. The next one I had there was what? Minus 1 over what? Then plus next one here. What's the next one there? X to the power of 4. I've been now. X to the power of 4. And that was giving me what? 0 over what? 4 factorial. Plus the last one here, which is what? X to the power of 5. And this is 1 over what? 5 factorials. So from here, if you want to write the answer here, eliminating all the zeros, so you can have x minus x cubed over 3 factorial plus what? x5 over what? 5 factorial plus dot 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 dot. That is the Maclaurin series of what? Sin x. You can have the Maclaurin series of ln x, because ln x, if you have ln x, you'll be having something that having indefinite, because you keep on having x in the denominator, and as you have x in the denominator, it becomes undefined. Do we get exponential minus x, which is giving me f double prime of 0 to give me exponential 0, which is what? 1. Are we following, please? And so from here, what do I have? F triple prime of x will give me what? Minus exponential minus x. And here, what do I have? F triple prime of 0 should give me what? Minus exponential 0, which is what? Minus 1. Fiv of x is what? Exponential minus x. Then here you have what? Fiv of what? 0, which is equals to what? Exponential 0, which is equals to what? 1. And last but not the least, fv of x equals to minus exponential minus x. That will give me what? Fv of 0 to give me what? Minus exponential 0 to give me what? Minus 1. Are we together? Are we together? Okay. So next time now. So now let's now compute my Taylor series. So macaroni series. So computing my macaroni series here, what will I have? So I'll have f of x equals to, so what is f of 0 there? 1 plus x, f prime of 0 minus 1 plus x squared, f prime of 0, f this one here will give me what? 1 over what? 2 factorial. The next one is what? Plus x cubed minus 1 over what? 3 factorial plus what? x4, which is what? 1 over 4 factorial plus x5 minus 1 over what? 5 factorial plus what? Dot dot dot. You can now feel this one is equals to 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial plus x4 over what? 4 factorial minus what? x5 over what? 5 factorial plus what? Dot dot dot. That's macaroni series. Closing book. Head on. That's your tired, you know. If you are tired, carry your bag and go. You can meet inside exam mode. You hear me? I'll beg you, go. You are meeting exam mode. Do you get that, please? Actually, I'm just joking. Don't go more. So for me, I think I've computed. Taylor series. Macaroni series. Have I done like that? I've done 3 macaroni series. You can go home and go and play with as many functions you can play with. You can probably, if not because of time, you can play with cos x. You can play with it. So if you compute the macaroni series of cos x, although I can tell you what it should look like. Should I say it? So if we want to expand cos x. If you want to expand cos x, that cos x is going to give you 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial. Wait, it's just like the opposite of sin x. While sin x started from x, cos x will start from 1. And so from just that, 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial plus You're blocking my face. Okay. I want to continue new. I think that's all. So I think with this idea, you can compute out. Okay, you can't fathom how to variable will look like. So let's look at Taylor series this time around. Are we ready? Okay, Taylor series. So now in Taylor series, this is what has to happen. Taylor series. And Taylor series, now the first thing I want to compute is ln x at x equals to 1. That's the first thing I want to compute. I want to compute the Taylor series of that function at x equals to what? X equals to what? 1. Are we together? Are we together? Then let's start. So this is f of x. Don't forget that this here is also my what? So a is equals to what? 1. Yes or no? Yes or no? From here, I can say that f of x, which is what? Ln x, then what will be f of a here? So ln 1 will give you what? 0. Then f prime of x will give you what? S is by minus 1. And what is f prime of a? That is 1 raised by minus 1, and that's what? 1. Then the next one, f double prime of x. What do I have here? Minus x raised by what? Minus 2. Then f double prime of a, which is going to give me minus 1 minus 2, which is what? Minus 1. Now f triple prime of x should give me, what's f triple prime of x now? Now f triple prime of x should give me what? 2x minus 3. Then f triple prime of a should give me what? 2, 1 raised by minus 3, which will give me what? 2. Are we together? Then fiv of x. So fiv of x should be minus 6x minus 4. Then I have fiv of x, sorry, not x now, of a will give me minus 6, 1 raised by what? Minus 4, which is what? Minus 6. And fv of x is going to give you what? 24 x minus, what is that? X minus 5. Are we together? X minus 5. Then what do I have here? fiv of a, give me what? 24, 1 is by what? Minus 5, which equals what? 24. Okay, good. So I think I've completed everything I want to compute like that. So let me now start making it up on my Taylor series table. Are we together? This is the formula for my Taylor series table. So I can now say that here, f of x at Taylor series. So what's f of a there? F of a there is what? 0. 0 plus what is x minus a? X minus a, so I have that's going to be x minus 1. Open bracket. Now what is f prime of a? F prime of over 2 factorial. Now plus the next one, which is x minus a cube. Now what do I have? I think I have 2 over 3 factorial. And plus the next one here is x minus 1 to the power of 4. What do I have here? Minus 6 over what? 4 here, if you expand this, it should give you x minus 1 minus x minus 1 all squared over 2 factorial plus 2x minus 1 cube over 3 factorial minus 6x minus 1 is power 4 over what? 4 factorial plus 24 x minus 1 is power 5 over what? 5 factorial plus dot dot dot. That will be my final answer. Yeah, that makes sense. That value for our x is what differentiates that expansion from Maclaurin series. Sometimes, and for this particular type of function, if I do not put a value for it, then it should give me a lot of undefined. Because if I want to leave it at Maclaurin function, if I differentiate it at the first time, that's when I'll start having problem. Yes or no? After the first differentiation, everything else will be given what? Undefined. Sometimes sometimes the point helps in making it look defined. Okay. How does it look like? It looks like what? It looks sweet. Yes, that's the spirit. When you look at something and you tell it that it's sweet, that's the spirit. No matter how hard it is, once you tell that it's sweet, it becomes soft. Actually, there are some sweet things that are hard though. Sweet too, but at the same time they are hard. Alright, so that's the whole excess of Taylor series, right? You drop a pen, We are just planning to enter two variables. Please. See, I've told you if you want to run away, run away. You go and meet the exam and you come back. No. Depends on the type of functions and what the question wants you to have. Sometimes they might change it. They will tell you what to do to the value. Probably might ask you to expand at x equals to 2. And to affect everything I'm doing there. Yeah? I'm blocking you. Sorry. I don't think anybody's working there. Anybody working here again? Is anybody working here again? Nobody. Okay, now let's go to Ojokon. I can ask you all of you to close your eyes so that you're not running away. Smile, fine boy. Open your eyes. Open it. See with your eyes what your father paid for. Two variables. Wait, I supposed to have red marker now. Let me find red marker so that I can use to write it. Now show danger. Abi now. There's danger. It's black. It's black. Wait. Okay, I'm coming, give me a minute. Black, no. I'm supposed to have red now. Don't worry. When you call danger la lane. Danger. That sister is running away. Oh god. Okay, let's go. Maclaurin series. Now Maclaurin series. Sorry, I don't personally. I think I will use the word I've forgotten. So that's why I came with help here. Yeah, let's go and find it. Okay. All right. So. Okay. Okay. If you memorize, you can memorize because you want to go and write the exam. Then after the exam, still get. So there's an hack to knowing it. If you know you have got one, raise up your hand. I'll count 1 to 10. I welcome you on stage. Raise up your hand. 1, 2. Let it be. If you want, let it remain raised. 3, 4, 5, 6, 7, 8, 9, 10. For those of you that raise up your hand, come up on stage. Now, can we appreciate them, please? Let's see. Oh, yeah, quickly, make it snap. Make it fast. Quickly. Sorry, please, can we have Mike? It's part of learning. I think this will be the first class activity I would do ever since I've started. Let there be silence, please. Oh yeah, continue.
X of f of x 0 0, y f of y 0 0. So that is the basic. That is the basics. The first equation, that's for, like, let's say is 0 square. Then moving on to this 1 over 2 factorial. Then this is like saying x plus y square raised to power 2. Put bracket x plus y. Close the bracket. Raised to power 2. Then for this side 1 over 3 x plus y raised to power 3. It will if you expand x plus y raised to power 3, it will give you x cubed plus 3x square y plus 3x y square.
My boy, thank you. We have tried enough. Please, can we appreciate him, please? That's beautiful. Okay, let me hear what you have to say. Okay, that's what you wanted to say. That's what you want to say. That's what you. Okay, thank you very much. Yeah, said whatever I wanted to say. That's beautiful. Thank you very much. Can I have someone? That is beautiful. See, as I told you, you don't literally have to memorize of expansion. Now, in the first thing here, whatever you have here is the same thing as saying x plus y to the power of what? 1. Then moving on to the next one here, the same thing as having what? X plus y to the power of what? 2. And all your derivatives are just following what? That order. This one here is following your x squared. This one is following your what? You see, xy. You see, y what? Y squared. And this third one here will be a what? X plus y raised by what? Raised to power 3. See the same thing. Now the only difference that the Maclaurin series had that this one here does not have, or was that at this point here, I started including a what? A point. At this point here, everything I had was what? But just 0. You don't literally need to what? To like, oh god. Don't worry. Please, where's the guy, Seth? Where's the guy? Thank you, please. Can we clap for him, please? That's beautiful. That's beautiful. I love that. That's lovely. So just don't cram. Just relate it to your normal expansion life. Now, if you want to expand x plus y with this x, since it's a single x, what will follow it? Fx. This one is what? Fy. Now you want to expand x plus y all squared. Then expanding is what do you have here? X squared plus what? 2xy plus what? Y squared. So this squared here will follow what? Fxx, Fxy, and what? Fyy. Then cube 2, you do the same thing. Do you understand what I'm trying to say like that? So that is the only way, sorry, I can I can help you. That's the only way I can help you. So let's take examples on it. MTS department in this house, stand up. You are in MTS and you're inside this building, stand up. MTS and you're inside this building, stand up. Don't waste my time now. MTS, stand up. Be proud now. I am proudly your product. Am I not your product? MTS department, we don't have anyone. I'm looking at one guy here and he's not standing up. Has he gone? Okay, he has gone. Let's save him. Be proud of the department. Now let's look at this thing this time around. Let's look at, want to expand exponential x cos y up to the 4th term. Yes, see, in exams, these are types of questions you will see. You just call the questions. I'm not swearing. I'm not saying that as if I'm saying it so that you can learn it. No. I've passed the stage of begging people to learn. If I don't learn, you come back and come and meet me. All I'm trying to say is that, see, a typical example can come with this same expansion. There's some kind of expansion they repeat. They repeat expansions like exponential x cos y. They repeat the expansion of sin x cos y, sin x sin y. So that the common expansion they repeat. I guess what I'm trying to say like that. So the only thing is that you might, if you know that you cannot memorize this, that's why the fact they even show you the hack, and that your head is not hacking it, then probably you can just have to go home, sit down, and work out as many series as you can work out. Because I can tell you that be sure to expect at least 2 questions from this under this category. At least 2. I'm not swearing for you. You will see it and you come and tell me, by God's grace, I'm still alive and I'm still in futa. So you get what I'm trying to say. So now let's try this. So I want to expand this one, and let me label it here. See, everything I've done here is your first term. Everything here is your second term. Everything here, or better still, yes, everything here from this fine boy here, this end here is your what? 3rd term, and this is your what? This is your 4th term. And one thing that will happen is that as you keep expanding, you start seeing zeros and zeros and zeros, and they'll start leaving. So I would ready to expand this to the what? 4th term. I would ready. I would advise probably you won't write. So probably I'll clean this board. And we expand. And once we are done with the expansion, you can now what? Write as you want. Is that okay? Okay. So that you understand it better. No, we are using the no. I can't do Taylor series with this one. Taylor series is bloody. Let's just do McLaurin. Oh. All right. So now let's start. So this is my f(x, y), which is equals to what? Exponential x cos what? Cos y. Now what is the first thing I'm looking for here? f(0, 0). F will do what will do. So what I can have f(0, 0), which will give me exponential 0 cos 0, which is the same thing as saying 1 times 1 to give me what? 1. Now the next one is what? fx. Now fx means you want to differentiate only x here. What do I have here? Exponential x cos what? Cos y. So fx 0, 0 will give you what? Exponential 0 cos 0 equals to what? 1 times 1 to give you what? 1. Are we getting it, please? Are we getting it, please? Fx here means differentiate only x. Any other time apart from x is a constant. Then you are putting, in your answer, you are putting what? 0 and 0 in it. We get that like that. Okay, good. So the next one here, fy. So what will be fy now? So fy will be, so I have what? Minus exponential x sine y. Then I can have fy multiply 0, 0, which will give me what? Minus exponential 0 sine 0, which is the same thing as saying minus 1 times 0, which is what? Which is what? 0. Now I'm done with this first part. Now the next part here, which is what? fxx. Now fxx means differentiate this on respect to x. What do I have? Exponential x cos y. Are we together? Then this one give me what? fxx open bracket 0, 0. Are we together, please? So I have what? Exponential 0 cos 0, which is what? 1 multiplied by 1 to give you what? 1. Then the next one is what? fxy. What is fxy? Differentiate fx with respect to what? Y, which is what? Minus exponential x sine y. Yes or no? So from here I can have fxy open bracket 0, 0, which is equals to minus exponential 0 sine 0, which is what? Minus 1 times 0 to give me what? 0. Now the next one I'm looking for is what? fyy. What is fyy? Differentiate this one with respect to y again. So I have minus exponential x cos what? If fyy, differentiate only y here. That will give me cos y now. Abi now. So, differentiate fx. This is only what I differentiated in fxx. This one is a constant. Therefore, me, I cannot have fyy. What do I have there? 0, comma what? 0. Therefore, me, I can have, what do I have here? Minus exponential 0. Abi now. Times, sine. It's not sine now. Cos 0, which is same as what? Minus 1 times what? 1, which is what? Minus 1. And I'm done with what? The second part. So let's go to the third part, which is what? F x x x. That means you want to differentiate. You can't finish under 30 seconds. That's why you have to go and practice and memorize it. Yes, I'm serious. It's not as if I wish I had someone that saw the question to come and testify to you here live on stage. Then you believe what I'm saying. But don't worry, you will sit and you come and tell me, and that one's sure. And this what I said is that deal. All right, fxs. So what is f triple x? F triple x is just you are differentiating f double x with respect to x, which will give you what? Exponential x cos y. Yes or no? And this is f triple x, and that's going to give you what? 0, comma 0, which is what? Exponential 0 cos what? Cos 0, which is what? 1 times 1 to give me what? 1. The next one is what? F x x y. What does f x x y mean? You are differentiating this f x x s with respect to y, which will give me what? Minus exponential x sine y. And from here, what do I have? F x x y. Then should give you what? 0, comma 0. Then should give you what? Minus exponential 0 sine 0, which is the same thing as 1 times 0 to give me what? 0. The next one is what? F x y y. So what is f x y y? That means I want to differentiate f x y with respect to y again. So what do I have? Minus exponential x cos y. This will give you f x y y 0, comma 0. Will now give you, what do I have here? That will give you minus exponential 0 cos 0, which is equals to what? Minus 1 times 1, which is what? Minus 1. And the last but not the least is what? F triple y. And what is f triple y? That's you are differentiating f y y with respect to y again, which is what? Exponential x sine y this time around. And this is what? Y y y 0, comma 0, which is what? Same thing as what? Exponential 0 sine 0, which is same thing as 1 times 0 to give me what? 0. Okay, I've completed everything now. Let me now put all of these values back inside this place. So now this will be my answer now. Listen, no. Fx, comma y. Now, what is f00? F000 is what? Is 1. 1 plus the next one is what? X. Now, what is fx of 00? Fx of 00 is what? 1. Then plus, what do I have here? Y. What is fy of 00? 0. Then plus the next one here. 1 over what? 2 factorial, open bracket. So what do I have here? X squared. What is fxx of 00? 1. Then plus what do I have here? Plus 2xy. Now what is xy of 00? Fxy 00. That is what? 0. I go together. Then plus what? Y squared. What is fyy? Fyy is what? Minus 1. I think I'm done with that. Now the next one that I'm left with is what? Is the third one. So plus 1 over 3 factorial, open bracket. So what do I have here? X cubed. What is f triple x of 00? 1. I have 1. Then plus what do I have here? 3x squared y. Now what's the next one? fxxy. That's what? 0. Then plus what do I have here? 3xy squared. Now what do I have here? fxyy. Fxyy. That's minus 1. Then plus the last one, y cubed, which is the same thing as what? I think that one is giving what? 0. Are we ready? So now let's now combine everything together. Your final answer here will now give you 1 plus, let me adjust it small. I'll give me 1 plus x plus 1 over 2 factorial, open bracket, x squared minus y squared. I'm done. Then plus 1 over 3 factorial open bracket x cubed minus 3xy squared plus dot dot dot. That's the final answer. So you want to screenshot it? You can screenshot it. Yes, sir. Tell me that if they were, I personally don't like punishing people with long cut if I know you wish to shortcut. If they were, I will tell you. But the only way that they exist is, fine boy, go and study as many as you can study, solve as many as you can solve, and you'll be fine. So that's the answer. Should you do another one before we move? Yeah, write this one down. Okay, yeah. Write it. I'll give you time to write. So write it. Huh? No. What's his name? It's more than water. What are Africa is doing me? MTS. That's fuck up. Seriously. I'll fuck up. Why? Why don't you want to stand up? You're proud. So the next one we'll be looking at now. So I think we have treated Taylor series of two variables. Next one we're looking at now, we're looking at Jacobians. I'm looking at Jacobians. Jacobians is just, I will just teach you. But I won't go deep in it, just for you to be safer. It's better for you to know it and not to see it than for you not to know it and you see it, not even see it once. Now see it in what? Multiple foods. I think there was one question I did then. I remember. It was a multiple integration question. I can't forget the question till date. The question came back to me 3 times in my test, and I picked 3 different answers, hoping that one of them will be correct. And at the end of the day, all of the answers I picked were very, very wrong. Yeah. So that's how it can be sometimes. They might repeat the same thing twice or 3 times, and you that don't know it's the first time, you guess. Second time again, guess. Third time again, guess. Anyway. I'm waiting, please. So we look at Jacobians. I'll teach you Jacobians briefly, so that we'll just be on a safer side. Just to be on a safer side, literally. It will be better for you to see it, as I've said. Not to see it, but you have an idea of it. Now for you to see it and you don't even have any idea of it, that thing pains a lot. It pains a lot, eh? So now, how many subtopics have we done so far in partial differentiations? How many have we done so far? See, I think we started this morning, and we have said, oh wow, this is how far we can go. Really? We've tried. Can you clap for yourself, please? That's that. I love that. You guys, you worth it. You tried. We started this morning and we have gotten this far. Now that one is simple. I don't know whether I'll teach in class of I'll teach you. My God's grace. I'll teach you. At all. Are we done writing, please? Please, let's write quick. The next time we'll be meeting on 201. I think we'll be talking more on, we'll now move on straight up to integrations. So we'll be talking more on multiple integrations, line integrals, all those kind of stuff. We'll talk about them. So go and prepare your mind. Yeah? When next are we meeting again? Huh? No vex, sorry, my dear. No vex. Please, are we done? If you are still writing, raise up your hand, please. Let me see you. I'm still much. Damn, yeah. Write quick. Please write quick, please. Make it snappy. Yeah, write fast, please. So. Yeah. I'm waiting now. Okay, I'm blocking. Oh yeah, sorry. Should I sit down? I think if I sit down. Okay. Thank you. I sit down very well. No. Don't let me sit down very well. No. That's I've been now. First time. Wait, it's true. Okay, there's still something you're supposed to know. A grand method of undetermined coefficients. A lot of this you have to know, my dears. Okay. Alright, I'm waiting. Please, if you are done, just roar so that we can start. Okay, this is what will happen. What is the time now? It is 19. Once it is 22, we start. Whether you are done, whether you are not done, I'm not concerned. 22. That's about 3 minutes from now. So let's be fast. Write as fast as you can. At least I'm not standing on the boat now to disturb you. Am I? No, I'm not. My joy is that's my joy. That's why I'll be here for you till as long as you want me to be here. I will write in, please. Okay, I said 22. It's 20. Get ready to stop. All right, let's start. Okay. Sorry. All right, so I said, let's look at Jacobians. Jacobians, just to be on the safer side, it's a part of a subtopic of partial differentials and partial derivatives. Jacobians. Jacobians. And I promise that I will teach you I'll make it as brief as possible. So if you are functions of x comma y and their derivative are expressed such as so this is Jacobians. So it's just like how do I call it? In MTS25, whenever you are talking about linear dependency and verification of solutions, you will still talk about Wronskian functions. I don't know, have you heard of it before? Wronskian functions, MTS25. The one, if they have not taught you, they will teach you. And if they did not teach you, I will teach you. All together. A Wronskian function. I'm not talking about Wronskian, but this one here is like a Wronskian function. So if peradventure, if for example you have a function u and v written at times they are a function of both x and y, and they want to express their derivative in matrix form, which is in this format, then this kind of matrix is called as what? Jacobians. So it is Jacobians that the matrix is called Jacobians, and it is either written in this format or this format. So we'll just take probably a few examples on it so that we'll be able to master it. So anywhere we see it, at least even if it might not come out or it may come out, I don't know, I cannot say, but it's part of partial derivatives. It's like under the subtopics of it, so it is advisable to learn it. All together, please. So now, okay, now let's look at this is we have three types. There are two types of Jacobians. The Jacobians of when we have two variables, which is your x and y, just like as I've done, or Jacobians when you have probably You have something like this: partial u, partial x, partial u, partial y, partial u, partial z, partial v, partial x, partial v, partial y, partial v, partial z, partial w, partial x, partial w, partial y, partial w, partial what? Z. Now this is another Jacobians too. Yeah, but the first Jacobians that I drew here is what? Jacobian of what? Of two. I get in of two functions. Second one I've drawn here is what? Jacobians of what? Of three functions. So let's take examples so that we can know how to represent functions on what? On Jacobians. Are we ready? Okay, good. Let's take example number 1. Examples. All right. All right, so let's look at this. Let's look at this. Now, this one says that if you have x equals to r cos theta, and at the same time that you have y equals to r sin theta, the question asks you to evaluate something that looks like this. And that's first thing I wanted to know, that whenever you have something that looks like this, it's first of all advisable for you to create your what? Create your working principle. Create your process to it. So if this one here, x comma y over what? Partial r comma theta will be written in this format, which is what? Partial x, partial r, partial x, partial what? Theta, partial y, partial r, partial y, partial what? Theta. Please, you see how I'm written it. It's not that actually I swapped. It's not that I did partial x, partial r, partial y. It's not x, y. It is x, x, y, y. I get what I'm trying to say like that. Please note that. Don't make that mistake. I get what I'm trying to say like that. So from here, so let's now find partial x, partial r. So partial x, partial r means you want to differentiate this with respect to r. What would that give you? Cos theta. Yes or no? Yes or no now? Abi now? Good. Now partial y, partial r. Or partial y, partial r give you? Sin theta. Yes or no? Now partial x, partial r. Abi? No, partial theta this time around. So now if I want to do this one, I have minus r sin what? Theta. Are we together? Then partial y, partial what? Theta here will give me what? R cos what? Theta. So I have all of these variables here. Then what do? I can write and put all of them inside this what? Inside that matrix. So I can have first one here will give me what? Cos theta sin what? Theta. The next one is minus r sin theta. And this one is what? R cos what? Cos theta. Then if you take the determinant of this matrix, I hope you know how to find the determinant now. Yeah, you can find the determinant, which is what? This times this multiplied by, subtracted by this. So for me, I can have r cos squared theta minus r sin squared theta. So from here, I can have r cos squared theta plus what? R sin squared theta. And if I factor out r, then I have what? Cos squared theta plus what? Sin squared theta. And everything gives me what? R. That's how my Jacobian is. My Jacobian is very simple. It's just a way of what? Representing, what's it called? Representing derivatives and functions on what? In matrix. It's very, very simple. Yes, ma'am. Ma? Wait, this times this. This one here. Okay. The thing is, this one here is partial y, partial r. Okay, it's supposed to be. Oh, thank you for that. Thank you. I made a mistake. Thank you. Sorry. So what is, I think the first one is cos theta minus r sine theta. And what do I have here? Sine theta over what? R cos theta. Have you now? Okay, so this one has changed. And at the end of the day, I still have what? R cos square theta minus r sine square theta. Right? Yes or no now? Yes or no? Then this determinant is this times this minus this times this now. And I have r cos squared theta plus what? R sine squared what? Theta. Then r is common here. Cos squared theta plus what? Sine squared theta. And everything should give you what? R. Right? That's how it is. It's very simple. Just a way of what? Representing derivatives on the what? On the in matrix. That's how it is. Matrix 3 by 3. So let's look at this. Now if you look at this one here, what will I have? And first thing I will have is this. So let's create the table first. All I have, so I have partial u, partial x, partial u, partial y, partial u, partial z, partial v, partial x, partial v, partial y, partial v, partial z. And from here I will have partial w, partial x, partial w, partial y, partial w, partial what? Z. So I think, now, this is what I would have. And so from here, let's start working it out. So partial u, partial x in this case, what would that give me? Yz. Yes or no? Partial u, partial y give me xz. Partial u, partial z give me xy. And next one, partial v, partial x. What the partial v, partial x give me? That'll give me y plus what? Z. Partial v, partial x, partial y now, give me x plus z. Partial v, partial w, partial v partial z. That's giving what? Y plus what? X. And last one, partial w partial x gave me 1. Partial w partial y gave me what? 1. Partial w partial z gave me what? 1. So I think I have completed everything I needed, right? Yes or no now? Then I've completed everything I needed. Then what else do I have to do? Just put everything back inside my determinant. That everything here can now yield to. So what do I have? I have yz, xz, xy, y plus z, x plus z, y plus x, 1, 1, 1. Are we together? Abi now? Abi now? Stuck now? I wanna learn the vex. I wanna go the vex. If I go the vex. So from here, if you expand this one here, what will you have? You can have yz, yes or no? This one will leave out, this one will leave out, so I'll have x plus z minus what? Y plus x my side. This will leave, this minus this, then next one is minus xz. Then what will I have? Y plus z minus what? Y plus x, yes or no? Abi now? Are we doing together, please? And the last one is what? Xy. So what is xy? That is y plus z minus what? X plus z. Are we together? And from here, I have yz. If I open the bracket here, what do I have? X plus z minus y minus x. And minus xz. What do I have? Y plus z minus y minus x. And here, what do I have? I have plus xy, which is what? Y plus z minus x minus z. I think from here, this one and this one will cancel. This one and this one will cancel. This one and this one will cancel. And at the end of the day, I'll be having yz open bracket z minus y minus xz open bracket z minus x, then plus what? Xy open bracket y minus x. That will be the final answer. That will be the final answer. You get that? Okay. Okay. How many of you were present in the morning when I started partial differentiations? You know, okay, put your hands down. Let's do it like this. You know, you were not present in the morning when we talked about partial differentiation. Raise up your hand. What the heck? Well, you had the note. Let me see your hand. Sorry, again. Away. I did not understand what I'm teaching you. No. I didn't mean it like that. Like, you just missed the prerequisites. Okay, no problem. Because that's what I'm just planning to do. So, no, I will reteach you guys. We'll do some examples about it, and I think everybody will be balanced by that. Abi now? I think that would be a very good idea. Yes or no? Okay, good. And so far, so good as I'm concerned. Well, I've reached my threshold for partial differentiations with you guys. So let's talk about everything from the beginning. Yes, from the beginning. From the beginning. Are we together? I think we are done with this part, aren't we? Are we not? Okay, good. That's if it's come. This is pursuing it. Yeah. Don't give it to him, please. Sleep. Now this morning we talked about partial derivatives. Those of you that have learned before, you can still pay attention to relearn. Learning does not end. And even said the examples we did before are not the examples I'll be doing now. might be a little bit complex, but it still be the same thing. So we talked about partial differentiation in the morning, if you can listen. And that partial differentiation, I remember that I told them that partial differentiation comes from two keywords, which is what? Partial and what? The differentiation for itself. So I believe that there should be no one here sitting and looking at me eyeball to eyeball, or hearing me hears drum to hear drum. Which part again can we do again? That doesn't know how to differentiate. Yes, I don't believe there's anyone that can differentiate here. I don't believe. If you raise your hand there. Now, we now start about, okay, partial differentiation is just one type of differentiation that, although it works on the fact that you have to differentiate, but it makes use of preferences. That is, you have to differentiate to one and leave the other what? Constant. And differentiate the other and leave the first one what? As a constant. Do you understand? So let's check out these examples together. All right, so, I don't know. Oh, this one looks mature to me. Let's find something eatable in this place. It's just that everything is just proving. That's why. All right, let me start. Okay, let's say, for example, I want to differentiate. Okay, and next time I need your phone, please. Sorry. Let me use put that PDF. Thank you very much. All right. So now let's take a look at this differentiation. Let's say that u here is equals to 5x to the power of 4 plus 2x cubed y squared minus 3y. I'm getting it. All together. Now let's look at something like this. Something like, oh jeez. Now for example, something like this. So now how do we deal with this differentiation? And you notice that first thing first is that in this differentiation, you notice that you have, how many variables do you have? You have 2 variables, yes or no? And I remember I told the people that were around this morning that number of variables you have in any function determines how many answers you will have, yes or no? If you have 3 variables, just know that at the end of the day you have how many answers? You have what? 3 answers, yes or no? Good. So if that's going to be the case, so from here, how many variables do I have? I have 2 variables. I can start with ux. Now what is ux? Ux is the same thing I was talking about, partial u, partial x. And what is partial u, partial x? Now partial u, partial x is means that you are only concerned with differentiating whatever x that you can find. And that thing apart from x will be treated as a what? As a constant. So let's start with that. So if I differentiate this, what do I have? 5x to the power of, no, I have 20x cubed, then plus here 6x squared y squared. Now I hope you know why your y squared is still there. I mean now it's just like the same reason why if you differentiate 10x raised to the power 5, that you have what? 50x raised to the power 4, right? So that's the same reason why this one is there. So from here, please also note that uy in this case here, uy is what? Partial u, partial y. So differentiating with respect to y, what do I have here? 4x cubed y, 4x cubed y minus what? Minus 3. This is what you have. I'll get what I'm trying to say like that. Now the next thing that we'll do here is uxx. Now uxx means a partial square u over what? Partial x squared, and their higher derivatives, and that means that you want to differentiate your ux again with respect to what? Respect to x. Are we getting that? So if I differentiate this answer again with respect to x, what do I have? I have 60x squared plus what? Plus 12x y squared. Then the next one you want to deal with here is what? Is uxy. Now uxy is known as partial square u over what? Partial y, sorry, partial x, partial y, which here will give you what? All this one gives you. So what this one means is that I want to differentiate ux with respect to what? Y. So if I differentiate this one, what do I have here? I have 12x squared y. And last one, second to last one, uyy, which is partial square u partial y squared, means you want to differentiate this answer again with respect to y. And what do I have here? 4x cubed. Please, are we getting it, please? Are we getting it, please? Huh? Let's talk you. Are we getting it, please? Yes. Okay, good. I'm getting it. And the last one here is partial, sorry, will be uyx. Yes or no? Yes or no now? So now uyx, what does uyx means? Partial square u partial y partial x, which means you want to differentiate uy with respect to what? You want to differentiate uy with respect to x. What do I have? 12x squared y, which is the same thing as what you have there. Yes or no? Abi now? Okay. So that's very good. So you can have another example, which is this one here, given that y is equals to 4 sine 3x cos what? 2t. Let's have this example. I want to differentiate this. Yeah, if you have two variables, you have two answers. Now, these ones here are just the same answers, but they're just higher derivative. Just like your dy dx, the square y dx square, all of this kind of stuff. So you get my point like that. Okay, good. So from here, so now let's deal with this. So I can say that y, let's say that y underscore x. So what is y underscore x, everybody? 12 cos what? 3x cos what? 2t. Yes or no now? Yes or no? Please now, let's respond. Yeah, we can know that I have people that are here. I'm doing this thing because of you guys. So. Are we together? Are we together, please? Now the next one here is what? Yt. What is yt? So yt means to differentiate only t here. Then if I differentiate, what do I have here? Minus 8 sine 3x sine what? 2t. Yes or no? Yeah. Okay, good. Then if you want to differentiate yxx, that means differentiating this one, what do I have here? Minus 36 sine 3x cos what? 2t. Then y, the next one is what? Yxt. Now what is yxt? Now yxt means you want to differentiate yx respect to t, which will give me minus 24, Abi? Minus 24 cos 3x sine what? Sine 2t. Yes or no? Yes or no now? Yes. Okay, good. Now what else remain again? Ytt. So what is ytt? Measure this with respect to t again. So I have minus 16 sine 3x cos what? Cos 2t. So this will be that will be that about that. Are we together? Okay, so that I think that with that we can be able to recall what differentiation is all about now. Yes or no? That's the basic concept of partial differentiations. Now the next thing we talked about in the morning, we talked about total differentials. On total differential, so suppose you have your u, which is written as a family of function of x, y, w, v, and et, let me just put dot dot dot, and you want to find the total differential of du. Du is equals to partial u partial x plus partial u partial y plus partial u partial what w plus partial u partial v plus dot dot dot. So this is what total differentials talks about. Now how do we deal with total differentials? Yeah? Yeah, there's no need for me to look for ytx because ytx is also the same thing as what? Yxt. Yeah. Ytx will give you what? Yxt. Just as uyx gave me what? Uxy. Because it's not differentiated very well. Yeah, if I differentiate it, give me the same answer. Should I try? Okay. Ytx, I mean. What is ytx, please? Yt, so differentiate with respect to x. What do I have here? Minus 24 cos 3x sine 2t. I want to give you the same answer. Should give you, my God's grace, fine boy. Now let's look at this. So we want to find the total differential. For example, now you have a function here. The function that you are giving here is z, and z here is equals to x squared y cubed plus 2x over y plus 1. I want to define the total differential of this one. And please note that total differential is also known as what? Dz here, in this case. I'll go to I'm trying to say like that. So I can say that z here, rewriting z, I can have xy cubed plus what? 2x y raised by what? Minus 1. So from here, I can say that dz is equals to partial z partial x dx plus what? Partial z partial y dy. So what is dz? What is partial z partial x? Differentiate with respect to x, what do I have here? Y cubed plus what? 2y minus 1 dx plus differentiate with respect to y. I have what? 3y squared minus 2x over y squared, everything here, dy. That's the concept of what? Total differentials. Any question, please? Now, this one here, whatever you just need here is that the total differential is what? Where? Okay. I just put x square and change the question too. It's balanced like that. Good. If your bit balanced like that, the bit balanced like that. Good. Now, what does this one state? This one states that the only thing you have to do here is that first of all, rewrite your question and differentiate partially with respect to the number of independent variables that you have. Then put them in this your formula that you have there. As simple as that. Let's look at another one that we can do. Okay, let's say you have right, so then by differentiating this one, what do I have? What is partial z partial x? So differentiate only x here. So you have if you differentiate only x here, what do you have here? 2y plus what? Sine x dx plus, if I differentiate only y, The next one we talked about was what? Was rate of change. Isn't it? Isn't it? No, was it rate of change? No, we talked about chain rule. Yeah, we talked about chain rule. I remember we used family to explain chain rule. Yes or no? Yeah, you can probably get the notes. Everyone that came in the morning were blessed. Have you now? So you can explain, get them to explain to you. You understand? I can vouch for that. You understand? We talked about chain rule. Then after that chain rule that we talked about, what was the next thing we talked about again? We talked about rate of change. So we talked about rate of change. It was rate of change we were discussing. I think we did how many examples? About 2 or 3 examples. 3 examples. I think, okay, we did 2 examples. We were dealing with the examples before we called the class an end this morning, isn't it? Okay, so, okay, that's actually very good. So now from that rate of change, we continue from what we did today. Where? We continue from what we did today. Abi now. So what did we start? What did we start with from today? We started with what? We started with what? Yeah, we started with small increment. Then small increments, we moved on to what? Extrema. Then from extrema, we move on to what? Taylor series of 2 variables. Yes or no? And from Taylor series of 2 variables, I think we talked about what? Jacobians too. Abi now. I think we have covered about, like, if not all, we've covered about a large percentage of what? Partial differential what? Equations. So I think, yeah, with this stuff that I've taught you guys, if you go home and you go and practice, by God's grace, you surely pass. Yeah, by God's grace, you surely pass. You surely pass. I give you my words, and I trust God to back up my wordings. You surely pass. So, and another thing again, I will tell you that MJS21 is CBT. The fact that CBT requires that you have to put more energy, you have to put more support, and all of this kind of thing inside. I'll get what I'm trying to say like that. It is very and highly required. Highly required. Hey, calm down now, Mr. Become alone now. Hey, you're calming down. Your sister that was sleeping also. You don't want to go and now open your eyes. No, the thing is that I love it when you guys come back and you see me, probably in the future. Thank you very much for that night class we had. This happened. Yeah, I think I collected these things from someone. Did I not? Okay, thank you. So, also, rounding up, I just want to use this period of time to say it has been a beautiful time spending with you for this last 3 hours. I really appreciate that. Thank you very much, and have a nice time. So I welcome the next set of persons as we journey again. Oh yeah, quickly. Oh yeah, let's start quickly. So I want to start. I'm just 301. I'm just 309. So this course wanted to show me Shaggy yesterday, but don't worry, I'm prepared for the Shaggy of the course today. So you see, I'm throwing the hand. How are you doing now? All right. So now this is how our map will look like today. Our map will be focused on series solution. Are we getting it? Series solution to differential equations, and by God's grace, we will solve probably. I'll make sure that all of us will be able to solve. I think I can solve probably maybe. I budget 4 4 linear differential equations that we can solve with series. But if you can solve it, then after that, when I enter, I will introduce you guys to Frobenius method. And Frobenius method, you can now enter, go on, and we can start building up ourselves from there. Are we together? Now, do you have anybody that is with phone that you can say quickly get questions, and let's start breaking some heads? Like that thing yesterday pained me a lot. I couldn't do it. I was making mistake, all that kind of stuff. Do you have anybody with questions? And let's start quickly. We don't have time. Anyone? Probably if you have with the past question, yes. You have the past question. Let's start series solution quickly. All right, good. So for this part, okay, let's start with this solution. I want to solve this. All together. Let's solve this one. This will be the first one I'll be solving together, which is y double prime plus xy equals to 0. Now let's start by solving this. So this will be the first thing I want to solve. And I remember that I told us yesterday that while we were solving, anytime we want to solve something like this, what will be our solution? Our solution will start from what? Y is equals to summation of n equals to what? Infinity. 0 to what? Infinity cn x to the power of what? S to the power of n. Are we together? Now let's solve this. So from here, and I told you that the number of times you differentiate what will happen here will affect this answer here. From here, I will have y prime. So by y prime means I will differentiate. So if I differentiate this one, what do I have here? N equals to 1 to infinity. You have n cn x to the power of what? N minus 1. Are we together, please? Now the next one here, y double prime, which is equals to, here will give me n equals to 2 infinity n open bracket n minus 1 cn x n minus what? X n minus 2. Are we together? Now so from here, let me now substitute everything I have back inside my general equation. So by substituting that back, what will I have? What is my y prime prime here? So this is it. So I can have summation of n equals to 2 to infinity n open bracket n minus 1 cn x n minus 2 out together plus x summation of what? N equals to 0 to infinity cn x n out together. Please. So now from here, okay, everything is equals to 0. Now from here, if this x here multiplies this one here, what will I have? You'll have n equals to 2 infinity n minus 1 cn x n minus 2 plus, now infinity n equals to 0. And what do I have here? Infinity, right? I have what? This will be what? Cn xn plus 1 equals to what? 0. So now there are two things you have to do first of all before you start solving. Now the first thing you have to do before you start solving is that you try as much as possible to what? Make your x have the same power. That is very, very important. And also again, make your words make your summation start from the same value. Notice that this one here started from what? N equals to 2, and this one here started from what? N equals to 0. Now it is mostly advisable that whenever you want to do this, try as much as possible to try to make your x start from the same place first. I get what I'm trying to say like that. So from here, I can say that let n minus 2 equals to what? Equals to m. I can say that let n minus equals to m. Then for me, I can say that n is equals to what? M plus what? Plus 2. Yes or no? I will get what I'm doing, please. I just want to find a way to make this n minus 2, the power of x here, have the same thing here. I'll get what I'm trying to say like that. So I have n equals to m plus 2, and this one means that when n equals to 2, what will happen to my m? M2 will give me what? M will give me 0. Yes or no? Yes or no now? Okay, so I'm done with this part. So let's move on to the second part here. Now moving on to the second part here is when you have x to the power of what? N plus 1. Abi now? Now what do? I can now say that let n plus 1 equals to what? Equals to what? M. Are we getting it, please? Then if we let n plus 1 equals to m, then I can say that my n is equals to what? M minus 1. I'll get what I'm trying to say like that. Then from here, I can say that, so when n equals to 0, what will happen? M will give me what? 1. Yes or no? Yes or no? So now, so from here, let's now work with everything that we have done here. Let's put it back here. So from here, this is what we'll have. This is what I will have. Yes. N equals minus 1, no. No. Then that from here, I was working with this number here. If n equals to 2, I have to substitute inside this place to get the corresponding value of m. So I'm trying to like that. Now, so from here, so let's now start. So from here, I can now have summation. Now, instead for me to have n equals to 2, at n equals to 2, what did I have here? At n equals to 2, m equals to 0. So I have m equals to 0 here. Then what do I have here? I have infinity. Please, are we getting it, please? Then the next part here, instead for me to have n, what is my n here? My n is what? M plus 2. I have m plus 2, sorry. This is m plus 2 multiplying, what would that be now? M plus 2 minus 1. Then what do I have here? C m plus 2. And at the end of that, I have x. What is n? N is what? M plus 2 minus 2. Are you getting that? Then, because moving on to this side here, I have exponential, which is what? When n is equals to 0, what do I have here? M is equals to what? 1. Then I have this one to be what? Infinity. So since this one is infinity, what will I have in this side here? Where's my n? My n equals to what? M minus 1. No, it should be n minus, it should be c m minus 1. Then x open bracket m minus 1 plus 1 equals to what? 0. Are we together, please? Are we getting it, please? So now, so from here, if you break this one down, this one here can give you what? M equals to what? 0, infinity. What do I have here? M plus 2. This will give me what? M plus what? 1. This will give me what? Cm plus 2. This will give me what? Xm. Are we together? Then plus, what would this one give me here? This will give me m is equals to 1, infinity, cm minus 1, x raised to power m equals to what? 0. I will get one apprentice like that. Now, so from here, now I have achieved one goal. And what is the goal I achieved? I have successfully moved, I've made all the power of x equal to each other. Now, the next problem that I have to solve is that I have to try as much as possible to what? Make them start from the same what? Same starting point. I think the best way to do it is by moving this point just one step further. I get my apprentice like that. Now, so if I substitute 0 inside this place, what will I have? I'll have 2 multiplied by 1, and then multiplied by c2 x naught. Are we together? Then plus, then since I've moved this one by 1 point, then I will have what? Summation of what? M equals to what? 0 of infinity, not 0 now, 1. I have m plus 2, m plus 1, cm plus 2. What do I have here? X to the power of m plus what? Summation m equals to 1, infinity, cm minus 1, x to the power of m equals to what? 0. Do you get what I've done, please? Do you get what I did? So from here, if you open this bracket here, what do I have? You have what? 2c2, I was getting x naught plus. Now you can factor out, you notice that everything, what is common in this part here? M equals to 1, infinity, yes or no? Then I can bring this one to be what? M plus 2, m plus 1, cm plus 2, are we together? Plus what? Cm minus 1, and everything multiplying what? X to the power of m equals to what? 0. I'm getting it, please. Are you getting it, please? Okay, good. So from here, what will happen? I can have this one here, and I have 2. Let's say from here, let's say I'll now have comparing terms. So if I compare terms, what am I comparing to? 0. So I can say that 2C2 is equals to what? 0. And from here direct, I know that C2 here equals to what? 0. Are you getting it? Now the next step here will now be what? M plus 2, M plus 1, Cm plus 2 plus what? Cm minus 1 equals to what? 0. Then from this part, it is always advised, sir? Do you understand? So now from this part, it's always advised that the bigger one is made the subject of the formula. And if you notice that Cm plus 2 is bigger than what? Cm minus 1. So let's make Cm plus 2 the what? Subject of the formula. So from here, I can have Cm plus 2 equals to minus Cm minus 1 divided by what? M plus 2, and this is what? M plus 1. This is where I can now start my what? My recurrence. Start imputing. So now, as far, I don't know if it were to be this man that was with me, then what is his name now? Okay, I don't think I can mention his name. It was the person that taught me then, that is teaching you now. I think it would be best if we had moved this one up to probably 9 times when m equals to 9. Although you wish space. Literally, you don't have to go as long as you want to go. It doesn't have a finishing, it doesn't have what? An ending. You can keep on going and you keep on getting an answer. You get what I'm trying to say like that. So it's just advisable to stop. But I would also say that since it's still going to be around, and I think he taught you in the first class of this topic, so let's just do this one up to 9 or 8 preferably. So let's start. So when m is equals to, now please, I hope you know that this part here, I cannot put when m equals to 0 here. Do you know why? Because if I put when m is equals to 0, I will have what? C negative. And I must not have a negative underscore. I'll get what I'm trying to say like that. So from here, the only thing I can start from is by saying when m equals to 1. Then when m equals to 1, what do I have here? I have C3, which is equals to minus C naught over what? 2 plus 1 multiplied by 1 plus 1. Are we together? Then I can now say that C3 is equals to what? Minus C naught over what? 3. I have 3 multiplied by what? By 2. I know it's 6, but let's just leave it like this for now. Now this is what I will have. And the next one is when m is equals to what? 2. So when m equals to 2, what do I have? And I have what? C4. Are we together? And by having C4, then what will I have? I will have minus C2 minus 1, which will give me minus C1 divided by, are we together? Then if I put 2 here, that will give me what? 4 multiplied by what? By 3. Are we getting it? And the next one, when m is equals to what? 3. So if I do when m equals to 3 here, so what will I have? I will have what? C5 equals to what? Minus C. What will I have here? C is 3 here. That's 3 minus 1. That's give me minus C2 over that's 5 multiplied by what? 4. But I can't be able to compute this one because already here, what happened? My C2 is 0. So if my C2 is 0, automatically my what? My C5 is also equals to what? 0. All together. Let's continue computing. I can say that when m is equals to what? When m equals to 4. If m equals to 4, yeah, what do I have here? I have C6. Have it now? Equals to minus C3 over what? That is going to give me 6 multiplied by what? 5. Then from here, initially, I know the value of my minus C3. What's my C3 here? My C3 was minus C naught. Then what will I have here? I will have C6 equals to minus C naught over what? 3.2. Everything divided by what? 6.5. Then if I write this one very no, yes, then what is my C4 here? My C4 is minus C1, so I can have C7 is equals to minus open bracket minus C1 over 4.3, then everything divided by what? 7.6, then C7 is equals to what? C1 over 4.3.7.6. Are we together? And this is when m equals to 5, so I can start when m equals to 6. So when m equals to 6, if I put 6 here, I have what? C8 equals to minus C5 over 8.7. But already I know that my C5 is what? 0. So automatically C8 is also equals to what? 0. The next one I'm doing here is when m equals to what? 7. So putting when m equals to 7, what will I have? I will have C9 equals to what? Minus C6 over what? 9.8. What is my C6 here? My 6 is what? Is C0. So open bracket C0 over 3.2.6.5. Please, are we getting it, please? Then everything divided by what is C at 9.8. Then your C9 can I give you what? Minus C0 divided by 3.2.6.5.9.8. Stop me here. I'm stopping here. So from here, what will I now have? I will have what? C10 equals to what? Minus C9 divided by what? 10 dot what? 9. And what is my C9 here? My C7, sorry. C7 here is this answer. You can have C10 equals to what? Minus C1 over, bring everything down to this side, 4.3.7.6.10.9. Let's stop there. I can now, after this, I can now say that recall that. So you can call it solution to a series differentiation. So from here, if I break this one down, I can have what? C0 x0, C1 x1, C2 x2, C3 x3, C4 x4 plus C5 x5 plus C6 s6 plus C7 x7 plus C8 x8 plus C9 x9 plus what? C10 x10 plus what? Dot dot dot. So from here, do you understand, please? Are you getting this, please? And so from here, give me what? C0 plus C1x. Then what is my C2 here? My C2 was 0. Happy now? Then what is my C3? My C3 was what? Minus C0 over 3.2 x cubed. Are you getting it, please? Then what is the next one? C4. What is C4? C4 is minus C1 x4 over what? 4.3. Then plus the next one is C5. And what is C5 here? 0. Then plus what is my C6? My C6 is what? C0 over 3.2.6.5. And everything is what? S is power what? 6. Then from here, I'm thinking I'm in 6, then plus C7 as C1 x7 over 4.3.7.6, then plus 0 minus C0 over 3 that's C0 9, C0 x to the power of 9, 3.2.6.5.9.8, and finally here minus what? C1 x10 over what? 10.9.6, 7, 4, and 3. So now I've just expanded. Since I've just expanded, one thing that you will notice is that almost everything that is here is written in terms of C0 and C1. Happy now? Now let's now start categorizing it. Let's bring all C0s together and let's bring all C1s together. Now doing that, next I'm having here is what? Minus C0 x cube over what? 3.2. Next C0 is this plus C0 x is power 6 over 3.2.6.5. Now together, the next one again minus what? C0 divided by 3.2.6.5.9.8, and everything here x is power what? 9. And the next one again plus, now let's gather the C1s now. Then plus C1, I have C1x, then minus C1x4 divided by what? 4.3. Then the next C1 here plus what? C1x7 over what? 4.3.7.6. Then minus C1x10 over 10.9.6.7.4.3, and everything plus dot dot dot. Then from here you can now remove your C0, and I remove your C0. Then if you remove your C0 here, what will I have? 1 minus what? X cube over 3.2, then plus x6 over what? 3.2.6.5 minus x9 over what? 3.2.6.5.9.8. Are we together? Then plus what? Dot dot dot. You can close your bracket. But this dot 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 means that you don't know how many C0s you can have again. Then plus next one plus C1, which will now give you x minus what? X4 over 4.3, then plus what? X7 over 4.3.7.6, then minus X10 over what? 10.9.6.7.4.3 plus what? Dot dot dot. Now you can now say that general solution is given as, so y equals to y1 of x plus y2 of x. Now where your y1 of x will be everything for your C0, which is what? 1 minus x cube over 3.c plus x6 over 3.2.6.5 minus x9 over 3.2.6.5.9.8 plus what? Dot dot dot. And your what? y2 of x will now give you x minus what? x4 divided by what? 4.3 plus what? x7 over 4.3.7.6, then minus what? x10 over what? 10.9.6.7.4.3 plus what? Dot dot dot. Just finish the solution like that. Alright, I'll finish solving. So that will be the solution. So I would highly recommend that probably we just for, I think we still have time, probably we just practice 2 more. Now the strength of 309, based on what I can see from my own time, was they dealt a lot with us with Fourier series, Fourier transform. We did a little of these differential equations. Then they give us partial differential equations too, Strombolians too, so all of this kind of stuff. But I don't know how this your semester will be. I will just advise. In our own time, they did not give us Bessel equation. He didn't even teach yourself. Although he mentioned it in class that hypergeometric, Legendre, he said it in a way that was scarce that you can read about it. But it didn't come out in test and what? An exam. Did it inside class for you too? He gave you characteristics. The fact that I gave you characteristics means that, I don't know, I can't see. It's only God that owns his heart. That man is, it's only God that owns, so I can't see. So I would just say probably for more practice, in case of higher, because you still be needing this thing here. Probably if you enter, I think 400 level, yeah. That's for him. You still be needing it more. So I cannot say that we'll probably just practice probably 2 more questions on series solution. Then we'll move on to probably them, what's his name? Them gamma beta functions and all of those kind of stuff. Is that okay? Okay, good. Now the problems, I am not with any textbook. This one does not have any. So if you have any questions, we can just bring it out and we solve. Series solution. Do you have anyone? Apart from the one in past questions. Well, how many past questions do you have? I've done, like, the only differential equation that is there is what I've done. We were doing one thing yesterday before we put no. We were doing some differential equation yesterday. I bring it that one. No, that not the one we did in class. The first one we did. That we're stopping and stopping, cancelling and cancelling. Let me deal with that. Let me deal with it now. And I want to sleep like this. Lazy bone. Lazy to the core. I want to clean this part. Okay. Okay. All right. Is it the one I was doing yesterday? Fuck. Sorry. And lower forward. Yeah. Y prime. Wait. Y prime plus xy prime. Plus x squared plus 2. Everything here multiplied by y equals 0. Let's deal with it. Now, first things first, that I would love to say is that, now, solution is that let y equals to infinity n equals to what? 0, cn, xn. That's the first one. Then y prime should give me n equals to 1, infinity, n cn x to the power of n. I'll get 120 like that. Then from here, y double prime equals to infinity, n equals to 2, infinity I have, n minus 1, n minus 1, cn, x n minus 1. Now, let's now start taking one by one. I think I have this, so let's start with this. Yeah, so if I have x or y prime, okay, minus 2, thank you. And so this one here, I can have x multiplying n equals to 1, infinity. I have n cn xn minus what? Minus 1. If these two multiply each other, then I will have infinity n equals to 1, and I have n cn x to the power of n. I can save this answer. Down to the last part here, which is x squared plus 2 multiplied by y, which is the same thing as saying x squared plus, or x squared y plus 2y. From here you can have x squared, from my y here is n equals to 0 to infinity. I have cn xn plus 2, n equals to 0 to infinity, Cn xn. Then from here, and I have infinity n equals to 0. I have Cn xn plus 2 n equals to 0 infinity Cn xn. Okay, then from here so let's now substitute. So y prime is what? This is, I have n equals to 2 infinity n open bracket n minus 1 Cn xn minus 2 plus, now xy prime here, I think we dealt with it to give me this. This is what? Infinity n equals to 1. Then you have n Cn x to the power of what? N. And the last one plus everything here is this, which is what? Infinity, summation n equals to 0 to infinity Cn xn plus 2, then plus 2 summation n equals to 0 to infinity of Cn xn equals to 0. Now from here, the goal is to try to write everything to start from x, 1 power of x. That's the goal. So I think it's very easy for us to do from here. So from this part here, I can say that let m is equals to what? N minus 2, and here n is equals to what? M plus 2, and here when n is equals to 2, and what will happen when n equals to 2, m equals to what? 0. And for this one here, let m equals to what? N, and here n equals to 1 equals to what? M equals to 1. I think that's set on this part. And this part here, let n plus 2 equals to what? M, in such a way that n is written as m minus 2. And when n equals to 0, m is equals to 2. And this n part here, I can say that m is equals to n equals to 0, m equals to 0, no stress. From this part here, I can now work with this. This one can now give me, instead of n equals to 2, m equals to, I have m equals to 0, infinity. Then what do I have here? Instead of n, I have m plus 2, m plus 2 minus 1, cm plus 2, x, everything will give me m plus 2 minus 2, plus, and this part here is infinity m equals to 1. So I have m cm s to the power of m, plus this one here, infinity m equals to c m minus 2 x m minus 2 plus 2 plus 2 infinity n equals to 0 0 cm xm equals to 0. How to get that, please? Eh? Good. Please help me follow, because this another thing about this thing is that the fact that it is long makes it easy for you to what? To make mistakes. Okay, so if I make mistake, just to wait to what? Call my attention back. Then from here, what will I have? I think the best thing for me to have here is what? M equals to 0. Eh? I'm still coming there. I'm still coming there. Infinity, this will give me m plus 2, m plus 1, cm plus 2, xm, plus infinity m equals to 1, infinity, so I have m, cm, xm plus m equals to 2 infinity cm minus 2 xm plus 2 infinity m equals to 0 infinity here cm xm equals to 0. So all of them must start from the same starting point. That means I must move this one twice, move this one once, move this one what? Twice. So if I move this one first time, and I'll have 2 dot 1 dot c2 x naught plus moving this one again, next time will be 1 plus 2 will be what? 3 dot 2 dot c3 x1, then plus everything you now. So see m equals to what? 2 infinity m plus 2 m plus 1 cm plus 2 x to the power of m, then plus this side here I have m, so adjust it by 1. I shifted this down twice to the front, but I can have everything starting at equal. Everything. I have 0, then after 0 I use 1. Now for this side here, this one is starting from 1. So I'm shifting this one further. I can have 1 dot c1 x1 plus this one I've shifted m equals to 2 infinity mcm x m plus next one here will give me m equals to 2 infinity cm minus 2 xm plus 2 open brackets. I have c naught x naught plus c1 x1 plus infinity m equals to 2 cm xm equals to 0. Then from here 2c2 x naught plus 6c3 x plus infinity 2 m plus 2 m plus 1 cm plus 2 x to the power of m plus c1 x plus m equals to 2 infinity mcm xm plus infinity m equals to 2 cm minus 2 xm plus 2c naught x naught plus 2c1 x plus 2 m equals to 2 infinity cm xm equals to 0. Answer again. Answer that I've never started working. Eh? Okay, 3 times 2. River. I must add anything. I'm still wetting the ground. Which one? And now this was the original term at 0, 1 and 2. 0 and 1. Then after 1 to be 2. I still turn back to the same stuff. So let's start. So here, so I can start by saying 2C2 X naught plus 2C1 X. Okay, I think that's all. Then plus infinity summation m equals to 2 infinity. I think it would be best for me if I just open the bracket now, which is m plus 2 m plus 1 cm plus 2 plus mcm plus cm minus 2 plus 2cm close bracket x to the power of m equals to 0. So now C naught and x together, you can have 2C2 x naught plus 2C naught x naught plus 6C3 x plus C1x C1x 3C1 x m equals to 2. not Bill. Yes, just Captain him, no. My him, the one being on. Hmm? This is the method that is required for you to use it. They told you to use this method to solve it. Eh? I haven't seen anything. Ish. I just want to start solving now. Whatever I did before was preamble. Alpha, where are you guys? Yesterday, it paid me yesterday when I couldn't solve this stuff. It paid me. This was one of my best topic then. Although it was long, but you know, the fact that it's long, you keep on working and you enjoy it. That's why this one I'll finish it today. I don't see anything. Everything finished. Let me see. I mean, so I can't, because of the fact that if I put m equals to 1 here, I have m minus 2 here, so I can only start by saying that when m equals to 2, so at m equals to 2, I will have c4 equals to minus 2 c2 minus c naught plus 2 c naught over I put 2. Okay, c2 dot 3. So here itu ya saya mesti kibaya bahasa lagi. So c4 equals to c3 minus c naught minus 2 c naught plus c naught minus c naught. I've forgotten anyway, fine boy. Let me talk about the mama. I'm waiting for you. Yeah. I remember when I was learning this in the first time I saw it. Then it took me, I think, 3 nights. 3 nights like that stretch. I don't get anything. I wish you were going. Remember, I don't even feel and I'm don't shaking. Belum. I know questions in my mouth. Mom, the one. a máa sọ bẹ́ẹ̀ a máa ṣe papọ̀ náà ni. A máa ṣe papọ̀ náà ni. Èmi ò ṣe. Est-ce que you don't come from the side. Some people are writing this part. If as I am safe, it's both of them. I'm not resting, I'm resting. Let's just continue and let's finish. I can advise God. Yeah, okay, I'm going to do. God. So, nǹkan tó kọ̀ kù ni pé I can complete it padà sí. I can recall this one, then if we should C6, C1, C1, C6, and for me, I've gotten to the solution. One thing, if not for the fact that we don't know, basically, that one I did. If I want to do it myself personally, I can't enter. I think I enter C10. C10 is too much. Maximum C, probably C7. What am I back on? Oh god. Oh, no. The bleak. The thing is, I need phone. Probably I can download the PDF that can use to work. It's night. My phone is not with me basically. I would have saved if you use my phone. Spare phone. Spare phone. Spare phone. Spare phone. Spare phone. Phone. You guys I'm waiting for. I had quite be back. Are we done with this bit? Okay. You know what? I'll get some. I'll get materials now. So let me just round up here. Recall that okay, y is equals to n equals to 0 to infinity and cn xn. Y also can also be written as c naught x naught and x1 c2 x2 c3 x3 c4 x4 c5 x5 c6 s6. So from here I have c0 plus c1x plus what is c2? c2 here is minus c0 x squared. What is c3? Minus 1 over 2 c1 x cubed. What is c4? Plus 3 c0 4 dot 3 x4 c5 minus 3 c1 over 40 c5 and x5 then plus minus from here I now have c0 minus c0 x squared plus 3 c0 4 dot 3 x4 minus c0 2 dot 6 dot 5 s power 6 then plus c1 x minus 1 over 2 c1 x cubed minus 3 c1 over 40 x5. That's right from here. I have c0 1 minus x squared plus 3x 4 dot 3 minus s6 dot 6 dot 5 plus plus c1 x minus 1 over 2 x cubed minus x5 x5 over 40 so general solution is equals to y1 of x plus y2 of x and y1 of x X squared. Yeah, that's the solution. Yeah. There are a lot of books you can use for it. Ah, yeah. Huh? I have a lot of books for them. No, I don't know. I'm not with the timetable. So, I'll just advise that we find one more, just do one more, and that's the problem. Eh? It's simple, but it's very long. So we'll do one more, just one more question again. After that question, then we'll now look at Bezier, that's Frobenius method, and Frobenius is even longer than this. Or although I don't know, the thing is I don't know how it will be for your time. In my own time, we didn't bother about it because it didn't even appear. And we can see that as it is for us, so it should be for you. So Samuel differential equations, okay? I have many. That's the problem. I have many tokens. No. Come on, you need jump bed. You have jump bed. Hmm? Hmm? I have jump bed. Give me your jump bed. Just give me jump bed, fine boy. The first. We cannot use the whole of 3 hours to solve. Even if you want to use to solve this type of equation, it's not enough. To be sincere. It's not enough, to be sincere. Okay. Give me the down. So let's look at one more. But this time around, it should be, so let all of us those of us that have the idea, so let's just try it once and for all. Or you can just be using eyes to monitor. One thing that made me learn it then was the fact that I know I will not have choice of questions. I just have to learn it, not as a solution. Plus. Okay, yes. 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 This will be plus, then this one will be minus. My work. Okay, let's look at this one. Have x squared plus x squared plus 1 y prime prime plus x prime minus 4 y equals to 0. So hold. Now, I want to look at this one this time around. So, I'm gonna start. We'll have to finish with that boat first, though, because I want to be, let's be fast. Because this one, say, alone, say, everyone did very well. 30 minutes, we're not done. I'm not as if I'm lying. I've been now. 30 minutes, we're not done. Now, I want to work with this. Now, so first thing first is that let your y equals to summation. What is this? N equals to what? 0 to infinity. Then you have Cn s to the power of n. Then y prime here should give you summation n equals 1 infinity n Cn x n minus 1. Then the y double prime here should give you infinity n equals to 2 infinity, so you have n minus 1, and this is Cn x n minus 2. Okay, so from here let's start working with all of this one by one. So we have x squared plus 1 x squared plus 1, so y double prime. So this one is still the same thing as y double prime x squared plus y double prime what is y double prime here? That's x squared multiplying n equals to 2 to infinity n minus 1 cn x n minus 2, then okay, n minus 3, okay, plus n equals to 2 infinity n minus 1 cn x n minus 2. And from here you now have n equals to 2 infinity n minus 1 cn x n plus infinity n equals to 2. You have n minus 1 cn x minus 4y n equals to 0 infinity. Oh, this is going to give me cn x to the power of n. Okay, I hope I don't this part. I hope I don't this part. Okay. Alpha, how would I say? Hmm? Let's be quick, I don't depend. Okay, yeah, done. Okay. Okay. Plus 2. Then okay, let's say so let me carry this one to the other side. 4cm minus mcm, taking this one minus minus 1cm. I think that's all. From here, cm plus 2 can I give me? Okay, 4cm minus mcm minus m squared minus mcm and divided by m plus 2 m plus 1, and then here this one should give me, here should not give me cm plus 2, which is 4cm, and this one here is minus 2 mcm minus m squared as m plus 2 m plus 1. And then from here I start when n equals to, oh, my hand starts from, my hand can start from, okay, I don't have any problems here. My m can start from when m equals to 0. When m equals to 0, I'll have C2, which gives me, okay, C2 1, 2 is okay. I hope you finish that one, please. Yeah. The best for me to do when m equals to 2. If m equals to C4, okay, C4 will be better. So C4 will give me 4C2 minus 2 as 2 C2 minus 2 squared divided by 4 plus 3, then C4 equals to 4C2 minus 4C2 minus 4 over 12. Shall not make mistake like this. I'm going to see where I made mistake in here. It's going to give me 4c3 plus 2 multiplied by 3c3 minus 3 squared c3. Okay? Then so from here I have 5 multiplied by 4, so I have c5 equals to, it's going to give me 4c3 minus 6c3 minus 9c3 divided by what? 5.4. Then c5 equals to, it's going to give me minus 2 minus 9 minus 11c3 by what? 5 dot what? Dot 4. What c3 is half c1, so I have c5 equals to minus c11 minus 1 over 2 c1 over what? 5.4. Like I have c5 equals to minus 11 c1 over 2.5.4. I've done 5. Let me round up. So that the chord at y equals to n equals to 0, and cn xn xn. So we can answer that y equals to c1 x1 c0 x0 c1 x1 c2 x2 c3 x3 c4 x4 c5 x5, and here y equals to c0 plus c1 plus 2 c0 x squared minus 1 over 2 c1 c1 then c1 here, I think I'll x cubed plus y c4 still right there, c0 plus minus 11 c1 plus 4. So I'm going to go to the cover. Okay. So what part should we now look into in 4.1? What part should we look into in 4.1? I mean, in 309. Let's come by now. Okay, I should go. Baca tentang apa biasa? Obina is more numerical now. Well, that seems fair. That seems fair. How to use the phone? How to use Bezel? Of what we said Bezel, we could do for Binion so. Mathematics, we know for Binion before Bezel. Yeah. Let's just round up here. And now, that's one line of question. Yeah, please quickly, that jump bed. Let's use it. My phone is dead, I'll have used my phone. We are done, we'll just look at, trying to look at it. Probably when next we meet again, we'll now enter gamma beta function. Enter gamma beta very well. I said I should finish writing. Look at one problem. We just plan power series today throughout. Plan power series today. I missed my power series. So probably next time we meet. When next will we meet for 319? Power series, yes. Est-ce que là, on va te attendre, d'accord. Should we collect most of my textbooks? You collect my differential equations. Let me put it to my differential equations first. I know, she pushing color one here. What the cut on the map here. I still writing now. All of my engineering maths. Put it on that folder of my book that I collected. Or do you have to ask? Just put it on your engineering mathematics, let me see. What's baby? I do fast. As once they finish, I want to start with something. Let me just start with opinion straight up. With after passes, put it. Do you have advanced case route? Let's just do gamma beta straight up. Let me see. I need engineering textbook. Okay. Where? This is the same way call me by. It's supposed to be same. Yeah, that's cool. And now this I have MCM multiplying these brackets. M times this one should give me M squared. Then this M squared one this should give me Yes, let's make an engineering maths. Yeah, do fast. 1, 2, 1 more. Yeah. Okay, Mathhathon. So that is it. We can snap your phone. Oh no, I'll use my phone. It's not there. No, I'm looking for it's not there. I'm not looking for power series. I need gamma and beta function. If it's there, just bring it and show me. If it's there, show me quickly. So let's start gamma beta function. Let's start with gamma. So from gamma function, we have gamma function to be given as this gamma x, which is the same thing as infinity bounded to 0 of t x minus 1, which are minus t dt. And one thing I wanted to know is that in this gamma function, what is that gamma function? Basically, it's not because of the fact that, so for example, I can have another I can have gamma function to be defined in another way, except from this my stuff there. Yeah. So that's one thing I'm supposed to know. For example, I can still have the same gamma function written in this form. Gamma n now can be infinity 0 x to the power of n minus 1 exponential minus x dx. So it can still be any form. So I don't want us to be streamlined to one kind of form. Yes, it can be written as any form. But this is the basic thing that makes it different. That's the only basic thing that makes it different. So now let's start taking some important stuff. Now let's now find gamma x plus 1. So to find gamma x plus 1, and that means that anywhere I see x, I substitute what? I substitute x plus 1 there. Abi now? This one self does not have much of gamma function. So it doesn't have much of gamma function. It's textbook. Well, let's work with this one. So what would this one be? This one would be what? You have infinity 0 t to the power of what? X plus 1 minus 1 exponential minus t dt. Then from here, I can have infinity and 0 t to the power of x exponential minus t dt. So from here, I can now apply integration by parts. So I can say that v is equals to, u here is equals to what? T raised to the power x, and my v here, dv is equals to exponential minus t dt. Are we together? So let's look at that. So for me, I can say that my du is equals to x dt, xt minus 1 dt. Are we together? And my v is equals to minus exponential minus t dt. Then so from here, so what will I have from this part here? So I can answer that. Don't forget that integral u dv equals to uv minus integral what? V du. Yes or no? Abi? Please let's be together. So I want to try to show some relationship, a major relationship. So from here, so let's now have, so what is my u here? My u is what? T raised to the power x multiplied by, what is my v here? That is going to give me multiplied by minus exponential minus t. Are we together? Are we now? Then minus, don't forget that this one is bounded by what? infinity and 0 minus here infinity and 0 so what's my VDU? Minus expression minus t multiplied by, trying to see something here. Okay, so yeah, from here, so what do I have here? Minus exponent minus t. So what's my du here? My du is what? X t x minus 1. Are we together? Dt. So in this kind of case, I hope you know that all of this one here will leave. So I can have minus x integral of what? I mean, will it be minus x? Let's go together, please. So from here, if I will put infinity and 0 inside anywhere I see t in this case, everything there will leave. I be now. So now in this case, I can now bring m. If I put infinity and 0 here in place of t, everything there will leave. Yes or no now? Everything will leave. Everything at all will leave. I'll now be left. So let me now remove everything here. So I want to bring this minus x outside. I can now have gamma x plus 1 equals to minus infinity, sorry, minus x infinity and 0. What is one be? T is power x minus 1 exponential minus t dt. Are we together? Then from here, you can now have gamma x plus 1 equals to what? X infinity to 0 t x minus 1 exponential minus t dt. And the first thing that I can have here is that I have gamma x plus 1 equals to what? X, and everything here is the same thing as your gamma x. So I have that as x gamma x. Are we together? So this is one formula that we use in gamma. This is one formula that we use in gamma. Now, okay, let me explain from the beginning. Now, what I mean is that this is gamma function. I get this gamma function. This is written, and I was like explaining earlier that this is the only way it can be written. I guess I'm trying to like that. Now, this one I can have it in terms of probably in terms of x or in terms of any other letter that I want. But let's just master it. That gamma is just written from infinity to 0. This I have gamma equals to this. Then from here, I now want to find the value of what? Gamma x plus 1. And how do I find the value of gamma x plus 1? I find it by simply substituting x plus 1 inside here. And when I see x, then I think I can follow suit. So by substituting, I have this one here. I get in it. Then from this one here, I did integration by part. So I made this one my u, made this one my what? The v. And I integrated and differentiated, and I came back here. Please, one thing I wanted to know is that don't forget that here I was bounded by what? Infinity and what? 0. By the time I will have my u2, this answer here must be bounded by what? Infinity and 0. Should you get an approach like that? Minus here. Minus here. I don't know. I've not tried it before. We can try it now. So we'll see what will happen. So I will together. So from this side. Now don't forget that it's bounded. And what did I integrate? I was integrating with respect to what? To t. That means this my infinity and my 0 will affect everything that is t inside here. And at the end of the day, t here will leave. Happy now? Yeah. So now, so I'm now left with this side here. So now minus this minus x is I can more or less like a constant, sure? So I can just carry this minus x outside here. Minus times minus to give me what? This x. I get in this. Then I will now have this thing left. But don't forget that whatever I have here was the same thing I was coming from here. Happy now? That means I can now have a relation that says that gamma x plus 1 equals to what? X gamma x. You get? There are other relations that we can have. Other relations. So are we done writing? Okay. Or if you are with your notes, you can bring it. Let's use your notes to explain. Not on this course. It's not complete. Let's speak about a part of it. I don't know. Is anyone with this? Is anyone with this notes in class? Now, let me see. If you can help me check it, yeah. Let's try to see another thing again. Are you in it? Check if it's there. Quickly answer me. Quickly check if it's there. Is there no one with that note in class here, please? Is there? Help me bring it, please. 61. Wasted time more. We are wasting time more. We are wasting time, sir. This one. This one. Okay. So we've defined another one here. There's another one again I want to check again. This is another important relationship that we can check. Another relationship that we can check, which would be Questions. Right. 20. When? Okay. Okay. All right. All right. Okay. All right. Okay. Right. When are we starting? Okay, let's start. Let's start. All right. Okay, let's start. Okay. So the last time we met on, so part of my voice, it should be normal back. Right. So the last time we met on MTS 301, we talked about vectors and all the scalar product stuff. All right. Okay. So let's talk about vector differentiation. All right. Yeah. Is it time to start? Time to start. Okay. So vector differentiation. So okay, let's look at some examples. Okay. Okay, so we're good to go, right? Okay. So vector differentiation. So unlike our normal calculus on everything we see in our everyday life, so it's also the same thing to our vector application. So let's look at some examples. Let's say that okay. Okay, so you have a, which is equals to 2 exponential derivative I minus 4 exponential 2t sine dt. Everything here should be k. And let's say that. Okay. Alright, so that's like our normal. That's like our normal vector differentiation. Okay. I don't know, do we have any materials on vector differentiation? Are we? Anyone? So I don't want to pick questions to mind. I don't think this textbook I'm using has. Alright, so do you have anyone? Okay. Okay, so let's get this question together. Okay. No. I don't see this one. Do you have any other one? Okay. I think. Do you have any other one apart from this? Let me see. I don't see this one. Okay. Let me see. Let me see. No. I need more of like. Okay. Okay. Alright. So let's start with this. So. Okay. Okay, so let's start. Okay. So. Okay. Cos t k. So number one access to. Okay. Okay. All right. Okay, let's take this as transition here. All right, so let's get these questions together. I wish some questions would be here so that I can solve. Well, as if we don't have. Okay. So now let's get this together. So now it said that suppose we have r of t, which gives us something like this, and I have my u of t. Then the question asks me now to compute r of t dot r prime of t. Now let's start. So so all things being equal, first we start from what? Now let's look at our r of t. So r of t here should give me what? Cos ti sine tj and minus exponential 2t k. Alright, so let's differentiate. So by differentiating here, so this one will give me minus sine ti, then plus cos t So I've gotten this. Then the next thing I have to do is what? Next I have to do is what? Compute the dot product of my RT and the derivative together. So I can say that RT multiplying R prime of t here would give us what's RT here, which is cos ti plus sin tj. All together, then minus exponential 2t. Alright, so multiplying. What is this one here? What do I have? I have minus sin t I plus cos t j, so minus 2 exponential 2t k. So according to the way we know in our dot product, so let's start. So in our dot product, what do we have? I have I multiplied by I plus j multiplied by j and what? K. I think there should be a k here. K multiplied by what? By k. So let's start. So for me, what will I have? I will have, then I have cos t multiplying minus sin t, right? Then plus, now the j is now sin t multiply what? Cos t. And the last one here is exponential 2t multiplying 2 exponential 2t. How together? Okay. So everything here should not give us, what do I have? Minus cos t sin t plus sin t cos t, then plus, I think, yes, okay, plus 2 exponential 4t. So it's observed that these are equal to each other, yes or no? So from here, so I can say that everything here will leave, then I'm left with what? Exponential 4t. But that's just the dot product. The question asks us to find what? ddt of what? Of the dot product. So let me move here. So we have ddt. So I hope everything here has been sorted out to give us 2 exponential 4t. Yes or no? So we have 2 exponential 4t. So from here, by differentiating this, what do I have? I have 8 exponential what? 4t. Yeah. So I think that will be the answer for that. Alright. And now for number 2, we have ddt of u of t cross r of t. Now first thing first is what? So let's look for the what? The cross product between what? U of t and what? And r of t. Yes? Are we together? Okay, good. So from here, so we have I, j, and k. Okay. So u of t first. So what do we have in u of t? So we have t of course t. Okay. Yeah, 2t. So from here, what do we have next? So let's break it down. So from here I have I, then everything here leaves, then what am I left with? Minus exponential 2t sin t. Are we together? Okay. So please mind my voice. Okay, so minus, so we have minus sin t cos t. Are we together? Okay, so from here, next one is what? Minus j. Then this one leaves, then I have t, okay, or better still, minus t exponential 2t minus, then this one here will give us cos squared t, then plus k. So from k here, what do I have? I have t sin t multiplying both sin t cos t. Okay, yes, minus, yeah, okay, minus. So from here I can have I open bracket. What would this one give me? So I have, okay, I think it's explicit enough, isn't it? I bet now. Okay, let's just write it very well. So I can have minus exponential 2t sine t minus sine t cos t, right? Are we together? Then, so if I factor out minus from this space, what do I have? Then plus j, t exponential 2t plus what? Cos 2t, cos square t. Then the next one here is what? Plus k, open bracket, t sine what? Sine t minus sine t cos t. Okay, so from here, what will be the next thing we're checking? The question asks us to find what? The ddt of all of these ones. So I can say that ddt in this case here of u of t r of t here. So let's start picking it piece by piece. One thing I want us to know is that most of them are, from the look of it, most of them are doubles, because this one here is having two function of t, two function of t, two function of t. This one is having squared here, two function of t, another function of t. So from here, so what do we do? Let's apply a product 2 straight up. Then since I'm still dealing with high here, then I can have this one, everything here to be u, everything here to be v. Then I can have minus exponential 2t. So if I differentiate sine t, what do I have? Cos t, right? Then plus sine t. If I differentiate this one, what do I have? Minus 2 exponential 2t. Are we together? Okay. Then next one is what? Minus sine t. Minus sine t, right? Then plus next one. No, I think we have a minus here, so let me put this one inside bracket. Then plus I have cos t. If I differentiate this one here, what do I have? I think I will have cos t too. Yes or no? I just saw it now. Okay, good. So from here, I think I'm done with differentiating this part. Abi now. So let's look at it again together. So this my high is what is here. I applied product 2 to what I have here, which is exponential 2t. Writing it out. Then here should give us cos t, then sine t here. Differentiating this, what do I have? Then this minus that is here, sine t. Now this cos t here is minus sine t here. Are we together? And also here I have plus cos t, and if I differentiate sine t, I have this one. Let's move on to the second part. Okay, so from here, I think we'll notice that here I have plus, so j in this point. Then what would j be? This is t exponential 2t, and this is what? Cos squared t. So what do I do here? I use product 2 here, u and v, and I use chain rule here. Happy now? For me, I have t open bracket exponential t. Sorry. If I differentiate this, I have what? 2 exponential 2t. Are we together? Then multiplying. What do I have there? Okay, t exponential 2t multiplying plus exponential 2t. If I have this, what do I have? I will have what? 1. Are we together, please? Okay. Then, sorry. Let's continue from this part here. Alright, yeah. Wait, do you want to start from this part here, please? Okay, let's get it from here. So which is, okay, I'm done with this side. So the next one I'm dealing with is what? I'm dealing with j on this side. So dealing with j on this side, so this is what I will have. Are we together? So I have t here. If I differentiate this one here, this is what I would have, plus, what do I have here? Exponential 2t. If I differentiate t, what do I have here? I would have 1. Okay. Then the next one that I have here is what? Plus. Now, this cos square t, if I would differentiate cos square t, I don't want to show the workings. I hope we can do that. I would give us minus 2 cos t sine t. Yes or no? Okay, good. then close the bracket, plus k, then this one here. So what do I have here? I have t. If I differentiate sine t, what do I have? Cos t, plus next one here, sine t. If I differentiate t, I have what? 1. Then minus this time around, if I have sine t, what do I have here? Sorry, this one should give me what? Minus sine t. Are we together, please? Then plus plus cos t. Then if I integrate this one, what do I have here? Cos t also. Yes or no? So I think I've done everything like that. So are we done with the first? Are we done with the first part? Okay. 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 Let me clean it like this. Now I'll clean the question. So okay. So let's start taking this one by one. Let's start taking it one by one. So what do I have there? I have the solution here will not be I. Are we together? Now let's open the big brackets. So from here, I think everything there will be negative. Are we together? So I have, or let me just bring the negative outside. So I have negative I, right? So I have negative I. Then everything inside will not be what? Exponential 2t cos what? Cos t. Then plus 2 exponential 2t sine t. Are we together? Okay, then the next one, which is what? I think we factorized out minus here. If we factorized out minus here, this minus here should be affected. Abi now? Okay. Or better still. So I'll say minus sine squared t. Yes, either way. Minus sine squared t. And at the end of the day, plus cos squared t. Plus cos squared t. Are we together? Okay. Then I think I'm done with this first part here. Move on to the second part, which is what? Plus j. What do I have here? Can I have what? 2t exponential what? Exponential 2t. Abi? That's what I'm looking at, because if we already factorize the minus here will leave, minus here will leave, then either of this minus here will leave, then this one here becomes what? Negative. Abi now? Wait, let's look at it together. If I remove minus from this side, minus here will leave, minus here will leave, one of this minus here will leave, so then this one here will give us the second one here, which is this. Then I think I'm still removing minus from here. Okay, yes. Yeah, okay, yeah. Then so from here, plus the next one is what? Exponential 2t. Are we together? Then the other one here, minus 2 cos t sine t. Okay. So from here, alright. This thing will look a little bit longer than I expected. Then plus k. I think my writing is too big. So from here, k here. Let's open this bracket here. So what this one give me? T cos t plus sine t, abi? So t cos t plus sine t, abi? Then it should be plus sine squared t minus cos squared t. All together. So from here, okay, let's factorize here. I hope you know that I hope you know that this, so minus I from here, exponential 2t cos what? Cos t plus what? 2 exponential 2t sine t. I hope you know that I want to do something here. I hope you know that this one here is no. Which one to give us 1? Because I want to write it this way: cos squared t minus sine squared t. According to trig ratio, this is giving us cos 2t. Abi now? Trig ratio. So let me have that here. So I can have everything here to be plus what? Cos 2t. Are we together? Then plus what is here? Plus j. Then so from here, do you have anything common here? No. Everything is what? 2t exponential 2t plus what? Exponential 2t minus what? 2 cos t sine t. Are we together, please? So from here also, then plus what? Plus k. And this one here, now nothing else is happening here, which is what? T cos t plus sine t. Then plus sine squared t minus what? Cos squared t. Abi now? No. Cos 2t is only positive. I think it's only possible when you have cos squared t minus what? Minus sine squared t. Oh, okay. Oh, yes. Minus cos 2t. Yeah, thank you. Minus cos 2t. Okay, is there anything else we can do to this one again? Is there anything? I don't think there is. Yes, there is. Because, I don't know. Abi? But I meant me to understand. I think this is what we look like. This is what it should look like. Abi now. So probably we have anyone that has Shalms. Shalms will have vector and tension analysis. We have Shalms, okay. Vector and tension analysis, Shalms, precisely. So from here, I don't think we have any other problems from here again. Don't have any problem from me again. No. Even if they will have, it should just be the basic part they will teach. That's why this one does not have. I don't know why. I was thinking it will have. But it doesn't. It did not. I'm waiting for us to finish it though. Okay, I'm coming. I'll come get it for you. It should be here now. Are we done writing, please? If I don't writing, please let me know so that I can clean. Yeah, let me see it. Okay. Okay. Okay, yeah, okay, it's fine, 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 yeah, okay, it's fine. T sign T. What do I have? That will be t cos t plus sin t. Then plus the next one is what? K open bracket cos t plus sin t. Have you know? No? Okay. Wait. Cos t minus, don't should be minus t minus sin t. Have you know? This is sin t to give me cos t, minus here. T here, cos t will give me this. Plus what do I have here? It has to give me cos t 1. Have you know? So from here, minus Joshua. So from here, this one here, and this one here will cancel out. Abi? I think I have c cos t. So from here, I think, is there anything that will cancel out here? No. Should be 2 cos t, k open bracket, 2 cos t minus, no, it's not minus now, plus t sin t. You get this? Let's write. Wait, who gave you this question and when did they give you? Test. The man is nice, so. Obalaragba Idabi. I mean, what's his name, sir? Look, a woman. Describe her. 2-6. Oh, you get body lies. No. I don't know. I don't think so. I don't think so. Oh. How to get that like this? I just have you. So, okay. How to get that, please? Do you understand this part? Now, there's this part that I literally wanted us to look at, which is the div, curl, and divergence. Those parts. I think in my last test it came out. That third question. If you have the past question, bring it. Let's look at it. Conservative test. Conservative field. That man, I don't know who teaches this now. Okay, grammar. Let's see. I don't know if you have it. Now that div, the only thing I can. Jesus Christ. How do I feel sieve? Okay. Let's start from let's look at number 2. This is on my spirit. I don't know. This is on my spirit. So number 1. So it said that f equals to 2xy plus z cube. How to that? I. Then plus what do I have here? X squared plus what? 2y j, right? Plus 3x z squared minus 2, everything will be what? K. That's just to show that it's a what? Conservative force. Take this one. This is the same thing. I want to show that this one is a conservative force. I want to prove that this is a conservative force. I mean, is it force or field? Field. Yeah, there is. There's a proof to it. So now the thing is that I don't know, except for mathematicians that have done it in 208 and in physics. Abi, department only. Okay, so this is what will happen. Have you heard of curl and div of before? Sorry, I've not heard of it before. There's curl, like it's not curl, like curl. Okay, didn't learn in last class. Now this curl here, because the first thing I wanted to know is that whenever this man that was asking us for conservative fields in this question, the only thing that can make a field conservative is if its curl is what? Is 0. If it should be solenoidal, the solenoidal it will be, I mean, if it is be solenoidal, then solenoidal will be what? The div. Abi now? Div will be 0 to give you a solenoidal field. And if it's a conservative, it should be what? The curl. Okay, now the thing is, there's something we call, okay, probably, let me see if I can piece everything together and see if we can work it. There's something we call grad. Are we together? There's something we call, yes, grad or gradient, yes. Gradient. I guess so. Well, before this gradient, let me remember. There's a name of that operator. Ah, Jesus Christ. Del operator. Maybe it's del operator. Yes, del operator. Aha. So for del operator, you have something that looks like partial xi plus partial y g plus zk. Okay. So this will be a dual operator. And for you to have grad or gradient of a gradient of a field. So gradient of a field here will not give you, I think, it's not grad multiplied by the field. Just grad like this. Happy now? Good. Where this one will be a vector field itself. I still remember small. Happy now? Okay, good. Okay. All right. And also, when you have divergence, for divergence of a field. So what would divergence of a field be? And for divergence of a field, instead for you to have this, you'll be having this. Abi now? This will be divergence of a field. This is divergence of a field. Go and check. Is that this is the divergence of a curve. Abi? Is that not it? Is dot, and now there's dots now. And now this, I know that for gradient, there's nothing between gradient. I know that for div, there's at least, because the div of a vector field will give you what? Will give you a scalar. And if I don't know this, I still remember now. And also this curl now will give you what? This multiplied by what? By a vector field. Abi now? Aha. I still remember how small now. That's the note. Okay. That's where it stopped. Okay, don't worry. Probably when next we meet, we'll talk about it. The abundance of a vector, because that question is always a common piece in his past question, especially that man that sets it. He will set it in his exam, he will set it in his test. It's always a common piece. Although it's very simple for some people to pass through. Very, very simple. But that's not even where I'm going, sir. The way I'm going is that I want to show that this one, I want to show that this one here is what is a conservative field. And as we've said earlier on, that we can only have a conservative field if and only if the curl is equal to what? Is equal to what? 0. Let's now show the curl. Now, what would be the curl? Don't forget that the curl is defined as what? Your grad. The del operator multiplied by your what? Your vector field. The cross product. From here, I can now say that del here is equals to, I think, partial xi plus partial yg plus partial zk. No, if you know it, it's very, very interesting. Let's be playing with it. So from here, after this part now, the next thing is now everything here, now cross product. I remember that day came to so this is what we have. Then cross product of what? 2xy plus what? Z cube I will say that plus x squared plus 2yg plus what do I have here? 3xz squared minus 2. Are we together? So from here, let's now draw our normal stuff. So grad multiplied by the gradient. So from here, I, J, and K. So this one be partial x, partial y, partial z. And from here, so what everything here be? What is everything here? Why let me know you right? I shall not do this one at the Then you have x squared plus what? 2y out together. Then from here, what do I have here? 3xz squared minus what? Minus 2. Now in this time around, how do we do with this? Now so from here, we deal with it with look as if the way we are writing it is not balanced. Sorry. Let's take the dimension like that this night. So now let's go. So the first thing I have here is what? Is I. Then if I have I, let me teach you the way I did it so that I used to get math. What got the for me course and look I'm learning. So from here. One here. Now partial y. Put together. Then everything here, because it should be this side, everything here multiplied by this, which is what? 3xz squared minus 2 out together minus partial z. I think the question 2 is what? X squared plus what? 2y. We'll see connection going to learn into or not. But everybody there is there as far as that differentiation is concerned here. Everybody is a what? Is a constant. Have you know? Now the second one, which is what? Minus j. If I now minus j here, what do we have? So minus j here, that will give me okay, j partial x. What do I have here? 3xz squared. Okay, 3xz squared minus 2. Partial z. plus z cube. Abi? And last one here is plus k. How will k look like now? K will be like, so k will be partial x plus 2y altogether. Partial y 2xy plus what? Z cube. Obviously, everything here to me is what? Is 0. Oh, do we believe everything to give me 0? How sure? Fine boy, 0. 0. You know why? Let's differentiate. I'm down J, I'm down integration ratio to x here. This only x I have what? This z square now. I mean now minus this is z, which is giving what? This z square. How about plus k half 2x minus 2x2. Everything is what? Everything equals to what? 0. Because everything is equal to 0, then you can say that this this vector here is a what? A conservative field. I guess it. Conservative field. That's why it's a conservative field. Okay, that question again. Are you with it? Okay, I think I'm with it. Let's look at another question. File x minus y is that equals to what? 2x cubed y squared z4. My question says find the div of grad they want to calculate now the div of grad. Yes, that I'm going div as a grad now. Div and grad. I will know it's the dimension of a gradient. Look at div and grad. Now let's start with the grad first. Let's start with the grad. Grad file. I said that grad file is the same thing as what? Your del minus multiplied by what? Your file. I mean now. So what is your del? Your del is what? I partial x altogether. What I have, and everything I'm multiplying it with is what? 2x cubed y squared z4. I can do what to form. That means that one will multiply everything I have here. I've been on. I'll give you minus. Question is minus. This one and x multiply, which will give you what? I'll give you 6x squared y squared z4 I mean now. Then plus 4x cubed y z4. Then say j and plus 8x cubed y squared z cubed. This was k. This is a grad. From that grad now to become a div. To become a div. Now how do you deal with div? div yeah. So let's look at the div. And don't forget that div is giving us divergence is giving us um del dot file. But sometimes the file can be a what? The file can be a vector. So what do I now have here? So yeah. To have differentiate right vector I have what? 12x y squared z is power 4. I will see that. Then plus differentiate this one with respect to what? To y. I have 4x cubed z is power 4. Then plus 24 s cubed I squared z squared. Yes, yes. That's the only benefit that div have, that grad does not have. As long as it is grad. Yeah, grad will always still have your what? A component. I guess I'm continuing. But div does not need a component to exist. Another one now. So still the same type. Yeah, div E. Okay, key. So from here, I hope you know what to do from here now, straight up. That means it'll be I multiplied by I. So I don't need to stretch myself. Let's versus x here. Happy now? So that's the answer you'll give what? 2xz minus 9 z squared y squared and plus x y squared. And after I've gotten the grades, and I give us that I should find it at this point. This is x, y, z. This is two pairs. 1, 2, 9, 2 squared. That was 19 squared. 9. Abi? Huh? Abi now? 4 minus 9 times 4 is what? 36. Abi now? 9 times 4 is 36. This 1 plus 1 is 5. And 5 minus 36 is what? Minus 31. Because my banda is not really. Eh? You did it in last class. What is it? Is it correct? Your memory is failing you. So, I don't know how, but I really feel very, very easy, like a huge feeling in my heart that we should just, I don't know, we should just trash this vector stuff this night. Material, can't give out from my head. If you give material, I'll teach. It's a problem. I just find one here. I don't know why it's not here. 31. Okay, so just 3 1. Okay, let's get new board. Alright. If might not necessarily be from. At least you can differentiate now. But by the time you want to differentiate now. Let's start with it. I think we have defined what a gradient looks like now. Okay. Should we have done gradients now? And you can take down this question. If file of x, or if file is equals to xy squared let's start. %. I think first thing we have to define is we've defined del. We defined del earlier on now. Hmm? Define del earlier on. So define graph to define call. I mean now. Let's look at some exercises. Okay, if file is equals to xy squared z cube. Do we get that? Okay. I think I've defined what the grad will look like. You know. I defined what a grad will look like. Yes. 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 Let's try it first. Let's try it first. I've helped you already now. Hmm? Mm-hmm. I'm waiting now. I'm waiting now. So let's try that question. Yeah. Yeah, no. I know. I know, sir. Okay. So from here. Where's my file here? This is my file. Partial x squared z cube over partial x I plus partial x y squared z cube over partial. Okay. A lot of questions said that you can even practice with it. Why are you not using the PDF? A lot of questions you can practice with. A lot of questions you can practice with. Okay, this is another one. Find Delphi and find Delphi. Find Delphi and magnitude of Delphi. Magnitude of Delphi. Find Delphi and magnitude of Delphi. If phi is given us I'm trying to see what it is here. 2x y raised to the power 4. Yeah, 2x y raised to the power 4 minus x squared y at the point 2 comma minus 2 comma minus 1. Yeah. Yeah, they actually find Delphi, I know. I'm actually of Delphi. Okay. Let me see. Yeah, now. Yeah. I give you file. I give you file now. I give you file. I said file was 2x z4 minus x squared y, and I asked you to find Delphi. Yes or no? Now Delphi in this case, for Delphi here, that is going to give you what? Partial x I plus partial j k plus partial k z k, and everything multiplying. I mean now. And if we do it normally, then you multiply everything here by this, which will be partial x, open bracket 2x z4 minus x squared y I plus partial g, open bracket 2x z4 minus x squared y, okay, plus partial z equals to 2x z4 minus x squared y. So from here, 2z4 minus 2xy. Yeah, I think I'll continue from here now. And you can have empty small. Continue from there. I've helped you now. Okay, thank you. So be high. This with y. So plus. You have something that looks like this. She has something that looks like this now. Abi? Okay, Abi now. Magnitude. You want to find magnitude? Z. Yeah, this one here is Z now. This one here. Where? This one here. This one here. This one is gotten from this one. Abi now. Look at it. Squared, yeah. Yeah, sure. I've helped you now. Okay. So if you put your point inside. X is this, y is minus 2. Everything here is high because this is minus 2 squared. Always go plus. Here you have 2 minus 2 minus 1. Yeah. What's the answer? I don't know. Yeah, I think if you put all of this together, you should get something like that. Huh? Mm-hmm. Another one you want to look at. Okay. Away. Square root of 100. Let's have to this one inside here. So I think I'll have 2 minus, what is this? 4 multiplied by minus 2. Huh? Let's get this question again. Yeah, so what do you say will happen here? Let's do it together. So from here, what is my z? This is x, y, and z. This, I think that's what I did here. Have you now? Okay, good. So if I open this is 2. Have you now? 2 minus what? 2 minus 8. No, it was 8, which is what? 10, Abby? Then I m plus 4j. Have you now? 36. How come 36? The same times 2, not 32. Why can't you compute the 2 minus 2 minus 1? I think if you square this one, the answer you get, will give you. Abi now. Okay, another one. Another one. If A equals to, if A, another question, if A equals to, if A equals to 2x squared I minus 3yxj, 2x squared I minus squared I minus 3yxj plus xz plus xzk. Yes, xzk. What's it? How did I get 1 and 2 here? As I was saying, if A equals to 2x squared I minus 3yxj plus xz squared k, x, yes, x for xylophone, xz squared k, are we there? And phi is equals to, and phi is equals to 2z minus x cubed y, 2z minus x cubed y, yes, and find A del phi, find A del phi. Yeah, at point 1 minus 1, 1. Yes, capital letter A, they'll find, yes. Now, actually find the product of A and delphi. At point 1 comma minus 1 comma 1. A dot, yeah. Yep, A dot. A dot delphi. Minus what? So I don't know if you're wrong. This is what I used to find though. Huh? Yes. This This one I need to find. Okay. So let's see what I got it. So from here, okay. So first thing you have to look forward is del phi. You know. Now from del phi, now do you do with del phi? You have your partial xi plus partial yg plus partial z key. Yes or no? Then everything multiplied by your what? Your phi, which is what? 2z minus s cube y. Have you now? So from here, del phi. So from here, if you bring this one inside and start differentiating respect to x, all together. Yes, let's start doing this with respect to x. What do I have? I have minus 3x squared y I all together. Then plus, what do I have here? Let's say with respect to j, minus x cube I with j all together. Then plus, what do I have here? 2, what is this? 2, okay, 2k. So from here, so we need to find a del phi. So from a del phi, let's go on. From a del phi, I'm coming, please. Alright, so from here, so a del phi. Now, what is the area? I think now let's now start taking this one and this answer in congruence with respect to each other. What do I have? I have this one here and this one here. I have negative 6x to the power 4, right? The next one here, j and g. Okay, yes, there's y here. And this one now, this one and this one here. What do I have here? Plus what? Plus 3x to the power 4y and plus what? 2xz squared. Have you now? Okay. This should be what I gave you a point. What is the point? At x equals to 1 comma minus 1 comma 1. I was together. From I have minus 6 of brackets 1 4, then 1 plus 3 1 1 plus 2. Okay, y is here minus 1 no minus 1. Then this is giving me 1 all together. And from here, what do I have here? 6 minus 3 minus 6 no minus 3 plus what? Plus 2. I think that's going to give you 5. Abi? 5. Right? So, let's... Okay, next one. Now, what if this one here was not dot, and what if it were a cross? Now, let's look for file del phi. And what if it were a cross? Yeah, if A cross B, and this time around, now let's look at it. Looking at this scenario, if it were a cross, if it were a cross. Now I think I've gotten my A. Where is it? I've gotten my, okay, I was given A, which is this, and I've gotten del phi. Where's my del phi? This is my del phi. So let's look for the cross product of it. I can say that I have high J and K. Then from here, where's my high? Where's my, okay, I'm talking with A first. I have 2x squared minus 3yx, then x z squared. Then where's del phi? Minus 3x squared y minus x cubed, right, plus 2. Then from here, what do I now have? I think I can take, I have I now, everything leaves here, then I have what? Minus 6yx. Are we together? Are we together? Then, what do I have here again? I mean, minus, I put it inside bracket, minus, no, this times this, minus this times this now, as plus what? x4z squared. Are we together? Then next one minus j. Then from here, so for minus j, what do I have to do? This one, I have this one and this, which is what? 4x squared. Then this one here, I have to give me what? Plus 3x cubed z squared y. I be now. So from here, what do I have next? Plus what? Plus k. So from this k now, so what do I have there? Minus 2x to the power of 5. Then what do I have here? Minus s minus 9x cubed y squared. Then so from here, if you open the bracket, bring this one out, what do I have? x4z squared minus 6yx. I will take it out. Then I minus j, open bracket here, 4x squared plus 3x cubed z squared y. I think if I remove minus k here, then I'll have what? 2x5 plus what? 9x cubed y squared. And I think from here we now have a point, don't we? I mean now, so we have a point. So here I have 1 minus 1 and 1, 1 to the power of 4, 1 squared minus 6 minus 1. This is 1, right? I mean now. Then I minus j, out it down. I mean now. Then 4, 1 squared plus 3, 1 cubed. Then I have what? 1 minus 1. Abi minus k, open bracket, 2. What's x here? That's 1 is power what? 5 plus what? 9 to the power of what? 1 is power 3. That's minus 1 all squared. So if I open up this bracket here, what do I have here? I'll have 1 plus 6, which is giving me what? 7i. Are we together? And this is going to give me 1, 4, okay, 4 minus 3. I mean now. That's minus 3j. 4 minus 3 should be minus j. I mean now. And this one here is going to give me, this is going to give me 9 plus 2, 11 minus 11k. Yes? It's 11 now. It should be 11k. How is it down? Okay. Okay. No. Okay. Let's look at the divergence now. This time around, I think everything I've been doing since mine was graph. Let's look at divergence. Okay. Let's take this question together. So we said that if v equals to x squared zi, how together? If v as vector v is equals to x squared zi, if v equals to x squared zi and as x squared zi minus 2y cubed z minus 2y cubed z squared g, z squared g, that is, okay, let me write it to make it easier. Okay, let's look at this question, which is v is equals to x squared zi minus 2y cubed z squared j plus x y squared zk. And the question asks us to find this del of v at what? At this point, at what I have 1 comma minus 1 and what, and 2. Okay, so let's look at this together. What would this symbolize? This is symbolizing our what? Our div. Yes or no? Okay, so this is symbolizing our div. So this is symbolizing our div. Let's now take div. Div is equals to partial x I plus partial y j plus partial z k. Everything here. Then where's my v now? So I have x squared. No, this time around it's not like this. I have a dot product in between, which is what? X squared z I, then minus what? 2y cubed z squared j, then plus what? xy squared z k. I mean, now let's do it together. So from here, what will I have? Okay, this is del. Okay, let me just put it on top here. Del dot what? Dot v. Are we now? Okay, so from here, so I and I together, right? We have partial x multiplying this one, which is what? X squared z. Are we together? The next one is what? Wait, I'm coming. I'm not done here. I'm looking at only i's together now. Are we now? I and I, then plus j and what? J. Have partial y, the bracket, minus 2y cubed z, abi, z squared. The next one plus the next one here, partial z into brackets x y squared z. And from here, so let's look at it. So from here, what do I have here? 2x z. Then what do I have here? Minus. Would it be okay? Yeah, minus 6 y squared z squared. All together. Then plus x y squared. Yeah, plus x y squared. But they asked me to find it at the point. I mean, now, where is the point now? At this 2 open bracket 1. This is 2 minus 6 open bracket minus 1 squared. Then what is z now? 2 squared plus 1 minus 1 all squared. And from here, if you open the bracket, you open 4 minus 6 open bracket minus I squared. Abi? Or let's just open the bracket 1. This is going to give me minus 19. Yes or no? Abi, no? Minus 19. Good. Okay. All right. Okay, I think we did something similar to something. Okay. Okay. No, do you know what the solenoidal vector is? The solenoidal vector. Solenoidal vector is when your div of a vector is equals to 0. This will give you solenoidal. I think I wrote it sometimes. Here you go now. Now let's. So when, yeah, thank you. When curl, yeah, this is curl of a vector equals to 0, then you have what? Conservative. All together. Okay. Conservative. So from here, yeah, let's look at this question. So that I should prove that this fine boy here is prove that this one here, which goes to 3y4 altogether. t squared I plus what? 4x cubed t squared j minus 3x squared y squared what? K. So now I actually show that this one here is what? Is solenoidal. Solenoidal. Now what do I mean by solenoidal? That means the div must be what? Must be 0. That's for the div. The div here. So that is, yeah. This one is called like something curl, call, yes. So now this v here, so this is the file which is partial xi plus partial yg plus what? Partial zk. Are we together? Then so from here, then what is this one that I have here, which is what? 3y4 t squared plus 4 s cubed t squared. I think this is I, this is j, and minus 3x squared y squared k. Are we together? And div here. So if I'll take this now, I can have partial x of what is I here? 3y4 t squared. No, I, it should be I plus I. Plus the next one is what? Partial y. What will be the next one? X cubed j t squared. I mean now, there's no, wait, and again, sorry, for this, okay, I'm still writing it actually. Then, plus what? Partial z. Everything here should give me minus 3x squared y squared k. Abi? Everything is constant here. So from here, let's now start differentiation. This one will give me what? 0 plus 0 plus what? 0. Everything is 0. So hence, our vector is solenoidal. Which one? Oh. Okay. This one is a yeah, close with, I'm coming. I'll remember. If I remember, I'll tell you. Yes, if I remember, I'll tell you. It's inside the course too. We'll do this in 301. But if I remember, I'll tell you. That's a name. I've forgotten. Skipped my mind just now. Okay, another one. Well, if you are done with this one, we are tired, you know? Yeah, I think it looks probably more of like a closed curve. It's more of like a closed curve. Yes, it's a closed curve. A closed curve. Okay, want to show you a proof. Yeah, now want to simply show you a proof. I want to show you a proof. Now this is the proof I want to show. Which part of the board should I claim? This part. Okay. I want to quickly show this proof. We so from here, let's say that I want to look at want to prove this. I want to prove this. I want to show that this thing that is here will give me what is here. I think the only issue that I might have here is I will find a way to how can I square this side here. Okay, well, let's look at it. Let's look at it critically. So from here, imagine that we are not given anything. Let's prove it together, please. So let's pick out this term, which is del multiplied by what? Del v. Are we together? Okay. Now before we start anything, let's start with what? This one here. Del file. Now for del file here. Okay. For del file. Okay. I know that for del file, what would the file look like? The file look like this. Partial x file. I mean now I plus partial file partial y j plus partial file partial z k. Yes or no? Okay, this is what will happen. Now what will now happen? So if I have this, so what if I now have? Okay. Now how will we even meet it? Okay, let's say that for example now I have I partial x plus j partial j out together plus what k partial what z. I mean now y. Now the dot product of what is here. So the dot product there. So what will that give me? That'll give me partial file. How together? This is what we have. How together? So from here, the dot product means I multiplied by I. I be now. So dot product means I multiplied by I. So from here, this is I, this is another I. So by the time these two multiply together, I can have what? Partial square file over what? Partial s squared. That's what we are going to have. Have you now? So, and now let's now deal with what I have on the right hand side. So this is the left hand side, have you? Huh? Okay, z square. Let's now go on to the other part. Okay. For the other part now. So from here, let's look at it. So So from here, we have to look for what partial square look like. Are we together? Partial square here will also be the same thing as what? Partial project. So I think to prove this, let's go. So from here, this one here would be what? What would this one be? It will be open bracket I partial x plus j partial what? Plus k partial what? Z, and everything what? Squared. Have you know? And at the end of the day, I think I will have I times I last, which might be partial about what? Partial x plus partial over what? Partial y's, and like that. Okay, and plus partial squared. Wow, no, partial should number. Okay, it's x, y, z. Okay, then everything. Okay, and everything I multiply by your words, by your 5. Then at the end of the day, I have what? Partial square 5, what? Partial x squared, or partial square 5, over partial y squared, plus partial squared 5, over what? Partial z squared, which is the same thing as what I have gotten in this format here. Yes or no? Yes, sir. So that means this proof here is what is valid. Do you understand, please? Okay. Can I clean this part? Okay. I'm ready for that look. I think you're getting the hang of this stuff now. Okay. Let's look at this thing step by step. Let's look at this. Let's look at some exercises step by step. Let's have some exercise step by step. Okay. So from here, u equals to I'll be alright then. Let's get all of these ones here. I said let's look at it. And the only thing that makes it look a little bit difficult is the fact that you are dealing with now. You're dealing with call of a vector. Abi now. And call of a vector is unlike the div of a vector where you can just complete the dot product and before you know it you have done. The call of a vector is when you are dealing with cross product. I guess what I'm trying to say, yeah. Cross product. And no, it's not a call that will be equal to 0. It is the conservative force that will make call equals to 0. Call in necessarily says no, if it's not 0. You know what I'm trying to say, like that. So probably should take a mini test on what the call look like, right? Let's say that I said you had u which equals to 2xi plus 3yj plus 2k. I have to find curl of a vector. What would this one look like? First thing, you first judge you by let's look at this now. I mean, no. So this actually look like. No, I'm not solving number 1. I want to give us a look on how call of a vector will be. So this I just created something that somewhat of an example on the board. So from here, the same way you do your cross product, the same way you do this one. The only difference is that this time around you are getting it as an answer, and I look as if the person that they said that is scrutinizing this thing is strict. I don't know. Let's go together. Then what do I have here? I have I. I go together. Then have I. Then okay. So what will happen here? Then I think I will have what? 2 partial y out together minus 3 partial y out together. I mean now this times this, okay, it's 3y let's write it very well. Partial z. The next one is minus j. Now what will be j? Everything here and everything here will go. And you have what to be 2 partial x, and subtracting what we have here minus 2x partial z. I'll get one trying like that. And plus k. What will k be? And 3y 2x. So just like you see that is just like your normal vector. Have you now? So no, it doesn't really make any sense to any of us now because you can't partial y incomplete all of these things. But so this is how the code of a vector would look like. Let's have number 1 then. Can I clean that part? Okay. Okay, let's start. The first thing I have to do with number 1 says that you want to find u cross partial file. Abi now. Let's do it together. Fine boy. And the first thing that we need to find here is what? Let's write the file. How together? So where's my file there? My file is xyz. My del file in this case. So we have file equals to what? XYZ. Yes or no? Now don't forget that del equals to I partial x plus j partial y plus k partial z, right? So now let's nail this. So what does this one look like? So this one here will now look like this: I partial x and plus j partial y plus k partial z. I mean now. And from here, let's open it. Don't forget that everything is multiplied by what? X, y, z, which is what? Your del. I mean now. If you put this one inside this place, then what will I have? I will have partial x representing student. Are we together? And plus, if the I think would that be 1? Let's just write everything now. X, y, z. Are we now? Then j. Let me put I here, and j, which is what? A fraction of what? Of x, y, z, and plus k, which is what? Partial z, x, y, z. Then so measuring with respect to x, what will I have? Y, z high. I was getting plus what do I have there? X, z. Well, last. Abi now. Abi j's plus x, y, k. I was gonna. And that means I've gotten what you call now. I've gotten the phi. Abi now. Next is not gonna cross you with it. Why is you? Use. Okay, before I put you here. Use equals to what? I z squared high minus 3x z squared plus 2x y z k. I was together. Now, I want to find it with what? So, you create I, j, and k. So I have yz square. I mean now minus this j. Add on to 2x y z Then what's this one here? This one is yz plus xz plus what? xy. I think for me, we can open the bracket. I have I. If I open the bracket. I'll open the bracket. That will give me, yes, minus 3x squared yz. Then the next one here will be what? We are not done with the first part. This is the only part it picked. Then that will give us minus 3x squared yz minus 2x squared yz squared. All together. Then the next one is what? Minus j. And what is j? This and everything down here. Which will give you yz squared. No, it's not yz squared now. Everything and everything will give you. So this one and this one will come. It will give you. I have x, y squared, z squared. Yes, minus this. I've done this. I'm left with this, which equals to 2x y squared z squared. The next one here, plus k. So from here, so what do I have here? It is 2. So I have x xz no xyz cube. Are we together? Xyz cube plus 3x z square y. Are we together? I don't think there's anything we can do to this one again. Is there anything? Factorize with my boy. You answer like that. Abby? Alright. Yeah, how do I write it? Yeah, write it now. This is the one I just wrote now. Okay. Okay. So, what's the next question? You cross there, Abby? Abby now? Let's start. Number 2. You cross there, so what's your deal? As partial xi, then plus partial y j plus partial z k. We know what my u is now. Let me write it. So from here, my z square I minus 3x z square 2x constant. I'll take it now. I've been now. Okay, let's continue. So don't forget what's here? U. So I have what? Yz squared minus 3x z squared What do I have here? X, Y, Z. Then next one is your del. Oh yeah. How to get that, please? How to get that? Is that what we have? Okay, let's continue. And continue from here. You have I, which you gave me. So what do I have here? I will leave everything here is partial z over minus 3x z squared. Then minus, I will with this and this, so I have this minus 2xyz partial y. Then minus g this j and this j y squared minus 2xyz please let me check, please. Let me check. It's correct. No, okay. Oh, well, okay, half. It's everything here. It's Q, which is partial y. Partial x, I mean. From here. So from here. From here. So what do I have here? Z. So minus y have we? No, y now. Maybe this is it. I partial now. Partial y means I want to know y. This is z. So that will give me, what is that going to give me? 2xz. Yes. Okay. I can do it. And let's continue. Have I this? Okay, let's move on to j. Minus j. What would j look like? So differentiate this with respect to z. So I have 2yz. And with respect to x minus what? 2yz again, right? Then plus what do I have here? K here. With respect to y, but I have z squared minus. With respect to x, what do I have here? 6 xz squared. How to get down? Hmm? Is that an issue? Wait to. Wait, is Z having square? Wait. Minus 3Z square. Abi? Then from here, open your bracket. I don't think, is it openable? If you open it, you won't change anything, Abi? Mm-hmm. That should be my words. No answer. I've done two together now. Okay. Not submitted. Yeah, hold on writing, please. Hold on writing. Okay. I've done this, right? I'm done on number 2, Abi. So let's move on to number 3. Wait, they said that, what's his name? Vector product is not but commutative. Abi now? So, since it's not commutative, so let's start with the first one, inside. I think, I hope you know that that is going to give me I, J, and K. That'll give me I. So I will have partial X, partial Y, partial Z. What is my U? YZ squared minus 3XZ squared plus 2XYZ. How to get down? So everything. So I have partial Y. Put it together. So plus so this one and this one will go. Abi now. So from here we have Abi now plus K Happy now? Please have a following, please. Let's do it together. So, apart from function that would leave, another one that we had, so I have I, which is a better to write it as X Z I. This one will leave. With actually, that this one does not have squared here now. Okay, with y here, it has squared now. Okay, so that will give me what? Minus 5 z squared q. Are we? Okay. I'm together. So, the next one do we have here? Let me check the question, please, properly. Okay. So, and I can this part. I think we have done this one. Happy now? With, do we cross it with V? With, cross this answer with V. Let's do that now. So, everything here multiplied by what? By V. So my cross product here. That's I, J, and K. That's my I. Then 0 minus 5. Is that square? Okay. Wait, I'm coming. For what? For you having? For V, okay. 4Z. Z. Minus xy. Okay. I have I. This is 6, Abby? I know, 0. That means one is left, so I have. Okay. And it's 0. I don't know. B plus is minus J now. Minus J. Okay. Yeah. Then what's the last one? Number 3. $32. So we plus K now. Okay. Okay, Z square. Okay. I think so. So that's from the brackets. Opening the brackets here, what do I have? I think, is there another special thing for us to do to it? So from here. Okay. So what do I have there? So I think I have done this, and I think this was what I had. I heard that I heard about it. I don't know. Have we done this multiplication? Yes, we did. I think that's the first thing I did here. Xi plus 4z j man is wait. Why this one here? Okay, minus xyk. Once you do the dot product, have you? So this one times this one dot product, you give me what? As 8x squared z. And this one does not have a g, so I leave that. Minus what? 5z square z square. Have you now? Hmm? 8. 8 times 3, okay. So I'm coming, give me a minute, please. This is what I have. Then I'm taking the dot product of this with the tabby. I can have what? 24 x squared z. I don't have a g, right? Minus 52. Have you now? Okay, take care of Wait, this is it. What's bad? So plus 52 x y z z square. Okay. Alright. Okay. What else are we looking at? No, we can't finish. When is this supposed to end? When did we start? 2:20. No, it's not 5:20 yet. Okay. Okay. So we treated a lot of questions on the vector differentiation and integration. Have you now? Hmm? We said a lot of questions on it. So I don't think there should be anyone by now that doesn't. I shouldn't be able to do the call and the vector and all of this kind of stuff. Have you now? Okay. Let me give you assignment. Yeah. Yeah, let's start. One. That's right. Assignment. We did the job. When that's why did you? Agree? We did the job. Hand up, Joe. And then more room me. That's not beg. Fine boy. 5 don't knock. You go house. Alright. So I am to take part that. So fine boy, stand up. Nobody should sleep. So let's take assignments, please. Nobody should sleep again. Nobody should sleep again. Nobody should sleep again. Say I want to sleep here. My big daddy, my son, and I'm more coming. All right. Now let's find the color of the following vector. Nobody is sleeping again. I will not sleep again. Nobody should sleep again. You see that in my phone, they are sleeping. Alright, let's start. Now, if I need a ledger. So if u equals to I think we've done that one. Okay, next vector r equals to x cos z. Yeah, vector r equals to x cos z I. X cos z I. Are we together? Plus y log xj. Plus y log xj. Minus plus z square k. Minus z square k. But you find the color of that vector. That's one assignment. You need for the color of the vector. Number 2. Yes. Prove that. Okay, I think we've done a little bit of proving now. Okay. Show that the following is a solenoid vector when n equals to 2. That the following is a what? Solenoid vector. I'm making it illegible. Oh God. Alright, let's start. I said that. Show the following. Are we together? Now show the following is a solenoid vector when a equals to 2. Oh yeah. Let's start please. I'm back again. Yeah, I said that show that v is equals to show that v is equals to, are we together? 3 plus question pada ni. Show that v is equals to 3 plus Baladida. How can assignments? Show that v is equals to x plus 3y close bracket I. Are we together? Plus y minus 2j. Show that v is equals to x plus 3y close bracket I plus plus y minus 2j. Y minus 2z close bracket j plus x plus az x plus az close bracket k. Solenoid vector when a is equals to 2. Solenoid vector when a is equals to what? When a equals to 2. I can play a perfume you. The next one is that so that v vector v. On a more serious note, it's already 5 now. Abba, let's see more now. Abi now. We're going and G journal. Now, show that vector v, which is equals to, or better still, instead for you to show, find v dot v. How would they wrote here? Find v dot v. If v is equals to, find v dot v if v is equals to find v dot v if v is equals to find v dot v if v is equals to fucking soon. I'm not soon. Let's go on. Find v is equals to what? Sorry. Okay. Find v equals to that's xi plus yj over x plus y. Xi plus yj everything all over x plus y. N over x plus y. I want to look for that. That's happening like that. Yeah. That's happening like that. And I still have a lot of stuff to do. Okay, if you, another one, if you u is equals to s squared z, if u is equals to s squared z plus exponential y over x, that is e raised to power y divided by x all together, and v is equals to all together 2z squared y minus xy squared minus xy squared. Find del u plus v. Find del u plus v. Find del u plus v. Del open bracket u plus v close bracket. But tell on me. Equals to del u plus v close bracket number 2 a cross del phi I'm joking. I don't know the way. I'm sure I'm going on here. I can't go me. I'm sure we still have time. She will. I continue. About it in. Open book and let's continue. I can't stop now. You can't stop now. I've tried. I've been now. We should stop, but we are not stopping now. We are stopping, but not now. And leave the money. I some many multiple. See that one did not have A. And leave the other part. So we'll talk about the U and all of those kind of deals, Abby. Okay. What else can we briefly talk about? We have to talk about something now. If we don't have, we have to find. Yes. Yeah, the integration step. I say it's the closed surface. The closed surface. Yeah. I did not finish 309 before. Yeah. I just had to check that briefly. Briefly. I think that will open our eyes more. Have you know? Do you have mastery in this one? The bathroom did you have mastery on this one? One material for major. Please look for material. Let's quickly run. Let's run 309 again briefly. Yeah. I didn't know. They play my phone. I was familiar to go. No. I no. I don't want to do for real. Gamma beta. Let's talk about gamma beta. I started it. No half. It's not far. If you can quickly go and bring your phone. Okay, I'm coming. Wait. I'm coming. Wait you. 7% is going only. Let's do 9 time. I already said. Like it's loading. Let's load it down. Okay, bring it. Let me just quickly run that one that we not finished before. I mean no. Yeah, 210. One 10 plus 17. I'm coming on, please wait.
Loud and clear.
Okay, good. Go on. Okay, let's start. Can I clear everything on the board, please? Okay, let's start. We'll soon be dropping. I get it, man. Soon be dropping. Ready? Let's start. Good. Soon be dropping. Let's get us start. Can you last us? The phone. Can you last us? We'll still be talking under the umbrella of 301, but it's not 301 I want to discuss. Yeah, unlock your phone. So, yeah. So, that we defined something earlier on, and we said that whenever we had something that looks like this, it was supposed to give us the meaning of something that looks like this. Are we together? S to the power of n minus. You see now, what I was trying to tell you the other time, minus x dx. That the first time I wrote it, it was written in terms of t, right? Now that's why I said that it is not good that you have to put the formula in the head. Okay. And from here, So there are some formulas we have to deal with now. We have to note. First of the formula is that gamma n plus 1 equals to n gamma n. I think we proved this one. And the next one is that gamma n plus 1 equals to n factorial. There's another formula we have to prove. Well, you get to use this more when you're dealing with fractional power. That one on top, you get to use more when you're dealing with fractional power. Let's get them. So let's take some integrations. I want to integrate infinity 0 exponential minus x squared dx. Let's look at this integration. Take this phone that is in your hand like this. Let's look at this integration. From this integration, I can say that let u equals to, what do I have here? X squared. How is it now? If u equals to x squared, what do I have? I have du equals to what? 2x dx. Have you know? I say that dx equals to du over. I get me what I've been please. And so from here, what can I have? Can I have integration of what? Infinity and 0 multiplied by what? Expression of minus x squared. All of this minus x squared is equal to be mid-scale dx du over 2x. Have you now? Okay, good. So from here is 2x. Abi? From here, you realize that I can have 1 over 2 integration over infinity and 0 and what? X minus 1. Are we getting it? Multiplied by what? Du. Yes or no? Okay, good. But here, do you know I said something here? I said that x here is, you said u equals to what? Is x squared here. So, and here you had the life 1 over, I think you did over use infinity and 0. I'll get one pencil like that. You see what I'm doing? What I'm doing is that this here, see the same thing as this, and I just brought my half outside. And from this place here, now I want to try to compute x here. Thank you. I can have from here 1 over 2 integration of infinity and 0 x raised power minus 1 e raised power minus u du. Yes or no? Yes or no? Don't forget I said that u equals to what? Equals to x. So that means I can say that square root of u equals to x altogether. So from here I can have 1 over 2. So from here I can do, what is my u? So square root minus 1 minus u du, and here I can have 1 over 2. What did I do here? Don't forget that here I add u equals to what? X squared. And from here I square root of x squared here, I have what? Square root of u here. Yes or no? So here I had x squared minus 1. And this x squared minus, I can substitute u here, which will give me square root of this. I mean, no? Now, I want to try and compare and contrast this one here to what? To a gamma, to a beta function. To a gamma function. That's what I'm trying to do. I want to write this one in such a way that the answer I will have will be what? A gamma function. I saw this question somewhere. So, it came to me and I felt like less solving it. That's what I've done to this extent now. So, and by experience, you notice that with this that I've got in here, I've written my equation in a way that is similar to my gamma function. Yes or no? If I compare both sides, what would I be having? I have n minus 1 equals to what do I have here? Minus 1 over 2. And n equals to what? 1 over 2. I'll get some something like that. That means that everything here as reached was Hilda Bassi. Are we together? Are we together, please? I have 1 over 2. Everything here is the same thing as talking about gamma what? Gamma half. Because everything here, by the time I'm done with everything here, if I compare this one and this one to each other, you find out that they're the same thing. Yes or no? So for me, I can say that my n here, my n minus 1 equals to what? Minus half. And from here, I can say that my n equals to what? Half. Yes or no? This n equals to half. That's what it means for me. Yes or no? Yes or no now? That's why I can turn everything that I have here to what? To this. And gamma half as like I had. Gamma half here should be square root of 4 over a billion. I think. I don't know, I'm not sure. But do you get this? No, it can't be 4 over b. Square root of pi over 2. That's the answer. Do you understand? So let's write that down. You can write it down. There's some scenarios whereby you can be given integrations and you'll be asked to express them in terms of what? Of gamma and beta function. Now that part is very, very common. This is to bully students. I'll get one advantage like that. I'm waiting for you. I wish I had more questions that I could solve, right? You have a time phone, have you? Help me with the time phone. Okay, I was going to give him that.
Gamma minus 4.5.
Thank you. It's a question one later. So much just credit, huh? I think question Charlie. So, what did I actually find? Gamma what? Minus 4.5. This is where you now use this formula a lot. You use it a lot here. And they didn't do what? This gamma 4.5 can be written as in terms of 1 plus something. I mean, let's say 1 plus x. And you are giving reports to your x, comma x. The thing that there's just a report here. There's a report that you write. But basically, there's a way you can work out. The thing is that, for example, in this formula, you know that you had gamma minus 4.5. Abi? Now from here, add 1 to it. So if I add 1 to it, so I have gamma minus 4.5 plus 1. I'm serious. Minus square 4. I'm telling you. That thing. How to get that? So let's see. So minus 4.5. Just add minus 4.5 plus 1. And this one will give you what? Square root of what? Minus 3.5. I get it. So from here again. So and from here you cannot have gamma 4.5. You have shifted your attention to gamma and you get my pencil there. Yes, sir. So from here, then I can now move gamma minus 3.5 plus 1, or better still, yes, plus 1, which will give me what? Gamma minus 3.5, right? I be now. Yeah, how? Minus 3.5. 3.5 gamma 3.5. Yes or no? Be now. Can walk. You can keep on walking like that. But the key is here. The key is here. I get my pencil like that. The key is here. So you can consider like this again. So you keep on doing until you get to what? Gamma negative half or gamma half. I didn't know that gamma negative half is equal to half gamma half. Okay, let's break this one down. So for me, I have this. Let's do it together. So that give me what? Gamma 3.5 minus 3.5 or minus 3.5. Yes or no? And for me, gamma minus 3. Plus 1. So I have gamma minus 2.5 minus 2.5 minus shall we get something, please? I'm just adding 1 to it. I'm following this formula. I'm adding 1 to it and I'm following the formula. Minus 4.5 added 1 to give us minus 3.5 gamma what? Minus 3.5. And from gamma minus 3.5 added 1 to it again to give us what? Minus gamma 2.5, gamma minus 2.5. Continue again from here, gamma minus 2.5. That I'm multiplying square root. Plus 1. All I have here minus gamma 1.5. I got 1.6 like that. Minus 1.5. The last one again. Gamma minus 1.5. So plus 1. So that will give me what? Gamma minus 0.5. Join. Then from gamma minus 0.5 here. Going to minus from here. And this one here, when I give you gamma minus gamma is 0.5, because if I had 1 to it, give you gamma 0.5, you give me 0.5 gamma 0.5. If you look at it from here, just keep on adding 1 to it until you get to what? Gamma 0.5 here. I guess I'm trying to do that. So from gamma 0.5, I hope you know that gamma 0.5 is the same thing as what? That thing on the board there, which is what? Square root of pi over 2. I'm getting it. From there, you can now start substituting. From the machine. So this one here will now give me, so I can have here to be, that's 0.5. Now, the collect money on gamma, have to be on gamma account from here, so that will give you square root of pi over 2. Then the washa share, washa man share long part of bench of it okay. That's how you do with gamma function. You understand? If I have another one, bring it. Let's quickly run it. Gamma 3.
Gamma 3, gamma 2.5 over gamma 5.5.
Okay. The fractional power too. So anything that has to do with fractions, this is the keyword to it. This keyword answer it. That gamma, what is that? Gamma 2.5 here. You break it down, probably subtract 1 from it. That will now give you, what is that? Gamma 2.5, you conclude gamma 1.5 plus 1. I mean now. Now gamma 1.5 for 1, then that one will now give you gamma 1.5, gamma 1.5. And from gamma 1.5 again, remove 1 again. You end up having what? You end up having your Nelson. I think I have someone that did that too. Already. So you got a branch like that. You can't get one child seven. Continue on. If you want to deal with fractional power, this is the key to the fractional power. You keep on writing it in such a way that you must add 1 to it to give the next term. Then, for example, gamma 2.5, as you said, gamma 2.5 is the same thing as saying gamma 1 plus 1.5. Then this is, if I take it here, then this will now give you what? Equal to what? 1.5 gamma 1.5. Then gamma 1.5 again itself can be written as what? Gamma 1.5 is what? Gamma plus what? I mean, you can write it plus 1.5 from Lolam Solom. I guess I'm trying to say like that. I get it. So this gamma 1.5 too. 1.5 is this as plus 1, which will give me what? So this gamma 1.5 is 0.5 plus 1. And from here you can now have your answer to what? 0.5 gamma 0.5. And from here you can now return it back to your original something here. Because 0.5 gamma 0.5 should still give me, I don't know, pi over 4. You get what I'm trying to say like that? You didn't get. Like what I'm trying to say is this. Let me make you understand. Let me get those down. Yeah, these are the 3 formulas that you use. But anytime you're dealing with fractional power, the basic thing you need for fractional power is this one. Now, for that example of the question that he gave me, I said he was looking for the value of what? Gamma 2.5. Gamma 2.5 can be written as gamma 1 plus 1.5. Yes or no? And whenever you have 1 plus n, this one is also equals to what? So that will give you what? 1.5 gamma 1.5. Happy now? Because of this 1.5 plus 1 again, I think they consider to be what? Gamma what? 0.5 plus what? Plus 1. And from there you can now what? Have 0.5. Then you can go and try so. I both want to mention like that. She gets me. Those are the things you used to work with. Gamma 0.5 are the things you used to work with fraction. For the negative. And that's formula of gamma 0.5. Square root of pi over 2. Yes, that's the value. I don't know. Did they not teach you how to prove it? Didn't teach you. Now they were supposed to teach you how to prove gamma half. Are you in class? Where are you in class? Some love you. I don't understand the basic stuff. Do you understand what I'm trying to say like that? Please. This is the most basic form of what of gamma functions that we can have. That one now, if you work it, this will be the lowest you go to. Gamma 0.5 to gamma 0.5. And from there you now start moving up. Minus 5, 10, like that. You get what I'm trying to say like that? Let that one again. Now beta function, yeah. I think I see a few idea on beta function. Beta function is, I think, give me the formula. I can't remember now. I think it's written by 1 and 0, x to the power of m minus 1, by 1 minus x half n minus 1 dx. Have you now? Yeah. And this beta function has how many ways of writing? A beta function has how many ways of writing? You can express beta functions in 2 ways. And express it in this way. At the same time, you can express it as a what? Trigonometric ratio. I can branch it like that. And also, if you have so the first way is this. The second way is this. Infinity 0. Is it infinity 0 now? Yes. So sine 2m minus 1 theta. I might not get formula correct too. Plus I think cos 2n minus 1 theta d theta. Is it like this? It's correct. Good. You see that you write it like this, or you write it what? Like this. And most of the times you can also write your beta function and you can also write your beta function in this format, in form of this as gamma. For example, if you have so as we're talking about diagram, I'm going. Let's have a cashier. Yes, this is what I wanted to write. That whenever you have beta m minus n is equal to beta n over beta m plus n. Formula is better because can note in here. Okay, it's 5 over 2. Sorry, this formula I wanted to note because whenever there are some cases that you might be solving some integrals basically, and those integrals might probably resemble this function. So if you resemble this function, what will you do straight up? You just move it here straight up. I got friends like that. Think I must show you. There are some cases, I don't know. Might be some differential equation that you might write, I don't know. That might probably solve our integration. And they will look exactly like this type of function. You don't have to stress yourself down to just what just put inside. So I don't know if you have any question like that. This have anyone there? You can even prove this with half. Let's see if you're going. But I go try negative and one number. Can Try one.
So negative upon. Negative upon.
I try what they can go now.
This minus 1.5. She plus 1 upon number.
No. You subtract, you add 1 to it.
Because what I'm trying to say that if you say 5.5.
No, like if you keep on doing like this one will keep on increasing.
So subtract 1 from.
Yeah.
That would be minus 3.5. Minus 3.5 plus 1. 20 was this one.
Wait, let me see. I'm trying to. No, I'm trying to see if there's another one I have to remember. There's some formulas I'm trying to see if I can remember for that beta function, gamma function that you can use for negatives.
Like this, I saw this one. I didn't know what it is.
I don't know. I'm coming now. Okay, I'm trying to see. I can't remember. There are some formulas you can use for beta that has to do with negative. I can't remember. I really remember, and it's me somehow. I can't remember it. Okay. Don't know. What is the general formula for gamma? This is it, Abi? This is it. Let's prove for gamma n minus 1. So what would I have here? I have infinity 0 x n minus 2 minus x dx. Okay. Then let's say I want to do product to v. Yeah, let's do it together, please. So I can say that u is equal to what? X n minus 2 dv is equal to what? Exponential minus x dx. Then the u here is equal to what? N minus 2 x n minus 1. What's it up? N minus 3. Oh, why can't I remember this formula like this? Oh, I can't remember. It's too much. Let me show you have there again.
Huh?
Let me show what you have there again. Your notes. I'll be happy. Okay. Now looking at ourselves like this. I didn't have material for me to use. That textbook is out of this country. What next is 309? Or 301, any of the two. I think we tried with 301 yesterday now. Now orthogonal function now, no, and represent that. Again. No, I pay anyhow. Eigenvalue gain functions. I've heard of it before. Yeah, I think I have. Eigenvalue gain function, but I can't remember where I heard it from. Eigenvalue gain function, eigenvalue. I can't remember where I heard it from. I can't. But series solution, shall I India? Series solution. Series solution. You understand series solution to some extent, at least. So. Did you get it last night? I want to see if I can work with something. I'm trying to work something out, but it's not coming. Oh, Jesus Christ, help me. Oh, it's not coming. It's not coming. It's not coming. It's not coming. Figure something out. It's not coming. You have it on your phone. You have it on your phone, Abby? Yeah, no, do you have it on your phone? I'll check something. Probably something on the book. I don't know. Yeah, have you seen this formula before? Have you seen this one? Isn't part of what you wrote? Hmm? Not there. Hmm? This kind of formula. I'm looking to see if it should be able for us to be to us to use that and link your textbook, but I'm not sure. I'm not sure. I'm not sure. I'm coming. I should be able to see something here. It's not here. I get materials. Huh? I hope you find the ones I can get. Probably the note I used before. I'll be getting those I used before on it. There you go. I've tried. I've tried enough. When I submitted the assignment, it will be around today. Probably another time during today.
That's in the night now.
Yeah, okay, it's also in the night.
We don't need the time to do it. But it should be in the night.
What if it's not in the night? 'Cause I want to go and look for a source to teach you guys. I want to go and help you on this course that you're doing. If you had that 309, basically. I have to go home and go and use my notes, my PDFs. All of our assignments. Just right. Where are you guys in 301? Where are you guys in 301? Where are you? Okay, it's about core. I've been that tensor analysis. I've been that tensor analysis. Tensor analysis. And then that tensor self. So you can implement that tensor. I'm a div and grad. Have you done this in class? But you say that's where you stopped. You div and grad. You say that's where you stopped in class now. Well, we have done call today now, so that should not be a new thing. So, I'll see when next we meet again. Yeah. So, I'll go and work on most of the courses. Probably I'll take a call through to some friends to get the notes you want to use. I think that will be possible now. I have to do that. It's better that so just giving up safe. Away, fine boy. Sorry boss. Should be going. I've tried. So probably if you want to so you want to do more practice like this, that one. So probably I don't know. I meant this have you done 3-1. I meant this have you done 3-1. What's the one? Amando, that go come. If it's that man that wrote it, he will use it. If it's the man that wrote it, he will use it. If the man that wrote it, he will use it. When it's not him, what's it now? So I'm not sure. Out of 309. Who is teaching now currently? No, 309 currently now. Oh, she's one now. That's very, 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 very serious. Very serious. Well, let me wake these boys. You can't sleep in his house. Anyway. Anyway. Yeah, go and say about them. Thank you very much. You can start sleeping. Alright, so please, so next time we meet, don't worry, next time we meet, we talk about, I give you my words on that, we talk about 309. This time will have been better. I don't have my materials with me. Once I send me personal. Wake up. Wake up. Well, so yeah, thank you very much, everyone. Thank you. I really appreciate. So we can start. Yeah. So thank you for everyone. Go and sleep at home. Thank you very much, everyone. You can. Oh yeah, another class about to begin now. The next class can join in. The last class we met, where did we stop? Let's continue. Let's pick it up from last class. Where did we stop? I know. Yeah, where did we stop in 205? Wait, I think we did some questions on exact now. Wait, did we not enter second order differential equations? Enter second order differential equations now. Abi? Alright, so let's pick it up from where we stop. Oh, before we stop, we just quickly take a brief recap on it. I think last time we met, we met twice or 3 times yesterday or today. And in all of those times that we met, we talked about differential equations, and we solved their orders. I mean, no, how many types of solutions did we provide? How many ways of providing solutions did we get? I think we got about 5. Yes or no? Separation of variable. And after separation of variable, we talked about what? Direct integration. So, okay, direct integration, separation of variable, homogeneous, and all of those kind of stuff. Okay, let's just pick it up from second order. So I don't know, most of us were not around, so let's pick it up from second order. From second order, we'll continue. So from second order, so I'll start by talking about the solutions to second order differential equations. So I'll talk about it. So first I wanted to mention is that come in. Okay. Now first thing, let's talk about the fact that they are written mostly in this format: a y prime prime plus by prime plus c y equals to what? Equals to 0. Are written in this format. That's number one. And number two, to solve them, there are different ways. So the first one would be method of undetermined coefficients. Variation parameters. So, as far as second order linear differential equation is concerned, so we have how many types? We have two types basically. Like there are two major methods of solving them. Although the higher you go up, the more you find out. But the major ones we have is what is method of undetermined coefficient and what variation of what parameters. So look at them one by one. So let's start. We're talking about method of undetermined coefficients. And under this one, there's something called an auxiliary there exists an auxiliary equations, and the equation is most of the time written in this format: y m squared plus pm plus q equals to 0. So, and there are three cases. There are three cases. Okay, am I right?
Yes, sir.
So, so this is the three basic forms of solutions we have. Now, and another thing I would like to tell you is that in this one here, in this method of undetermined coefficients, there will always be present a what? An auxiliary equation. It's always going to be present. You have to find it though. And if you solve your auxiliary equations, there are three kind of solution you are supposed to get. You are supposed to get either a distinct and real roots, which can later end up being written as this. You can end up getting a what? A real and equal root, which can either be written as what? As this, altogether. And the last one is that you can either get a what? An imaginary root, which follows this format and can be written like this. I will get one pencil like that. Let's solve some. Let's got these five exercises on the board. So these three exercises, so we want to name them and we want to solve them rather. And also before solving them, there's this friendly law that is advisable for you to learn, and that will be the a bit of superposition law. Okay, for 2-5 you might not have heard of it, but you'll soon hear of it, because it's a very important law that they must talk about before you start this course. I'm not talking about it today. Let's just delve into what? Solving differential equations. For the first one, y dx plus 15y plus 0. Let's get down. And from the first thing that I do here is that you see, let y equals to what? Exponential mx. It's like a law thing. That's the first thing you're going to do. You let your y equals to what? Exponential mx. And from this law, you can differentiate y prime, which will give you what? M exponential mx. Plus what do I have here? If I differentiate again, what do I have here? M squared exponential mx What's good up? So from here, substitute this back inside your equation. What do I have? I have mx m squared minus 8 y dx m exponential mx plus 15 exponential mx equals to what? 0. And from here, what is common here? Exponential mx. You have m squared plus 15 is 0. But note, exponential mx cannot be 0. But therefore, I can have 3 minus. What's good now? Then from here, you can now solve how many times? Solve and factorize. I think that's m squared minus 5 minus 3. And I have m minus 3. And it is either and here m equals to 5 or I would do that. So from here, since the solutions here are distinct from each other, what do I have? So I have y equals to exponential, no, 1 exponential ax plus c2 5x. Do you get this? So this one here, as it is. So, and again, another thing I want you to know is that the arrangement of the solution does not really matter. That's why I'm trying to say like that. So there are some cases you might have to put C1, like this one might be the first answer, this one might be the second answer. As far as CBT is concerned, it doesn't really what matter. You get what I'm trying to say like that. Good. Let's get number 2. So number 2 now. So as usual, write it. Square y dx squared minus then from here, let's deal with this. So from here, how do I do this? I consider y equals to what? Exponential minus exponential mx. And from here, let's see m exponential mx well, I put that here. Then that's 4 exponential mx 0 and exponential mx m squared minus 4 and 4 goes to 0, but by factorization, what would this give you? And for me, do you have any problems, please? Huh? What is the problem? I substituted the answers inside this equation. This m equals to what? 2 twice. So I'm getting m equals to 2 twice. So this is a what? A repeated shutdown. So I can say that the solution here is equals to what? Y equals to c1 plus c2x exponential 2x. I was get that, please. Let's start. Let's try mx. Alright, so substituting back, you have right. How's it done? Nope. Can be factorized. Okay, try it. I want to factorize this. You don't come up with a fraction, you'll be punished. Yeah. What is factor? Huh? Minus 2 plus or minus 3. Huh? Okay. Sorry, for those of you that are looking for factors, you can't get the factors. The factors here are not ordinary factors. And the factors you can just come up with in your head. I have to solve them using what? Your almighty formula. How many of us remember that formulas? Almighty formula. If you remember, raise up your hand. We are got the more than you go. Yeah, this one. Let's be some minor. From here, m equals to minus 4 Okay, can I clean this part? M here should give me what? Minus 4 plus or minus square root of what? 16 minus 20 or what? But Okay. 4 sorry, minus 4. So from here, m here should now give me minus 4 plus or minus 2I over 2. Then your m here is what? Minus 2 plus or minus I altogether. Then if you look at it, it follows this what? Follows this order here. So from here I can have alpha here is equals to what? What is alpha here? Minus 2, and beta here is what? 1. So follow this order from be written now, so I can have y equals to what? Exponential minus 2x exponential I'll get into it. Okay. You can have as many questions of this type as you can have. Can I clear this part? Okay. So from here, okay, we've done 2 examples on all of this. So let's push for more examples then. Okay now, that we can master. So let's push for more examples. So let's start with this. So what do I start with this first? Y equals to what? Exponential mx. The next thing here is that y prime equals to what? M exponential mx. Y prime is what? M squared exponential mx. So the next time I'm doing is substitute the 3 back here. So I have what? Y double prime, or better still, m squared exponential mx minus what? 8m exponential what? mx plus what? Plus exponential mx. So from here, exponential mx we can have m squared minus 8m plus 16 equals to what? 0. Then but exponential mx cannot be equals to 0, so therefore m squared minus 8x plus 16 give me 0. Then here you have m minus 4 all squared, right? Plus the 0. Can have m equals to what? 4 twice. Then what's your y here? So 1 exponential 4x. Did we get? Yes, sir. Yeah. I like this one. Huh? Okay. Okay, how about this? How's it going? Hmm? Okay, alright. I'm waiting for us on the writing. Shall we begin?
Yes, sir.
So here, y equals what? Exponential mx and y prime m exponential mx y double prime. Okay? And from this part here, substitute back here. Have exponential mx here, m squared plus m. Hmm? But exponential mx is now what? Equal to 0. Therefore, m squared plus minus 30 equals to 0. Have it together. We have m squared plus 6m minus 5m. So, we got m and I have m minus 5, m plus 6 equals to 0. Then from here, it is either m equals to 5 or m equals to minus 6. And your solution here is equals to what? C1 exponential 5x plus C2 exponential minus 6x. Okay, I think, how many have you solved so far?
That is
5. No. Nice. My friend, you came late today. How are you? Yes, still same thing, yes. What do I write in? Okay, let's write quick. If you have anyone sleeping beside you, help me wake the person up. Huh? If I have anyone sleeping beside you, help me wake the person up, please. I'm not allowed to sleep. Sorry, yeah? Can we begin? Okay, so now what will happen if you have something like this? Yeah, what if you have? Yeah, what if you have something like this? Yes, I know we are doing second order, but this time around, what will happen if you want to increase it by 1? Now you see the same process, the same way you differentiate, the same way you write your y equals to exponential mx, the same way stuff. So nothing changes. Let's start. So y equals to what? Exponential mx, y prime exponential max number 2 max and y triple prime m cube exponential mx. Putting everything back here now. Mx minus 2 plus 4 so exponential mx max cube minus 2 plus 4m minus 8 equals to 0. Now the thing is, how do you solve this now? Yeah, the two ways to solve this is that you use calculator, or you use a try and error method from polynomial. You keep on trying not to get one term, then use that term to divide it, then you get another term, and you simplify and factorize the other term. Is a solution. So I'll make it easy. You can find your calculators and tell me the factors of this. Yeah, anyone calculator? Yeah, anyone. Okay, we can pass it to the front, yes. Have you been trying to solve it, sir? So I think by the time I solve, can use any other method you know to solve. I have